everyone, welcome back to my YouTube channel. I am Riti and I'm back with a one-shot video on the entire SQL series. In this particular video, we would be learning about SQL from the very basic to advanced. We would be also solving some practice question on each of the topic so that we get familiar with the topic. So without any further ado, let's get started. So today we are starting a very new series on SQL. Now we were continuing the DBMS series earlier. SQL is also a part of DBMS. You can say the most important topic of DBMS. So I thought to make a new series on SQL and then we will combine all the videos which would be helpful in the DBMS series. So without any further ado, let's get started. So first we will start with re-revising some older concepts. What older concepts we are re-revising here are databases, database management system, types of databases, now why SQL is coming into picture and much more things. So firstly we will start with databases. What is database? So database is basically collection of data. Now consider an example of a student database. Now what do you think in this student DB? What all things would be there? So there would be data related to the student, right? So there are some data which is related to the student. Now coming to DBMS. What is DBMS? DBMS is a software application which is used to manage our data. So in the student database, there are some data which is present. Now what if I want to do some manipulation in that data? Consider that I am a student, my age is given there as 19, but tomorrow is my birthday and I am being 20 tomorrow. So I want to update my age from 19 to 20. So what I'll do some manipulation, I'll do some query which will be helpful in updating that data into the student database. So DBMS comes into picture there. Now understanding how a user interact with DB, or you can say database. DB is a short form which is used for database, and I would be using DB so much time in the video, so please don't get confused. DB stands for database. Now here is a user. Now user wants to interact with database, but would the user be able to interact with database directly? Just think once. No, it won't be able to interact with database directly, because again, as you have learned that if we want to interact with computer, or if we want to interact with machine, we need to interact with them using the binary language or the binary codes. But we don't know that for A what is the binary code, or for B what is the binary code. So we choose a programming language, we do the coding in that programming language, and that is then compiled to the machine code and which is understandable by the computer. So in the same way, if a user want to interact with database, he or she would be needing a software layer or a software application which would be helpful in decoding all the things student want to do a query or a user want to do a query, and that would be finally executed on the database. So basically user goes through a software layer, or you can say a software application is being used. So a software layer here is being used. So user adds some queries in that software layer or in that software application, and then from that software application user can query into database, do some manipulation and different things. So here what happens is that there is a user, he or she will use a software application. Now this software application may be using some programming language. And using this programming language, we will make some queries which will give us the required data or update or insert the required data. Now coming to databases. So database is a collection of data. Databases are of two types. First is relational database and second is non-relational database. In SQL, mostly we deal with the relational databases, that is databases which is in a tabular format. So relational databases are databases which use tables to store the data. So relational database mostly use the tabular format to store all the data. If there is a student database, that would be having a table which would be having all the details about the student. Now the examples of relational databases are MySQL, Oracle and MariaDB. Coming to non-relational databases. So non-relational databases are also called as NoSQL databases or NoSQL databases. Now what is non-relational databases? Databases in which data is not stored in tables. So in this database, that is relational database, data is stored in form of tables. But in non-relational databases, data is not stored in form of tables. There might be some hashing techniques or there might be some storage optimization techniques using which the data is being stored. And the most famous example of this is MongoDB. Now we are starting with SQL, but the very first question be why we are reading SQL or why we are knowing about SQL, what is the use of SQL? So we need a language to interact with databases. As I told that there is a user, he or she is using a software application, and using that software application he or she is interacting with database. Now this software application would be needing a language. you can say a programming language using which we can query into the database. So we need a language to interact with databases. So we use SQL to interact with databases and do some CRUD, that is create, read, update and delete operations on the database. Now you might have heard the term MySQL, and right now you are hearing the term SQL. So what is the basic difference between MySQL and SQL? So let's understand. MySQL is basically a relational database management system that uses SQL as a query language. So what is MySQL? MySQL is basically a relational database management system, that is a software application which use SQL, that is structured query language, for querying purpose. So SQL is a programming language which is used to query, which is used to perform CRUD operations on the databases. And MySQL is a software or RDBMS which is using SQL as a query language. So this is the basic difference between MySQL and SQL. Now in the further videos we would be knowing about the history of SQL, how we can make queries using SQL, how we can install SQL in our system, how we can make some connections, how we can install the server, how we can install the workbench and much more things. So firstly we'll start with the history of SQL, where this SQL originate from, who made this, and you have also heard the word SQL. Many people call it SQL, many people call it SQL. So what is the reason behind that? So SQL was originated in 1970s from IBM research on relational databases. So basically on relational databases, there is a querying language which is used, or there is a programming language which is used, that is called as SQL, which is structured query language. Now it started as SQL. So SQL stands for Structured English Query Language. So earlier it was named as SQL, which stands for Structured English Query Language, but later it was renamed to SQL due to some trademark issues. So many people call it as SQL, many people call it as SQL. Sometimes I also call it as SQL, sometimes I also call it as SQL. So both are the same things. It was just because of trademark issue the name was changed. So earlier the name was Structured English Query Language, and now the name is Structured Query Language. Now let's start with what is SQL. So SQL stands for Structured Query Language. SQL is a programming language that is used to communicate and manipulate data in the databases. So let's consider an example of a student database. So there is a college. In college, there are many students. Now consider that one student gets shifted from one place to another. So he or she may needs to update their address in the student database. So that updating or that manipulation of data is done via SQL. Now SQL helps user in performing the CRUD operations, that is create, read, update and delete operations on database. Now let's understand how SQL actually helps us. So SQL allows user to perform a variety of tasks related to databases. Now the very first point is retrieving of the data. Extracting precise information from a database through queries. So one can use certain queries to extract some information about a student. So what happens in class? We usually go to the class teacher or the class monitor and we ask that tell me the details about a person whose roll number is 42. I want all the details of that particular person. So he or she would be able to give me. But on a very large scale, if I ask someone to give me all the details about an employee whose employee ID is 123, so he or she needs to make a query into the database and retrieve all the information and provide it to me. Now the second one is manipulation of data or manipulating the data. So adding, modifying or removing records within a database can be also done via SQL. So adding some data, consider a new student's taken admission, so his or her data needs to be added. Modifying, consider a student is shifted from one place to another, so his or her address need to be modified. And deletion, consider a student leave the college, so his or her data needs to be deleted. Now the third point is defining the data. So creating and adjusting the structure of database, including tables, views and indexes. So there might be a possibility that we need to create some new databases. We need to adjust some values or some views or indexes in the database. So that also we can do via SQL. Now the fourth and final one is controlling the data. So managing databases access by granting or revoking permissions. So again, if there is a database of student, you can't allow anyone to make a query into the student details. There might be some permission which would be given to a person that yes, you can at least access the student data. You can at least access the teacher data. So there are some permissions which is provided to an individual, and there are some permissions which is also revoked from a particular individual when he or she leaves the institution. So all these controlling of data is also done via SQL. So this was all about what is SQL, how SQL helps us. In the next particular video, we would be starting with the installation of SQL. First, we would install the server and then we will install the visual tool, which would be really helpful for us to make the queries. So before starting with the MySQL server and MySQL workbench, I want you guys to know a basic concept. So in the last video, I told that there is a user. And if the user wants to interact with database, he or she will use a software application using which he or she can interact with the database. And in the software application, he or she can internally use a language which could be very easy for a user to interact with the database. Now in the last video we talked about SQL. So SQL is a query language that is called a structured query language, which is helpful in CRUD operations, that is create, read, update and delete operations in the databases. And we also talked about MySQL. So MySQL is a software, or we can say MySQL is a relational database management system. Relational basically means whenever the data is stored in the form of tables. So MySQL is a relational database management system which uses SQL, that is structured query language, for querying purpose. Now, have you ever thought that, okay, we are talking about the user who is making some calls to the DB, but where this DB is stored, where the DB physical existence lies? So DB is somehow stored in servers. So the first MySQL server here comes into the picture. So basically we need a server where our databases would be stored. So firstly we will install the MySQL server. So database server where data is stored, managed and accessed. So we will first start with installation of MySQL server, and then we will proceed ahead with the MySQL workbench. Now what is MySQL workbench? So MySQL workbench is a visual tool which is used for database design, development, administration and management. It provides a user interface to interact with the MySQL server. Now we have set up a server. In that server our database line. Now how we can make some queries, where we can write the queries. So we need a UI to write that queries, right? So there are two ways in which we can do so. So first is command line. Whenever we have established a server connection, we can use the command line to make databases, do some CRUD operations on the databases. But if you want a very neat and clean way, in the UI you are giving queries and you can see that tables are being created, some data are being inserted, so we can use a visual tool for the same. So in this particular video we would be learning about the MySQL server and MySQL workbench, like all about the installation process of the same. So firstly we will install the server. So first what we need to do is we will go to the MySQL official website, that is https://www.mysql.com. Then we will go to the downloads. Then we will select the MySQL community version at the bottom of the page. We will choose the MySQL community server. We'll select the version and we'll click on download. And then we will follow the instruction. Set the root password. Why this root password we need to set? So whenever you are establishing a connection on the server, you need to provide a password for that connection. So whenever you are making a new connection, like you are making 10 or 11 new connections, so you need to give that password to the server for you to make a new connection. So this password would be asked while creating a new connection. So let's see from the website itself. So this is the website for the MySQL. So here you can see, you can find this downloads tab. You can click on this download tab. And here at the very bottom, you can see MySQL community GPU downloads. That is the community version download. Now here you can find the community server as well and the workbench as well. The server and the UI where we will be writing the queries. So we will first click on the MySQL community server. Right now I am using a Mac OS. If you are using Windows, the configurations may differ. So you can see the configuration of your system and download accordingly. So I'll just download this DMG file. So I'll just click on download and I'll click on no thanks, just start my download. So it will just start my download. Earlier I have already downloaded this MySQL server. So this is the procedure you need to do. And then when you are about to install it, it will ask you for some permissions. You can just accept that permissions and you can provide a root password, which would be helpful when you are establishing a connection. And in the same way, you can go back and you can download this MySQL workbench. So here also you can give the operating system and OS version, and here you can click the download button. So both of these things would be downloaded on your personal laptop or computers. So this is the way we can install MySQL server and MySQL workbench on our personal PCs. So I already have MySQL workbench. Let me just show you how it looks. So here you can see that MySQL workbench has opened. Here we can put some queries. Here are some management instance and performance tools. Here you can see context, help and snippets. And here you can see the action, response and everything. From the next video, we will try to create some databases and tables inside the databases. So SQL commands are divided into different categories based on their functionalities. So according to the functionality, SQL commands are divided into different categories. Let's have a look. So the first one is DQL commands, that is data query language commands. So from the word itself, it's very clear, data query language. So any command which is helping us to do some data query, that commands comes into the DQL commands. The second one is data manipulation language commands. So any command which is helping me to do some data manipulation, like inserting some data, deleting some data, updating some data in the database. So all these commands are helping me to do some data manipulation. So that is why they are coming under the DML commands. The third one is data definition language commands. So again, from the word itself, it's very clear, data definition. So any command which is helping me to define the data, to define the structure of the database, or to define the schema of the database, all those commands comes into the DDL commands. The fourth one is data control language commands. Now again, from the word itself, it's very clear, data control. So any commands which is helping me to give some control to the data, like accessing the data, revoking the permission from accessing the data, or granting the permission to access the data, all those commands comes into the DCL command. The fifth and final one is transaction control language commands, that is TCL commands. So any commands which help me during a transaction, like consider that I am withdrawing money from ATM or I am making an online payment. So all those commands which comes into picture while doing a transaction in a database comes into the TCL commands. So these were all the categories of commands, SQL commands based on their functionalities. Now let's look about each and every command in detail. So the very first command is data query language commands, that is DQL command. Now DQL is used to retrieve the data from the database. So any command which is helping us to fetch the data from the database or retrieve the data from the database, that comes into the DQL command. Here you can see command which is used is select. So consider that I want to get the details or I want to fetch the details of a student who is in class 2 whose roll number is 3. So what I'll do, I'll make a database query in which I'll use the select command, and in that I can fetch all the details about a student who is in class 2 and having a roll number as 3. So this select command would help me to fetch the data or to get the data from the database. The second one is data manipulation, that is DML command. So DML is used to manipulate data stored in the database. So again, the same example, consider that there is a college database. In that college, a student takes an admission. So we will insert the data of that particular student. Consider that that student is promoted from semester 1 to semester 2. So that we need to update in the database. So updates comes into picture there. And consider that student has graduated from the college. So we need to delete the data of student from our database, college database. So we will be using this delete command for the deletion purpose. The third one is data definition language command, that is DDL command. Now DDL is used to define the structure and the schema of the database. So the schema of the database basically means, like whenever we provide a schema of the database, we give an overview like what is the database name, what all attributes or columns are there in the database, what is the primary key, and etc. things. So we basically provides a structure or a schema of the database. So the commands which we can use is create. Create usually helps us to create tables or create databases. Alter command. Alter command is used to modify an existing database or modify an existing table. Drop command. Drop command is basically used to delete the entire table from the database. Now truncate. Truncate command doesn't delete the entire table. It deletes the data which is present in the table. And rename command is used to rename a table. So all these commands comes into the DDL command, which is indirectly or directly affecting the schema or the structure of the database. The fourth one is DCL commands, that is data control language commands. Now DCL deals with the control and security of data within the database. Commands are grant and revoke. So grant, we are granting some permission. Revoke, we are revoking some permission. So again, we are taking the example of the same college database. Now in the college database, there would be student table, there would be teachers table, there would be some staff table, there would be principal, director, all those details in that particular tables. Now I, being a student, I can't see the teacher details or the staff details. I can only see the details about myself. Teacher can only see the details about the student. So we grant some permission or some security is there so that we can control the access of data. So teacher can access the student data. Student himself or herself can access only their data. So such type of commands which help in that purpose, like controlling of the data or security of the data, comes under the DCL, that is granting and revoking. The final command is the TCL command, that is transaction control language command. Now TCL is used to manage transaction within a database. The commands which comes into picture here are commit, rollback, and save point. Now why this TCL command comes into picture? So you have seen most of the time that whenever we are doing an online transaction, we do the online transaction, we pay the money, we give our PIN. The money is somehow deducted from our bank account, but the transaction is not completed. So in that case, what happens is that money is credited back to your bank account within 3 or 4 working days. So all those things, all that transaction which is happening inside a database, the commands which are helping us to do that transactions comes under the TCL commands. So this was all about the types of SQL command in this particular video. I hope you like this video. I thought to start with the creation of database, but first you need to know what does this create command means. In which category does this create command lies? So that is why I thought to cover these types of SQL commands first and then proceed ahead with other videos. So before starting, let's revise some older topics as well. So what is database? Database is basically the collection of data. Now database is divided into 2 types. First is the relational database, and second is the non-relational database. Now what is relational database? Relational database are the databases in which the data is stored in the form of tables. And all the tables have some relation between them. There is some interrelated data. What is the non-relational databases? So a database in which the data is not stored in the form of table, rather it is stored in the form of key value pairs or something else. So this is the basic difference between relational and non-relational database. As of now, we would be dealing with the relational databases. So consider a scenario. There is a user. Now user wants to interact with the database. How a user can interact with a database? So a user can't directly interact with database. What a user can do is a user can interact to the database using a software. So using a software, a user can interact with database. Now what this software is called? This software is called as DBMS, that is Database Management System. So any software which is helping us to manage our data is called as Database Management System. Now I told that we are dealing with the relational databases, so we would be using RDBMS, that is Relational Database Management System, for our purpose. So example of RDBMS is MySQL, which we would be using as a software. Now we have got the software, but we need to make some queries into the database. Like if I want to do some insertion, I want to do some deletion, I want to do some update in the values. So I have to tell the database ki, okay, this is the value I want to insert, this is the value I need to update, this is the value I need to delete. So for that purpose we use SQL, that is Structured Query Language. So it is basically a programming language which help us to make some queries into the database. Like consider that there is a new student which is coming into my college. So all the details about that particular student would be inserted into the database. Consider that there is a student who has left the college. So all the particular data related to that student would be deleted from the college. Consider that there is a student who has got his address changed. So that particular field would also be updated. So all these operations, like the manipulation operations like insertion, updation, deletion, we can do using this SQL programming language. Now coming to the database design. So what is this database design and how is this important? So consider a use case that I have been given, that I have to design a database for student. As of now, I know that I have to design a database for student, but do I know that if I design a database for the student, what would be the tables inside that particular database? As of now, I only know that there is a student database. I have to create that student database. But do I know that what all tables would be there in that particular database? What all domain constraints would be there for that particular table? Domain constraints you can understand in this way ki, okay, there is a field called as name. There is a field called as age. So age would be taking some integer values. Name would be only taking character values. Age is something which should never be null. So some rules should be there. So I don't know that what all constraints should be there. Then again, I don't know about the primary or foreign keys. So keys help us to uniquely identify records in a table. So I can uniquely identify a record for a particular person in a table. So I don't know about all these things, the constraint, the keys, the tables. Only thing which I know is I have to create a database. So in the database design, what we do is, whenever we are given a use case that we have to create a database, we are also provided with the schemas. So what is schema? So whenever we are giving any table name or the database name followed by all the attributes which is present there, we called it a schema. So here you can see that there is a student schema, right? With all the attributes which is there is student name, student roll number. Here you can also see that there is a teacher schema, which is having all the details about the table name, that is teacher, the characteristics or the attributes, that is table name and teacher ID. And here you can see that we are taking the database as school. So we have taken the database as school DB we have taken as of now. In the school DB, there are two tables. First is the student table. Second is the teacher table. Now when we create a table, there are multiple number of rows and multiple number of columns. So these are called as rows and these are called as columns. But in databases, we called columns as attributes or characteristics. So basically attributes are the characteristics of a particular entity. Like consider that there is a student database. Now that particular student database is having some of the tables like student course or student address details. So there are two tables in that student database, course and address details. So both of them would be having some of the attributes, like course is having some of the characteristics such as course ID, course name, like all the things about the course. And the address would also be having all the details about the address like street, flat number, pin code, everything, right? So all the attributes or the characteristics which is present, we insert in the column, and all the particular record about that particular student is inserted in the rows. So basically these all are the characteristics or the attributes, and this is the table name. So you can see S name, student roll number, teacher name and teacher ID are part of attributes or the characteristics of that particular entity or that particular table. So now we are clear that we have been given a college database or a school database in which there are two tables, student and teacher. Now in that student table there are some attributes, in that teacher table there are some attributes. So we have done a basic designing of our database. Now let's move ahead with the creation of database. So whenever we are creating a database, we create a database in a server. So what we do is, first we establish a server connection to create a database. So once we have established the server connection, we can create databases. Now the first question which will arise in your mind is, can we create only one database in one server, or we can create multiple databases in one server? So the answer is we can create multiple databases in a single server with a different name. Yeah, so the name shouldn't be same. With a different name, we can create multiple databases in a single server. So consider that this is a server 1. In that server 1, there are two databases, database 1 and database 2. So there are 2 databases which is created as of now in server 1. Now in databases also, the second question is, in a database, can we create only one table or multiple table? So the answer is we can create multiple tables in a single database. So you can see that there is a school database. In that particular school database, there is table 1 which is course, and there is table 2 which is fees. And in this hospital database, there is a table which is patient. So in a single server, there could be multiple databases. In a single database, there could be multiple tables. So this happens while creation of database. So when you have established a connection in a server, you can go ahead and create the database. In that particular database, you can create some tables as well. So there is no restriction on the amount of creation of databases or the amount of creation of tables. Now let's start with the creation of database. So there are some steps which we should follow while creating a database. Let's have a look on them. So the first step is choose a DBMS, that is choose a software. As I told earlier that if a user needs to interact with database, he or she needs a software. So we would be choosing a software. As I told earlier that we are using relational databases, or we are dealing with relational databases as of now. So we will be choosing a RDBMS, and that is MySQL for now. Now the second one is connect to the server using command line or a graphical user interface. So now I have installed the software, I have the software. Now I need to establish a connection in the server where I would be making the databases. So that I can do in 2 ways. Either I can go to the command line and establish a connection, or I can establish a connection using GUI or user interface which I am having in my PC. So mostly the command line is not covered here. So you can go ahead and have a look on all the articles which is presented, how on the command line we can establish a server connection, we can create a database or insert the database. The commands remain the same, but just there are 2-3 more steps extra. So the third one is create a new database. So there is a command we need to execute for creating a new database in the UI or the user interface which we have downloaded for executing all the SQL queries. Now the fourth one is, once the database is created, you can use the use statement to create tables in the databases. So again, going back, as I told that in a server there could be multiple databases. So how the server would know that if I want to create a table, in which particular database I want to create a table? So for that case, what we do is we use the use statement, use followed by the database name. Once I execute this particular query, my server will be known that okay, in this particular database, now what all actions are being done is being done in that particular database, like insertion, deletion, updation, anything. So I can use the use statement to tell the server ki as of now I am working on this particular database. And the fifth and the last step is create tables and insert data. So before moving forward with the SQL commands, I just want to let you know that SQL commands are super easy to understand because SQL commands are very similar to the English statements. Consider that if you want someone to create a picture of yours, like create a drawing of yours, what you will say, can you please create a drawing of mine? So you say create a drawing, right? In the same way, if you want to create a database in SQL, you say create database followed by the database name. So it's just like the simple English language which we use in day-to-day life. And whenever I say someone that create a drawing of myself or create a picture of myself, I'll just end the statement with a full stop. Here we end the statement with the semicolon. So it's just like a statement which is ended by a semicolon. So to tell the server or to tell the database that this particular command is being executed and the next command is in next line or whenever the next semicolon is found out. So we use the create database statement to create a new database. So we generally use the create database followed by the database name statement to create a new database. As I told again, it's very similar to the English language, like create a database. So create database. These commands are not case sensitive. So what does this case sensitive means? Consider that if I am executing create database followed by a database name, consider student. If I am executing this command in uppercase and if I am executing this command, the same command, what is happening? Okay, so create database student. So if I am executing this command in uppercase or in lowercase, both will give me the same result. So this is not case sensitive, like we can either use the smaller cases letters or the upper cases letter. So for now, let's go with the upper cases letter because there would be a notion we would be following for all the particular queries. So let's follow the uppercase one. So we will use this particular command, that is create database name. So let's go to our UI and let's learn that how we can create a database. So I'll be opening my MySQL workbench. So here you can see in MySQL workbench, by default, there is a connection which is established, but I want you all to learn that how we can establish a new connection as well. So we'll just click on this plus icon. Once the plus icon is created, we'll give the connection name. Just give it as SQL for now. And here we can give the password, which was asked while we were installing the MySQL workbench and server. So I'll just provide the password here. And once I have provided the password, I can click on OK. So you can see a new server connection is established here. So once I'll open this server connection. Now here you can see that there are many tools which is present. So let me just familiarize you with all the tools which is present and then we will go ahead with the query. So here you can see that there is an administration tab and here you can see that there are some of the instances and management status which is present. So this basically deals with our server connection if you want to make a new connection, if you want to end that connection, and other things. So there is a schema tab. In this schema tab, you would be seeing all the databases you have created, all the tables you have created, the primary key, the foreign key, the constraint, everything in this schema tab. By default, you can see that there is a SYS schema which is already present. This is of MySQL Workbench. So basically the database administrators have this already created to see the performance, how the performance is going. There is a performance schema also present here which is present in this SYS. So we'll not touch this SYS, we'll just create a new database here. And here you can see that there are some icons. So this icon would help you to create a new SQL file. So if you want all the queries to be in new file, or if you are creating multiple databases or working with multiple databases, you can create new files and work on that particular database. Here you can see that there are two run commands. Like if I am writing any query, I have to run it, right? So for that particular query, if I have to run it, there are two tools. So the first tool runs everything which is present in the file. Like if there are 16 or 17 SQL statements, it will execute all the SQL statements which is present. And the second one is run the selected one. So if I select any of the SQL statement, that only would be executed, not the entire file. So let's start with our first query to create a database. So I'll simply give the statement create database followed by the database name. As of now, let's give it school. And I'll just execute this line on selecting it, and I can use this particular run button. So here you can see that there is a success. So a database with the name school is created, but you won't be able to see it here. So to see it here, you have to do a refresh. And once you refresh, you can see the database with the name school is created. As of now, there is no tables in that particular database because I have just created a database. So in this way, we can create a database. Now, if you see here, I have also written it also to avoid errors. We can use this command create database if not exists database name. So why is this needed, create database if not exist? So let me just show you. So I have written this command create database school. Our database with the name school is already created into my system. Consider I am running this command again. So what it's showing? It's showing me an error that a database with the name school already exists. So what we do just to avoid errors, because errors are something which is like nightmare for developers. So just to avoid errors, what we do is we put an additional check that if not exist. So create a database if it does not exist. So we will use this query create database if not exist, and we'll give the database name. Now if we run the same query, you will see that you are not getting an error. Rather, you are getting a warning message that already this particular database exists. So if you want to create tables in that particular database, you can use that particular database. So right now we are not seeing an error. We are just seeing a warning. So it's better to add this additional check while creating a database. Create a database whenever there is no existing database with the same name. So create a database if not exist database name. So this was all about the creation of database. Now let's see how we can delete the database. So we use the drop database statement to delete a database. Dropping a database means deleting the entire database, including all the tables. So dropping a database means consider that you have a database of student. And in this particular student database, you have two tables. First is the course table, student course table, and second is the student address table. So once you use this drop database command, so what will happen? It will delete the entire database, including all the tables which is present in this particular database, all the data which is present in this particular tables. So it will delete the entire database, all the objects, all the values which is present in that database. So this command is not usually suggested, and if you are a developer, I would surely say that please avoid these commands and don't ever do this command or don't ever execute this command in the prod database, because like that would be a nightmare for you. So always avoid this command, but since we want to know how we can delete our database, this command is necessary to delete our database. So the dropping means deleting the entire database, including all the tables in the data, all the other objects within it. So drop is a DDL command, that is data definition language command. Now these commands are not case sensitive, as I told for the create command. So the command for dropping a database is drop database followed by the database name. So let's see about this command as well. So as of now, I have already created a database with the name school. So let me just delete this database. So I'll do drop database followed by the name, followed by the database name. Just done this. So you can see that we have got a success. So this database is deleted from our schema. So here you can see that the school database does not exist. Now again, in this particular slide, you would be also seeing that I have given also to avoid errors. So do we get errors while deleting that database as well? So the answer is yes. There could be a possibility that in the server there are many databases. You forgot that which database you have deleted, and again you are running the same command to delete that particular database which is already deleted. So it will give me an error. So what we do is we write a command drop database if exist. So the database should be existing, only then delete the database. If the database is not existing, do nothing. So drop database if exists the database name. So let me just show you again. So I have already deleted the school database. Let me again just delete the school database because I'm not aware that what all databases are there in my server. So by mistake I have deleted the school database, and again I'm deleting the school database. So if I again execute this command, you can see I'm getting an error because this particular database I have deleted just 2 minutes back, but I don't remember that I have already deleted this database. This could happen like if you have deleted a database 1 week ago, and after 1 week you don't remember that if I have deleted a database or not, and you run the same query. Or consider that you can also run the same query for a database which is not existing in the schema. So as of now, consider that there is a teacher database which is not existing in the schema, and if I run this particular command also, it will show me an error because this particular database does not exist in the schema. So to avoid such errors, what we do is we include this if exist clause so that it will check that delete the database if it exists in the server. So we will use this for the school only. We will use the same command. So drop database if exist, and here I give the command as school. So let me just run it again. So here you can see that we are not getting an error, rather we are getting a warning message that this student database does not exist, it's already deleted. So in some way we are avoiding the errors, we are just getting a warning messages. Now let's see that how we can use the database. So as I told that once we have created the database, there could be many databases in the server. So I have to tell the server that if I have to create any tables or I have to insert any data, which database I am inserting to. So for that we will be using the use statement. So use followed by the database name. We use the use statement to use a database. These commands are not case sensitive, and the command is use followed by the database name. So let's see. So again what I'll do is I'll create a database. Let's create a database college. So I'll execute this statement. So it's success. I'll just do a refresh all. So here I can see a college database which is created. Now what I'll do is I'll do just use, and I'll give the database name, that is college, followed by a semicolon. And once I run this query is also executed with a success. So now in this database only we can perform all the actions. So this is the use of use statement. Now let's see the next command. Now let's see how we can see the database. So showing a database, we use show databases statement to see all the databases which is present in the server. As I told earlier that in the server there could be multiple databases. Now I want to see that what all databases are there in my server. So what I'll do, I'll just execute this show databases statement which will show me all the databases which is present on my server. So let's use this command as well. So we will just do show databases, and I'll just execute this command. And here you can see that all the databases which is present in my schema is shown. Now again, as I told that SYS performance schema is something which is related to MySQL Workbench. The DBA administrator use it to analyze the performance and everything. But here you can see the database which we created college is already shown here. This was all about creation, deletion, seeing all the databases in the server. In the next video, we would be doing the same for the tables, like creating the tables, inserting the data into the tables, deleting the tables, and seeing all the data which is present into the tables. So in the last video, what we did was we created a database followed by the database name. Let's consider school. And then we used the database to create the tables or insert the data. Now third step, we do the table creation. So let's see how we can do the table creation. So we use the create table statement to create the table in a DB. So once we have used the database, we have told the server that this is the database in which I want to create tables. I'll use this create table statement to create the tables in the database. Now what is the command to create the same? So we give the create table followed by the table name, and then we provide all the columns which should be there in the table. So again, the table is an intersection of rows and columns. So columns tell me what all values should be there for a particular record. Okay, so consider for now we are taking the school database. Now in the school database, consider that there is a table student. So for that student table, there would be some columns, there should be some rows. So student may have characteristics such as student ID, student name, student age. So there are some characteristics or attributes which the student would be having. So we will provide all the attributes, all the characteristics in the column. Now the second one is data type. So whenever we create a variable in programming, what we do is we give the data type followed by the variable name like this, int a. So it tells me that a would only accept integer values. In the same way, we provide the data type for all the particular columns in the database, because there could be a possibility that if I don't provide the data type for SID, someone can insert XYZ into the SID, which is not a valid student ID. Someone can insert 1, 2, 3, 4, XYZ, which is again not a valid student ID. So I tell that this particular student ID will only be accepting values of the particular data type. So we provide the data type. Now the third thing is constraint. So what is constraint? So constraint is basically a set of rules which we provide to our attributes. So basically whenever we are giving all the attributes, we provide that these are the constraints which are there for that particular attribute. Now in the constraint there could be many things like not null. So if there is a not null which is provided to any of the attribute value or any of the column, that particular column couldn't have any null values. It needs to have some value. So why these constraints are given? Because it helps us to eliminate the duplicate data and the data which is misleading or incorrect data. So the insertion of incorrect or duplicate data is hindered whenever we provide the constraints. So creating a table. So create is a DDL command, that is a data definition language command. Now here the example is given. You can give create table followed by the table name. Let's consider a table name as employee. Here you can provide the first column, that is employee ID, the data type, that is int, and then the constraint, that is primary key. Again the second column name followed by the data type, that is varchar. The third column which is salary and followed by the data type, that is int. Again constraints are not something which is mandatory to provide. You can provide or you can't provide. Like it totally depends on you if you want like some unique values, some not null values in the particular column. Again right now you won't be understanding these terms like primary key, what is varchar, what is int. So as of now just forget all these. Just remember that to create a table, we give the command create table followed by table name and we provide all the columns which should be there in that particular table. So let's just execute this command in our SQL workbench. So this is my SQL workbench. Let me just start with creating a database, then I will create the table inside that particular database. So let's just execute the command to create a database. So it would be create database followed by the database name. Let me give it school. Okay. So let's just execute this command. So you can see that this command is successful. Let me just refresh it here. So our database with the name school is created. Now I'll just let the server know that I am creating all the datas in this particular database. So I'll just use school and I'll just execute this. So now use school is executed. Now I can create all the tables, all the data in this particular database. Now let's start with the creation of table. So I'll just give create table followed by table name. Let's just take the table name as course. And then I'll provide all the columns which should be there in the course. So let's take CID, course ID, and I'll provide the value as int. Let's take course name and I will provide the value as varchar and I'll give the limit for the number of characters, that should be 50. So let's just execute the statement. So here I've created a table with the name course which is having columns such as CID and having the data type as int, course name having the value as varchar. So let me just execute this. So you can see that there is a successful execution of this particular statement. When you will do a refresh, here in the tables, you can see that one table with the name course is created and the columns which is present in this table is CID and CNAME, which is the course ID and course name. So course ID would only be taking integer values and course name would only be taking the character values. So this is the way we create the table in our databases. Now since we have created the tables in the database, how we can insert the values in that tables? So inserting values into the table. So insert is a DML command, that is a data manipulation language command. Now we use this particular command to insert the values into the database. So that is insert into. We'll give the table name followed by all the columns in which manner we want to insert the values. So if you have provided a data like Raj here, so it will insert Raj here. And if you have provided the address as Pune, it will insert Pune here. So if you don't provide the column name, it will insert in a sequential manner into all the columns. But if you want to insert in like a different fashion, like if you want to insert the first value into the column 1 and the second value into the column 3 and the third value into the column 2. So you need to provide the column names here. So in whatever fashion you are providing the column names, it will insert the values in that particular fashion only. And here you can give the values value 1, value till value n. Now here we can see the example. So here we are inserting values into the employee table we have created. So we'll use insert into the table name employee and then we will give all the columns employee ID, employee name, employee salary, and then we will provide all the values we need to insert, like 1 Raj, the salary is 1200, the employee ID is 2, the name is Rahul, the salary is 1100, the employee ID is 3, the name is Riti, and the salary is 1100. So in this way you can insert the values into the particular table and you can provide all the values which needs to be inserted. Let's see how we can insert the values into our course table which we have created just now. So we'll just execute the command insert into. We'll provide the table name, that is course, and then we will provide all the columns. First one is CID, second one is CNAME, and then we will provide all the values to be inserted. So the first value, let's insert the course ID as 1 and the course name as physics. Let's insert the second ID as 2 and the course name as maths. and let's just execute this. Okay, just there is a typo, so it would be values. So let's just run this command. So once you run this command, you can see this success. So all the values have been inserted with the first course ID as 1, the subject name as physics, the second course ID as 2, and the course name as maths. So in this way, we can insert the data into our table. Now let's see how we can see all the values which have been inserted into our table. So we created the database, we used the database. In that particular database, we created tables, we inserted some data into that particular table. Now we would be seeing that how we can see all the values in that particular table. So to see all the specific values of a column, we can either use the select statement followed by the column from the table name. So it would be select the column name from and the table name. So the table name is and the column name is employee ID. So if I want to see only the employee ID details, I can just use the select the column name from the table name. And here to see all the values from the entire table, we can use select star from employee. So whenever I'll execute this statement, select star from employee, it will show me all the records which is present in the table. So let's use this particular statement. So what I'll do is I'll use select star from and I'll give the table name as course. And I'll just execute this. So here you can see that our table is created with CID, course ID and course name, where the values are 1 for physics, 2 for maths. So in this way you can see all the values which is inserted into your table. Now as I told that you can see all the databases which is present in your server, in the same way we can see all the tables which is present in our database. So there is a command to see all the tables which is present into our database. So we can use show followed by tables. So show tables will provide me all the tables which is present in the database. So let's see how we can see all the tables which is present in our database. So we'll just use this show followed by tables and we'll just end it with a semicolon. So in this way we can see all the tables which is present in our current database. So here you can see that there is only one table which is present in our schema, that is course. So in this way we can see all the tables which is present in our database. So here we are taking an example of Instagram database. So let's create a database for Instagram. In this we would create the database, we would create the table, we would insert the data into the table, and we'll see all the data which we have inserted into the table. So before moving forward, let's understand some basic concepts. So there is a server on which we generally create our databases. Now on a server there could be multiple databases like DB1, DB2, tilted DBN. Here DB stands for database. Now in this particular database there could be multiple tables like T1, T2, T3, in this also T4, T5, and this as well till Tn. So what we understood is that in a single server there could be multiple databases, and in a single database there could be multiple tables. So the very first step is create a database. So we'll execute this particular query, that is create database. Now here we are using this if not exist clause. Why this clause is needed? There could be a possibility that in a server, since there are many databases, there could be a possibility that two databases is having the same name, or we are giving the same name and a database with the name already exists. So in this way we will get an error. So just to avoid that error and get a warning message, instead we use this if not exist clause. So it basically makes sure that create a database only if that particular database does not exist on our server. So this is create database if not exist and followed by the database name. So let's just see our MySQL workbench, and there we would be executing this query and learning how we can implement all the things practically and create a database followed by table and then see all the data which is present in the table. So this is the MySQL workbench UI. Here you can see all the output, and here we're giving the query. So it is create database if not exist, and then we'll give the database name, that is Instagram DB, and we'll just execute this particular query. So once I execute this query, I can see a success here, but in the schema tab I can't see my database. So for that I'll just do a refresh all. So once I do the refresh all, I can see a database with the name Instagram DB is already created. For now there are no tables as we have not created any tables, but a database with the name Instagram DB is created. Now let's see the next step. So in this step 2, we would be using the database to create the tables. Now coming to the same example. So in a server, there could be multiple databases. So a server needs to know that if we are creating table, in which particular database we are creating a table. So to let the server know, we use this use statement. So we'll give the use followed by the database name, that right now I am using this particular database for creation of tables, insertion of data into the tables, and much more things. So let's just go to the SQL workbench. So here we'll be giving the command use followed by the database name, that is Instagram DB. And we'll just execute this particular query. So here you can see the success. So as of now, whatever tables we create would be created in this Instagram DB or database. Now let's see the step 3. So the step 3 is the creation of tables into the database. So here is the query for the creation of tables. As of now, we are taking two tables. The first table is the user table and the second table is the post table. Now in this particular query, we give create table. Again, here also we give an additional check. What if a table with the name post already exists? So create table, if not exist, user. So if there is no table with the name user, only then create a table which is named as users. So now here we provide all the columns, or you can call it as attributes or the characteristics of the table. So the first column is user ID, the second column is username, and the third column is email. Then we provide all the data types, that what all values this particular column can hold. So here we are giving the integer value, here we are giving the varchar, or we can say character values, and here also we are giving the character values. So in the third argument, we usually provide the constraint. So here we are saying that this particular user ID is now having a key constraint, that is a primary key constraint. That means this particular column user ID can only hold unique values and not null values. So a primary key is a key which helps us to uniquely identify all the records in a table. So if a column is declared as a primary key, so it can't hold any duplicate values. It should always be unique and it should always be not null. In the same way, we are creating the table for the post. The query is almost same. Here we have column as post ID, user ID, and caption with the data type as int. Here also int, and here we are giving as varchar. And here also we are giving a primary key constraint for the post ID, that the post ID will always be unique, the user ID will always be unique. So let's just execute it in the SQL workbench. So let me just copy this command and execute it in the SQL workbench. So I'll go here and I'll just paste it and I'll just do a run. So here you can see a success is shown in the output window, but here right now you can't see the table. So for that you have to do a refresh all. So once you do the refresh all, it will show a table with the name user which is created, which is having columns as user ID, username, and email. Now let's do for the second table as well. We will just copy this and we'll just paste it here and we'll just run the query. So here also you can see a success report that a table with the name post is created. Now we'll just do a refresh all here as well. So here you can see a table with the name post having columns such as post ID, user ID, and caption is created. Now in the next step, we would be inserting values in this table. So in this step 4, we would be inserting the values into the table. So this is the query we need to execute to insert the values into the user as well as the post table. So we'll just give insert into followed by the table name, that is users, and then we will provide all the columns, that is user ID, username, and email, and then we will provide the values. So 1 would be inserted into the user ID, Riti would be inserted into the username, and email would be inserted abc@gmail.com. So it follows the same pattern which is given here, the insertion. So in the same way, the 2 and 3 would also be inserted, and in the same way for the post also, insert into table name, that is post, then we'll provide all the columns, that is post ID, user ID, and caption, and here in the values we will provide all the values which we need to insert. So let's just execute this query in the SQL work. So let me just copy it and paste it here, and then I'll just execute this particular query. So here you can see a success report is generated. Again, I'll do just a refresh all. So as the data is inserted, we can't see it here. There's a special command to see all the data which is present in the table, which we will see in the step 5. So let's do the same for the post table as well. And I'll just run this query. So you can see the success. So as of now, my database is created. I've created 2 tables inside my database, that is users and post. I've inserted some data into the users and post table. Now let's see if all the data is inserted into the table or not. So in the step 5, you can see all the tables that is present in the database. So first we'll give the query use followed by the database name, which will help the server to know that the next command which is being executed for the Instagram DB. And then we'll give the show tables command. So let's see. So I'll just give use followed by the database name, that is Instagram DB, and I'll just give a semicolon. So the execution is successful, and then I'll give show tables. So this command will show all the tables which is present inside this database. So I'll just execute this query. So here you can see that there are 2 tables, post and users, which is present in this particular database. So in this step 6, we would be fetching all the values in a specified table. So for the first table, we would be executing select star from users, and for the second table, we would be using select star from post. So select star help us to fetch all the records which is present in the table. So let's go to the MySQL workbench and execute these queries. So we'll be just executing select star, then from, and then we'll give the first table name, that is users, and I'll just execute this query. So here you can see that all the data which we have inserted is here, that is 1, 2, 3, Riti, Raj, Rahul, and the email. And when we want to fetch the data for the other table, we will be using the same statement, just we will replace the users with the post. So select star from, and here I'll be giving post. So let me just execute this query. So here you can see 101, 102, 103 and all the caption and user ID is present. So in this way we create a database, we use the database, then we create the table in that particular database, we insert the values in that particular table. Again we see all the tables which is present in our database, and then we see all the data which is present in both the tables. So before starting with the data types in SQL, let's just understand what was the need of introducing data types in SQL. So consider an example of a company. So in a company, there could be many employees, E1, E2, till En. So there could be n number of employees. As of now, I have told that I have to feed the data for each and every employee in the employee table, which is having columns or attributes as name and age. So I'll start feeding the data of each and every employee in this particular employee table. So consider the first employee is Amit, who is having an age of 27. The second employee is Raj, who is having an age of 28. So first what I'll do, I'll feed the data for Amit. So I'll feed the name as Amit and age is 27. Now in the second, I'll feed the data for Raj. But while feeding the data for Raj, by mistakenly, I feed it 28 in the name and Raj in the age. So there was a reverse order in which I feeded the data. So what will happen whenever I'll make query, give me the name of all the employees whose age is 27. So what will happen in the age section, it will find out that there is one employee with the age 27, but the second employee is having Raj, which is not a valid value which should be there in age. Like no one's age can be Raj, right? So this is kind of an incorrect data. So it causes a data inconsistency. So what we do, whenever we do a creation of table, so the command for creation of table is create table followed by table name, which would be employee as of now. And whenever we will create the columns for the same, so what we will do is we will give name and then we will provide the data type, that this particular type of data a column can store. That is the main reason of introducing data type. So we will give name, then we'll give varchar. So varchar is basically used for storing the string values, and when we will give for age, we will provide it as int. So it will make sure that name is only having varchar values and age is only having integer values. So whenever we will insert data into the table, while insertion only, if we feed wrong data in the columns, it will give me an error. So data types are basically used to specify the type of data that a column can store. So there are numerous types of data types. First is the numeric, second is the character or string, third is the date and time, fourth is the boolean, and fifth is the binary. Now in the numeric data types, there are many types of data types: integer, small int, big int, decimal, float, double. So these all data types help us to store the integer values or the numeric values. In the character and string, there are three data types: character, varchar, and text. These all help us to store the string value or the character values. In the date and time, there is date, time, timestamp. So all these data types are used on the basis of their use case, but this helps us to store the date and time. In boolean, there is a boolean to store the true or false values. In binary, there is a binary, var binary blob to store the binary values that could be 0 or 1. So let's see about each and every data type in detail, and let's understand that where the use cases of such data types occurs. So first start with the numeric data type. So the very first one is int. So it is used for storing whole numbers without decimal points. So whenever we want to store a whole number without a decimal point, consider the age. So we always say that age of a person is either 16 years or 17 years. We never say the age is 16.5 years, right? So whenever we want to store a data which is a whole number, we use this integer value. Now int is having this particular range in which all the data could be stored, and it is a signed integer. What does this signed integer means? It means that it can also store the positive as well as the negative values. So the positive and negative values both can be stored in this particular int data type. Second one is big int. So big int is also used for storing whole numbers, but it stores large whole numbers. So the limit here was less, but here the limit gradually increases because it stores large whole numbers. So whenever we want to store a value which is very large, right, so we use this big int. So the third one is float. So float is basically used for storing the decimal numbers. So whenever we want to store the value which is in decimals, we use the float data type. Now the fourth one is double. So the double is used for storing decimal numbers, but again in the float the range was less, but in double the range becomes double. So if you want to store a value like 17.5, you can store it in float, but if you want to store a value like 17.555555555, so you can store that value in double. So it gives more precise value and it gives a less precise value. So if you want to store in a less precise value, or in, you can say, a round off number, you can store in float, but if you want a very precise value, you can store it in double. So basically float and double both are used to store decimal values. Int and big int both are used to store the whole number values. It's just the range which gets increased. So the fifth one is decimal. Decimal is basically used to store some values in which we provide that this is the precision I want in that particular value. This is the scale to which the value should be. So it is used for exact numeric representation. P is the precision and S is the scale. So if I want a value which is having 4 digits after the decimal, so it can help me to get that particular digit. So here you can see there is a command for creating a table and providing each and every data type for each and every column in the table. So in this way we provide the data type type while giving the column name while creating the table. So whenever we are creating the table, we will provide the column name and then we will provide the data type, like what value the column would be holding. So by default, all the numeric data types can have negative as well as positive values, as I told about the int. So int can have positive as well as negative values. This restricts the range. So if we know there is only positive values which is stored, we use the unsigned attribute. So what we do is consider age. So we know that age would always be a positive value. It won't be minus 17 years, right? So I know that age would only hold positive values. It can't hold negative values. So what I'll do, whenever I'll define the age or whenever I'll provide the data type for age, I'll just put this unsigned attribute after int, which will help us to increase the range. So what it will do, it will increase the range to 256 characters. So earlier the range was very less, but now my range is increased to 256 characters. For example, salary can never be negative or age. So salary or age can never be negative. So we provide this attribute unsigned, which says that this particular ID or this particular age or this particular salary would be only holding positive values. It can't hold any negative values. So it helps us to eliminate that negative range and add it to the positive range. Now let's see about the character data type. So there are three data types here: char, varchar and text. So let's see about the char data type. So char basically means character. So whenever we are storing any characters, we can use this char data type. Now here n basically means the size of string. So whatever would be the size of string we would be giving here. So whenever we want to store any fixed length of character strings, we use this char. So the range is from 0 to 255 character, that is A to Z values. Whenever we want to store, we can use this char data type. Now what does this fixed length of character means? So whenever I am giving a column name as char, what it will do is, consider that I have given the size as 50. So it will allocate or reserve 50 blocks of memory. So 50 blocks of memory is allocated or reserved for name. So whenever the first name is feeded, consider the first name is Raj. So I feeded Raj. So what will happen, that these memory spaces are wasted. Consider for second name Riti. So I feeded Riti. Now these memory spaces are being wasted. So these all memory spaces are being wasted and it's not utilized. So it's kind of not a good practice to use char. Rather we use varchar. Now what is varchar? So var here basically stands for variable and char basically stands for character. So whenever we want to store variable character or variable length character strings, we use varchar. Now what will happen varchar? So consider that I've given name varchar 50. So whenever I give name varchar 50, it will not go ahead and allocate a fixed length of 50 characters. What it will do, whenever I'll insert the value, consider Riti. So it will go ahead and it will insert Riti. And all the rest spaces wouldn't be occupied. So it basically inserts the value in a dynamic fashion. So the memory allocation is very good because none of the blocks of memory is wasted. But in char data type, what happens that because it is a fixed length, it will go ahead and allocate 50 blocks of memory. And in that 50 blocks of memory, even if you are using 4 blocks, the rest 46 blocks are wasted. So that is why we usually prefer using varchar, because it is for variable character string. So whenever we will provide any value, it will only take up that particular value and rest all blocks wouldn't be allocated. So the memory consumption is good. The third one is text. So variable length character strings with no specified limit. Here you have to give a limit. Here also you have to give a limit because it can hold only 0 to 255 characters. But if you want to store more characters, or there is no limit to the character string you are storing, so you can use the text. So this is the way we can use this varchar, char or text data type. Create table name followed by the column name, and here we can provide the data type. So the third one is date time data types. Here the first one is date, the second one is time, and the third one is date time or timestamp. Date is basically used for storing the date values in this format, that is year, month and day. The second one is time, which is used for storing time values, that is hour, minutes and seconds. The third one is date time or timestamp, which is used for storing date and time values. So it will give year, month and day followed by the hours, minutes and seconds. So the command which we can use is create table name, and then we can give this created timestamp as the column name, and here we can provide the data type as timestamp. So it will store the values in the format of year, month, day followed by the time, that is hour, minutes, seconds. So this is basically used for storing date and time values. So the fourth one is Boolean data type. In this Boolean data type, there is only one data type, that is Boolean. So Boolean is basically used to store a true or false value. So consider that you are a person, you want to see that if you are eligible for vote or not. So if you are greater than 18, you are eligible to vote. If you are less than 18, you are not eligible to vote. So you are making a column is eligible to vote or not. So in that particular column, there would be only true or false values. So in that particular use case, we can use this Boolean data type. So in the same way, we can use this create table followed by table name. And when we are giving the column or when we are defining the column, we can define the data type as Boolean. So the fifth one is the binary data type. Now in this binary data type, there are three data types: binary, var binary and blob, that is binary large object. So the binary is basically used for storing any fixed length of binary data. So binary data is 0 or 1. So whenever I'll give binary and the limit as 1, so it will only store 0 or 1. In the same way, var binary, basically variable binary, is used for storing variable length of binary data. It is the same what we saw for char and varchar. So char will only store fixed length character data. Varchar will store variable length of character data. So even if I am giving binary and the limit as 2, I can store 0, 1, 0, 0, 1, 0, 1, 1, like without even considering about the memory what is being used. Now the third one is blob, that is binary large object. It is used for storing large amounts of binary data. It is also variable length. So the command which we use is, while creating the table, create table name, we give the column name data, and here we provide blob, that is binary large object, which could help us to store the large amount of binary data. So this was all about this video. I hope you had a good understanding about the data types in depth, and now you understood that why while creating the table we were using the data types, what are the use case of data type where a particular data type can be used. So before starting with keys in SQL, let us understand what keys exactly is. So here I have taken an example of employee table. So in this employee table, there are some columns such as ID, name, age, phone number, which are also called as attributes or the characteristics of the table. And here I have fed some data in the rows, which is also called as tuple in DBMS. Now here I have fed the data for employee 1, employee 2 and employee 3. So ID is 1, name is Raj, age is 27, phone number is given. ID is 2, name is Rahul, age is 27, phone number is given. ID is 3, name is again Raj, age is 27 and the phone number is given. Now there should be a unique identifier or a unique attribute which could help me to identify records in a table or can distinguish between two records or two tuples in a table. So basically employee 1 and employee 2 can be distinguished on a single factor, that is called as key. So keys are basically a unique identifiers, or we can call it as attribute or a set of attributes which help us to uniquely identify records in a table. So in this particular table, ID is something which is unique for every employee, like 1, 2, 3. So we can't see some duplicate values. It is unique for every employee, and it can help me to distinguish between two employees. Like employee is Raj, so the ID is 1. This for the second Raj, the ID is 3. So it can help me identify records in a table. Now the second attribute is name. So as you can see, name is not unique for everyone. Two persons can have a same name. Here you can see employee 1 is also having name as Raj. Employee 3 is also having name as Raj. For the age also, age can be again same for different people. Phone number can be different for different people. So here we can see ID is also serving as a key, as well as phone number is also serving as a key. So ID and phone number can help us to uniquely identify records in a table. Now coming to types of keys. So there are two types of key. First one is primary key. So a primary key is a unique identifier for each record in a table. So primary key is basically a unique identifier for each record in a table. So here the key was ID and phone number. Now you will see that according to your definition, key and primary key both sound similar. So what is the basic difference between keys and primary key? So a primary key is always unique plus not null. So what does this not null means? So not null means that that particular column or that particular attribute cannot have null values. So it cannot accommodate null values. So here if we see ID cannot be null for any person, because ID is something which is generated whenever the person is onboarded into the company. So ID can never be null, and ID will always be unique for a person. So we can say ID is a primary key. But coming to phone number. So phone number would be there for each and every person, but there could be a possibility that a person doesn't have any phone number, or there could be a possibility that the person's phone number is not updated in the database, but still the person is onboarded. So phone number is not something which would be always not null. It can have null values at the very start of the onboarding. Maybe the values are updated after the onboarding, but it can have null values. So as of now, ID is something which is unique as well as not null. So it is unique for each and every employee, and it can't accommodate null values. So that is why it is called as primary key. It ensures that each row can be uniquely identified and accessed within the table. Now what is foreign key? A foreign key is a field in a table that refers to the primary key of another table. It establishes a relationship between the tables. So as of now, we are dealing with the relational databases. So what is database? Database is basically collection of data. In relational databases, we deal with the interrelated data. Now in database, there could be many tables. So there could be table 1, table 2, table 3, but as of now we are dealing with the relational databases. So all these tables should have a link or should have a relationship between them. So to establish this link, foreign key helps us, because in this particular table and in this particular table we establish a link using the foreign key. So foreign key helps us to establish the link between the two tables. So let us see about primary key and foreign key in more depth. So primary key. A primary key is a key which uniquely identifies record in a table. As I told earlier, it ensures that each tuple or record can be uniquely identified within the table. So there is an ID which is serving as a primary key which uniquely identify each records or tuples in the table. So it is always unique plus not null. So as I told earlier, that primary key is something which would be always unique and not null. It can't have duplicate values. It can't have null values. So ID would be always unique for each and every employee who has onboarded in our company, and ID won't be null, because if any employee is getting onboarded in our company, the ID would be generated for that particular employee. So this is primary key. So the second key is the foreign key. So a foreign key is a field in a table that refers to the primary key in another table. So basically a key or a field which refers to the primary key in another table is called as foreign key. So consider an example. There are two tables, student and subject. This is having all the details about student. This is having all the details about the subject opted by the student. So it is having roll number, name and hometown, and it is also having roll number, name and subject. Now this particular table is having roll number as the primary key. And this is the student table. So the student table wants to have a relationship with the subject table because the subject table tells that what subject a particular student has opted. So we want a relationship between the subject and the student table. So what we do is to establish the relationship, the foreign key basically refers to the primary key in another table. So in this particular table, the primary key is roll number. So let's see that is there any attribute which is kind of referencing to this particular table. So that will act as a foreign key. So here you can see there is a roll number which is kind of referencing to the same roll number which is present in the student table. So this will be acting as a foreign key which will be referencing or which would be taking values from the student roll number. So in this way we can establish a relationship between two tables. So this roll number is called as foreign key and this roll number is called as primary key. This is called as foreign key because this is referencing to the primary key of another table. So a relationship between two tables are established on the basis of the foreign key. Now there are two things here. You can see base or reference table and referencing table. So let's understand what is this base table and what is this referencing table. So reference table is a table which is having a primary key. So whenever there is a table which is having a primary key, that is called as reference table or base, because this is the table which is referenced by another table which is having foreign key. So that is why this is called as referenced or the base table. Second table is the referencing table. So this is called as referencing table because this is having a foreign key and it references to another table. So a table which is having primary key is called as reference table. A table which is having a foreign key is called as referencing table. So the very first question which would be coming to your mind would be why we are reading about constraints, data types and keys at the first place. So do you remember I told you a query for creating a table in the very start of the videos, that was create table followed by the table name, and then we used to provide the column name, then the data type of the column and then the constraint of the column. So as of now you would know that why we need to provide the data type so that any inconsistent or irrelevant data is not fed into our system. Now the second one was the constraint, which was kind of optional. You can provide constraints to a column and you can't provide constraint to a column. It totally depends on your use case. So constraints basically define the rules or the condition that must be satisfied by the data in the table. So consider that when you are creating a table, so at that particular time you are giving a column name, you are providing the data type and you are providing a constraint considered primary key. So this particular column would be a primary key or this particular column would have not null values. So we are giving this constraint. So whenever we would be inserting data, if we insert data which doesn't follow this rule or condition would be discarded and we would be seeing an error that this particular data can't be inserted because right now it is violating the constraint which we have given. So basically whenever we are giving a rule or a condition to that particular column or that particular attribute in a table, we call it as constraint. So common constraints include uniqueness of the data, nullability check and the default value, etc. Now here are some constraints which is present. So the very first constraint is the unique constraint. So unique constraint basically ensures that a value in a column are unique across the table. So basically whenever we are providing this unique constraint to any of the column in the table, it ensures that that particular column would only hold unique values. It can't hold any value which is duplicated or duplicate values can't be stored in that particular column. So let's see from the MySQL workbench, there we would be creating a database and then we would be creating multiple tables in which we would be seeing about each and every constraint. So this is my MySQL workbench. Let us first create a database. So we would be creating a database for college. So we would just give this command create database college and we would just execute it. So we have executed, it has run successfully. Let's just refresh it here. And here we can see a college database which is created. As of now there are no tables. We would be making new tables for every constraint. So let's just tell the server that right now I am using this particular database to make the tables. So I'll just give use followed by the database name and then I'll execute this query. So this is also successful. Now all the tables which would be created inside this college database. Now let's first see the unique constraint example. So we would be right now seeing the unique constraint example. So we'll just comment this out and let's create a table. So we'll create a table student in which we would be giving columns. So while creating the tables, always make sure that the table name is always in small letters. It can't be in capital letters. It will throw an error. So we are creating a table student. In this particular table, we are giving some columns. So as of now, we are giving phone number and we would provide a data type for this and we will provide the constraint that is unique. So we'll just execute this query and here you can see a success. So once I'll refresh it, I can see a table with the name student is created which is having a column phone number. Now since I have given this unique constraint to this phone number column, so it shouldn't hold any duplicate values. So let's just insert some values into this table and check if the unique constraint is working or not. So we'll just do insert into, and then we'll give the table name, that is student, followed by the column name, that would be phone number. So I'll just copy this, I'll paste it here, and then we would be inserting the values. So let's just insert some values. So let's insert the first value as 1, 2, 3. Let's insert the second value as 4, 5, 6. And let's insert the third value again as 1, 2, 3 to check that if the unique constraint is working or not. So let me just execute this query. So here you can see that we are getting an error that duplicate entry 1, 2, 3 for the key student phone number. So we are giving the duplicate entry, and since we have given that it will be only holding unique values, this particular statement can't be executed. So what I'll do, I'll just remove this duplicate value and then I'll try running this query. So I've removed the duplicate values, all the values are unique. Let's just run this query again. So once I run the query after removing the duplicate values, you can see that I am getting a success. So basically unique is somehow making sure that my particular table doesn't have any duplicated values. Now let's see for the next constraint, that is the not null constraint. So not null constraint basically ensures a column cannot have null value. So basically not null constraint makes sure that if a column is provided, it shouldn't have or it shouldn't store any of the null values. So let's see about this also in the MySQL workbench. So let's see for the not null constraint. So we'll just mention not null constraint and we'll just comment this out. And we'll just create a new table. So let's create a table student1 and let's just give some columns for the student1. So let's give the first column as age, which would be holding integer values, and as of now we are not giving any constraint to the age. Let's give another as roll number and it would be also storing integer values, and let's just put the not null constraint here. So let's just execute this query. And you can see a success. Let me just refresh it here. So here you can see a new table with the name student1 is created. Now let's just insert some values into the table. So we'll just do insert into student1, and here I'll only give one column name so that in the next column null value is automatically inserted. So I'll just give here age and I'll just give the values, and here I'll give the value as 27. And I'll just execute this query. So what I have done is, right now I am only inserting values into the age. I am not inserting any value into the roll number. So let me just execute this query. So here you can see I'm getting an error. Field roll number does not have a default value. So it says that right now field roll number doesn't have any default value. So it is getting a null value. And as of now you have told that roll number can't have null values. So this query can't be executed. But when I make this age, comma roll number, and when I insert some value for the roll number as well, consider 1, and when I run this query, it would be successfully run, because right now I am giving a value to that roll number column, so it is not getting any null values. So this is how we can ensure the not null constraint. Let's see about the other constraints as well. So the third constraint in the list is the check constraint. So check constraint basically enforces a condition to be true for each row. So basically check constraint is kind of like you are making a check that if you are inserting any values into this particular column, there is a check which should be true. So consider that if you are inserting age of a person in a particular table, so you have to only insert the age of a person if he or she is greater than 18, so that you can make a voter ID for that particular person. So let's see from the MySQL workbench. So this would be for the check constraint. I'll just comment it out. So let's again create a new table. Create table student3, and we'll just provide the columns. So we'll just give age, which will have integer values, and we'll just give a check constraint. If check age is greater than 18, only then insert the values, otherwise don't insert the value. So we'll just execute this particular query. So query is executed. Here if you do a refresh, you can see a student3 is also created. Now in this student3 table we will insert the values. So insert into student3, and here we will give the column name, that is age. And now we will insert the values. So let's insert. So here I have given the constraint that the age should always be greater than 18. Let's give an age which is less than 18. Let's give the age as 13. And let's just execute this query to see that if the constraint is working or not. So I'm executing the query. So here you can see that we are getting an error that the check constraint is present on the student3 age column. So we can't insert the value which is less than 18. And let's run the same query after giving an age which is greater than 18, 21. Let's just run this query. So you can see a success that this particular age is already inserted because this is greater than 18. So this is how the check constraint works. Let's see for the next constraint. So the next constraint here is the default constraint. So default constraint basically provides a default value for a column if no value is specified. So basically you remember that in the last example when we were inserting the data into the columns, if we are not providing any column name, null is automatically being inserted in that particular column. So if we want to avoid that null, if we want a default value which should be there, consider that you are a student and you are studying at a school. If you forget to provide that school name in your database, that that would automatically take the school name. So let's just see about the default constraint as well. So default constraint basically means if no value is provided, the default value will be automatically inserted. So let's see for the default constraint. So we'll just create a table. So create table student 5, and here we would be giving the column names. So let's just give the first column name as school name, and it will take varchar values because it is a character string. So it will just take 50 characters, and here I'll provide this default constraint. So default would be XYZ. Like as of now I'm taking the school name as XYZ, and then I'll be providing next column as age, which would be taking integer values. So let's just execute this query. So you can see that we are getting a success. Now let's just insert some values into this table. So insert into student 5, and then we will provide the column. So as of now I'm not providing the school name because it will by default take the default value. So I'm just giving for age. So I'll just give age, and in the values I'll just give 19 for now. I'll just execute this query. So you can see that I'm getting a success on executing this query. So let me just see if the table is taking the default value or not. So I'll just do select star from student 5. So it will show all the data which is present in student 5, and I'll just execute this query. So here you can see that the school name XYZ is already taken by default. So I haven't entered any of the school name. It has taken the school name by default. So this is how the default constraint works. So if we give the default constraint, it will take the default value if none of the values specified. If you specify any value, it will take that value. But if you don't specify any value, it will take the default value. So the next constraint is the primary key constraint. Now primary key constraint basically enforces the uniqueness of values in one or more columns. So a primary key basically enforces the uniqueness that two tuples can be identified uniquely whenever there is a primary key present. So primary key is always unique as well as not null. Both the unique and the not null constraint together is applied in the primary key. So when you are providing any column as primary key, it is by default unique, it is by default not null. So let's see about the primary key. So this would be primary key constraint. So we will see for two things. First is the uniqueness and second is the not null. So first we will create a table again. So we will create table and we'll give the name as student 6. Don't get confused at why I am creating so many tables. It's just for you to have a proper understanding about each and every constraint in depth. So that is why I am creating multiple tables. We can do this in the same table as well, but again that could be a bit confusing. So let's just give some columns. So we'll give age int, and then we will give roll number int, and let's just give roll number as primary key, and let's just execute this query. So you can see we are getting a success for this query. Now let's just insert the values. So first we will see if it is holding the uniqueness or not, and second we will see that all the values are not null. So let's see for the uniqueness first. So we'll just insert into, again we'll give the table name, that is student 6, and then we will provide the column. So the first column is age and the second column is roll number, and then we will give the values. So let's give the first value as, let's give the age as 12 and roll number as 1, and then we will give another age as 13, roll number as 2, and here we have to check that if it is following this unique thing or not. So let's just give a duplicate value. So we will give age as 14 for a student and again the roll number as 2. And let's just execute this query to see if it is taking care of the uniqueness or not. So here you can see we are getting an error because we have told that once a column is declared as primary key, it will always hold a unique and a not null value. And for not null also, let's execute the same query and do some changes. So we have to make this roll number always not null. So let's just not give any roll number here, and let's just insert only one value in age. So let me just execute this query. So here you can see we are again getting an error because for now roll number is having a null value and roll number is asking for a default value because primary key can never be null. Now the last constraint is the foreign key constraint. So foreign key constraint basically enforces a link between two tables by referencing a column in one table, that is primary key in another table. So in foreign key what happens is the foreign key is basically helping us to establish a link between two tables. So foreign key links two tables to have a relationship between them. So there are two tables, table 1 and table 2. Table 1 is having details about the student and table 2 is having the details about the course or the subject. Now table 1 is having ID, which is serving as a primary key as of now. So if we want to establish a relationship between the student and the course table, what we will do is we will search for this primary key if it's present here or not, the attribute which is like kind of referencing here. So we'll search for the same attribute here. So we can see that there is the same attribute which is present in the course table as well. So it will act as a foreign key and it will reference to the primary key of the student table. So in this way a relationship is established. Please take care this thing in mind, that one table would be having only one primary key but can have multiple foreign keys. So let's just see about the foreign key constraint. So we'll see foreign key constraint. Now for the foreign key, let's create a table first. So create a table with the name course that would be having some course details such as course name, and we'll give it as varchar 50. And then we want to establish this course table with the student table. Now the student 6 table is having age and roll number. So let me just provide a roll number here. So it would be roll number and that would be taking integer value. Now at the very last, I'll just establish a relationship between this roll number and the roll number which is present in the student 6 table. So what I'll do, I'll just provide foreign key roll number. I'll just mention it inside the brackets. Foreign key roll number references. I'll give the table name of which we are taking a reference, that is student 6, and then I'll provide the column name, that is roll number. And okay, so I've provided the foreign key and I've provided that which particular column here would be acting as a foreign key, and then I've given this references. So there's a small typo and I'll just fix it. So let me just execute this query. So once I execute this query, I can see a success. So basically a table with the name course is created, which is having a relationship with the table student 6. The student 6 primary key, that is roll number, is acting as a foreign key here, and there is a link which is being created. So before starting with foreign key, let's just re-revise some older concepts. So in keys, we learnt about two types of key. The very first one was the primary key and the second one was the foreign key. Now what is primary key? Primary key is a key which uniquely identifies all the records, or we can say rows of a table. Now consider that there is an employee table. Now in this employee table, we have some attributes such as employee ID, employee name, employee salary, employee address. Now in this particular table, we are treating ID as the primary key. So we have fed the details of employee 1, then employee 2, employee 3, followed by all the employees which is present in the organization. Now if I want to identify employee 1 from rest of the employee, would this ID be helpful to me? So the answer is yes. The ID would be helpful for me to identify employee 1 among all the employees which are present, because primary key says that if we are declaring any of the key as primary key, it is always unique as well as not null. So what does this mean? Uniqueness here means that ID cannot have any duplicated values. So employee 1 and employee 2 both can't have the ID as 1. It is not allowed when we are declaring ID as the primary key. So ID cannot have duplicated values. The second one is not null. So ID cannot also hold any null values, because again, if I am holding ID as null here, so it won't help me to differentiate between all the employees, because for employee 2 the ID is null. So null values are not allowed and duplicated values are not allowed whenever we are assigning any attribute, or we can say set of attributes, as primary key. So primary key help us for unique identification of all the records which is present in a table. Now let's move to the foreign key. So what is foreign key? Foreign key is a key which help us to establish relationship between two tables. So whenever consider there is a database, and as of now I am taking school database as an example. So in the school database there would be multiple tables. First one would be the student table, second would be the course table, third would be the teacher table, and so on. Now the student table and course table have a relationship between them. So the course table basically says that which particular student has opted which particular course. So this course tables helps me to know that if a student has opted a course of, let's say, course code as 100. So what are the course details, like what is the course name, who is the course teacher, and much more thing. And then this teacher table also have a relationship between the course table. So basically the course table tells that this particular teacher is gonna teach that particular course. So somehow we can see that there are some relationship which is established between different tables which is present in our database. So foreign key help us to establish a relationship, or we can say link, between two tables. So whenever we want to establish a relationship or link between two tables, we use the foreign key concept. Now let's see the example which is present here. So there are two tables, first one is student and second one is course. So what is the first thing we will do? We'll identify the primary key of both the tables. So here you can see that ID is something which is unique for each and every student. So here ID is acting as a primary key. Now coming to the course table, here you can see that course ID is unique for each and every course. So here we can make course ID as primary key. Okay, so here course ID is acting as a primary key, here ID is acting as a primary key. Now you can see that this particular ID tells about the student ID, that for Rahul the student ID is 1, for Raj the student ID is 2, and for Riti the student ID is 3. Now in this particular table, if I add one more column which is of ID, like which is, you can say, roll number, like consider this as roll number, student roll number. So if I add a same column here, student roll number, so I can know that okay, a student with roll number 1 is having a course ID 100, is opted Hindi as a language or as a subject, and the teacher who is teaching is Ram. So basically this particular ID column is helping me to establish a relationship between these two tables, because from here I can see that okay, the ID is 1. So here if I come, the ID is 1, the name is Rahul. So ID 1, name Rahul, has opted Hindi as a course or as a subject, and the teacher who is teaching is Ram. So a relationship between these two tables is established. So this is called as foreign key. So foreign key is a key which references to the reference table and act as a primary key in the reference table. So whenever there is a foreign key which is present in another table, it is kind of acting as a primary key in the table to which it is referencing or to which it is establishing a relationship. So as of now, course table is establishing a relationship with student. So there is a key which is present which is kind of primary key in another table. So this key is acting as a foreign key, because this key is helping me to map all the details which is present in the course table to the student table. So there is a relationship which is established between table T1 and T2, which is student and course. So whenever a table which is referencing to another table, that is called as referencing or child table. So whenever we are having a foreign key in a table, that table we can call it as a referencing table or child table. Now what is this child table? So you might have heard this parent-child inheritance. That child always have some properties of parents, or child inherits some properties of parents. In the same way here, child table inherits some properties of the parent table. And whenever there is a foreign key which is present in child table, it is referencing to one of the table, that is called as reference table. So whenever a table is being referenced, it is called as reference table, or we can also say that it is called as base table, or we can say that it is called as parent table. So we can name it as base, referenced, or parent table, and the table which is having foreign key and which is referencing to other table is called as referencing or child table. Now foreign key help us to perform operations related to the parent table, such as joining tables or ensuring referential integrity. Now what is this referential integrity? Consider that there are two tables and they have a foreign key relationship between them, or they have established a relationship between them. This is also having a column as ID, and here also we are having column as ID, which is acting as a foreign key here and which is acting as a primary key here. Consider that in this ID, if I update ID from 1 to 2, so this particular 2 should be updated here as well to maintain the data consistency, because consider that someone makes a query here and someone uses the same query for here, that give me all the details of a person whose ID is 1, or give me all the course details of person whose ID is 1. So here 1 is not existing. So here it will say that okay, you are making a wrong query because 1 is not existing, but here it will give the detail. So basically data is kind of inconsistent. So we need to maintain the data consistency, that if anything is updated here or considered deleted here, that should be done same in the another table, or we can say the child table. So if any of the update or delete happens in the base table, that needs to be done in the child table. So that is called as referential integrity, basically maintaining the integrity of data, all the tables which is having a relationship between them. Now the query to any column or attribute as foreign key. So we give create table and then we give the table name. So consider that there are two tables. The first table we are calling as base table and the second table we are calling as child table. Now this table is already existing and this table we are making it new. Now this particular table has base ID, consider name and other parameters, and here base ID is acting as a primary key. This particular child table is having its course ID and now it's having a base ID which is acting as a primary key in another table. So this is a foreign key which is referencing to the primary key of another table. So we'll give create table followed by the child table name. Then we will give all the attributes which are present here. So child ID, then we will provide the data type, that this attributes would be taking only these values. So we will provide int, and here CID is acting as a primary key. So we will provide this primary key constraint as well. Then we will provide the base ID and then all the values which is being accepted by the base ID, that is integer. Then we will give this foreign key Like we will tell the database that this particular column is going to be my foreign key. So I'll provide this foreign key name, and then I'll provide that which column in the child table we want to be a foreign key, that is base ID. So I'll provide the base ID, and then here I'll provide references. Okay, I've made the base ID as foreign key, but I have to tell the database ki, okay, this particular ID is being referenced as foreign key, but which table it's referencing to. So I'll give this references, and then I'll give the table name, that is base table name, and then which column this foreign key is referencing to, that is base ID. So in this way, while creating a table, we can declare the foreign key. So let's see from the MySQL workbench. So here I am creating a database of school. So I'll just execute the command. So I've created a database of school. I'll just do a refresh all. So here a database of school is created. Now I'll create a table student which will be acting as a base table as of now. So I'll just run the command. Okay, so we are getting an error, no database selected. So why we are getting this error? We have created the database school, but I haven't told the server that if I want to create the table, in which particular database I want to create the table. So no database has been selected. So we need to execute this use command. So this will tell the server ki, okay, now all the operations which are gonna happen will happen in this school database. Now you can see we have got a success. Now again we will run this create table student, and here you can see we have got a success. So once I do a refresh all, here in the tables, I can see a table with the name student is created, which is having columns as ID and name. ID is acting as a primary key and name is another column. Now I am creating a table course, which is a child table, which will be having foreign key, which will be referencing to the primary key of the student table. So what I'll do, I'll just give course, and then I'll give course ID, integer, and here in this particular table, course ID is acting as a primary key. So I'll give primary key, and then I'll provide the ID, which is coming from this particular student, and it is taking integer values, and then in the last line I'll provide that ID is a foreign key. So I'll provide ID here, and then I'll provide that which table it's referencing to. So references, and then I'll provide which table it's referencing to. So it's student. So I'll provide student, and then I'll provide the column or the attribute which it's referencing. So that is ID, and then I'll just execute this particular query. So you can say I've got a success, and here I'll do a refresh all. So here you can see that two tables are created. First one is student and second one is course. So course is having ID as a foreign key, which is existing in the student table, which is acting as a primary key there. So now let's see about cascading in foreign key. So just now I explained about referential integrity, that if there is any update which is happening in the base table, same should be happening in the child table, or if there is any delete which is happening in the base table, same should happen in the child table as well. So cascading are a set of rules which dictate what action should be taken automatically when a referenced row in the parent table is modified or deleted. So whenever there are two tables, first one is the parent table, second is the child table. So whenever there is any kind of insertion or deletion which is happening in the parent table, same should happen in the child table as well, as they are having a relationship via foreign key. So there are ways in which we can achieve the same to maintain the referential integrity. So there are three ways to maintain the referential integrity. First one is cascade. So if a row in parent table is updated or deleted, all the related rows in the child table will be automatically updated or deleted. So cascade says that if I give cascade command, what it will do, that if any of the attribute here or any of the value here is updated or deleted, same will happen in the child table. The second one is set null. So if a row in the parent table is updated or deleted, all the corresponding foreign key values in the child table will be set to null. So consider that in the ID, I have updated the value from 1 to 1a. So the same shouldn't be replicated here. Either what it will do, that ID is updated from 1 to 1a, so it will set a null value there, saying that this particular value is now being updated, and now for now we have set the value as null here. So foreign key values in the child table will be set to null. Now the third one is restrict or no action. So what it does, it blocks the modification or deletion of a reference row in the parent table if related row exists in the child table, thus maintaining the referential integrity. So if I provide this command at the last of creation of table, what it will do, consider that there is a ID which is here, and the same ID is present here, which is acting as a foreign key. So what it will do, that it will not allow any kind of updation or deletion happening in this particular ID table, because it will somehow affect the ID which is present in this particular table, that is the child table, and it is acting as a foreign key. So it will basically block the modification or deletion of the reference row in the parent table. So it will just block the modification of the ID which is present in the reference table. Now how we can achieve the cascading in foreign key? So these cascading action helps to maintain the integrity of data across related tables in the database. Now there are two ways in which we can achieve this cascading. First one is on delete cascade, and second one is on update cascade. So what does this on delete cascade does? So the onDelete cascade clause indicates that if a row in a parent table is deleted, all the corresponding rows in the child table will be automatically deleted as well. So it says that if I am writing the query in which I am referencing a attribute as foreign key, if at the very last I mention this onDelete cascade, it will make sure that any of the data which is deleted in parent table will be deleted in the child table as well. What is onUpdate cascade? So the onUpdate cascade clause indicates that if a row in the parent table is updated, all the corresponding rows in the child table will be automatically updated. So it says that if there is any kind of changes or any kind of updation which has happened in the parent table, the same would be reflected in the child table. So while creating a table, at the very last we can provide this onUpdate cascade, which makes sure that if any of the value which is updated in the parent table, that is the base table, the same should be replicated in the child table as well, thus maintaining the referential integrity. So before starting with the update command, let's just realize or understand what is the importance of update command, or how is this update command even coming into the picture. So what is SQL? SQL is basically a programming language which helps us to perform any CRUD operations on our data. Now what are these CRUD operations? So CRUD stands for create, read, update and delete. Now, whenever we want to perform such operations on our data, we use SQL. And there are some special commands in SQL which help us to perform all these operations. So for the create, we have a create command in SQL, which help us to create any database, any table. For the read, we have a select command, which help us to show the data or the data which is present to make a query in the data. Then update, we have the update command in SQL. And then for delete, we have a delete command in SQL. So using all these commands, we can do manipulations in the data, basically perform the CRUD operations. Now in this particular video, we would be touch basing more on the update command. So before starting with the update command, let's just create a sample database. In that sample database, let's just create a table and fill in some details into the table. Then we would be updating some values, or we can say a record in a table, and see that if the values are being updated or not. So before making any of the database or any of the table, there are some requirements or some steps we should be following. So the very first step is make a database for a company XYZ. So we have given a requirement that we have to make a database for a company named XYZ. So what we will do, we will first run this particular query where we give create followed by the database, and then we provide the database name, that is XYZ. So this is the very first step we perform. Now here it will create me a database with the name XYZ in our server. So in the server, there could be multiple databases. For now, it is creating a XYZ database. Now the second command is use XYZ. So as I told that in a server, there could be multiple databases. Now I want to execute some queries. So how would the server know that if it's being executed in this particular database or this particular database? So we give this command use XYZ, which helps the server to know that if any operation or any queries are being performed, it would be performed in this XYZ database. So we will be hitting this particular query. Then the second requirement is, now in that particular database, we would be creating an employee table. So to create an employee table, we would be executing this query. We'll give create table followed by the table name, that is employee, and then we will provide all the columns which we need in this particular table. Basically you can say as schema of the table or the characteristics or attributes of this particular table. So we will give the column name followed by the data type, basically what all values the column will be holding. So ID can either hold string values, integer values, boolean values, any values. So we will be telling that ID would only be holding integer values. So whenever a person wants to insert a string value or a boolean value, it will throw an error because we have told that ID would only be storing int values. And then we give a constraint. So what is constraint? Constraint is basically a set of rules we provide to particular column. So we are providing a constraint primary key, which says that this particular ID field will always have unique as well as not null values. So it means that ID can't hold duplicate values, ID also can't hold null values. And in the same way, we will give column name followed by the data type. The constraint is kind of optional. So we will again give the column name followed by the data type, column name, data type, column name, data type, and column name, data type. In this way, we can create an employee table in the XYZ database. Now the third requirement comes in where we have to fill the details into the table, basically insert some data into the table. So for that, we will execute this query where we will give insert into followed by the table name, that is employee, and then we will provide the order in which we want to insert all the values. So basically it gives the order, like firstly the value would be inserted into ID, second value would be inserted into name, third value would be inserted into age, fourth into department, fifth into city, and sixth into salary. So whenever here we give the values, we can provide multiple values followed by a comma. Like if I want to enter details of multiple employees, so I can enter the details of employee 1, then I can give a comma, and then I can enter details of employee 2, employee 3, employee 4, employee 5. Now in the values, the 1 is basically stored in the ID, as this is the manner in which we are inserting the data. Rahul is stored in name, 25 is stored in age, IT is stored in department, Mumbai is stored in city, and 1500 is stored in salary for the very first record, we can say, or the employee 1 record. Now in the employee 2, the same thing happens, employee 3, employee 4, employee 5. So here we have feeded among 5 details of each and every employee, including their ID, name, age, department, city, and salary. So we have created a database, we have used that database, we have created a table, we have inserted some values into the table. Now we want to see if all the values are inserted into the table or not. So the very fourth requirement is see all the data in the table. So let's see from the MySQL workbench, let's execute all these queries and create a database with a table employee so that we can perform any operations on that particular table. So I'll go to MySQL workbench. So here you can see that I have already written all the queries just to save time, but I'll be executing the queries one by one and would be explaining that how these queries are even working. So the very first thing was to make a database with a company XYZ. So I'll give the command create database followed by XYZ, and then I'll just run this. So here you can see that I've got a success, but in the schemas tab you won't be able to see anything. So you have to just right click and do a refresh all. So once you do a refresh all, you can see a database with the name or a schema with the name XYZ is created. When you open it, you would be seeing that there are no tables, no views, nothing here, because we have only created a database. As of now, we haven't done any operation. Now the second operation is use XYZ. Again, we use this use XYZ or use followed by the database name to tell the server that if there are two schemas, SYS or XYZ, we want to execute all the operation on this XYZ schema. Now the second one was to make an employee table in the XYZ database. So we will just hit this create table, then we give this table name, and then we provide all the columns which we need in this particular table. We'll just run this query, and here you can see we have got a success. But here you won't be able to see anything. So you have to just again go and refresh all. So here you can see in the tables, our employee table is created, which is having all the columns as ID, name, age, department, city, and salary. Now we have to fill some details into the table. So I'll be just executing this query, which inserts data into the table followed by the given order, and then the values which we need to insert into the table. So I'll just run this. And here if I do refresh all, I won't be able to see the data which is present here. So to see the data, that if the data I have provided or if the data I have inserted is inserted correctly or not, or if the data is present or not, I'll just hit this particular query, which is select star from employee. Now this particular query, select star from employee, help us to see all the data which is present into this employee table. Basically the asterisk here means all. So select all from employee. So select all the data which is present in the employee table. So we'll just hit this query. About the select, we will be looking more on to the next set of videos, but for now you can understand that here we are trying to see all the data which is present into the table. So here you can see ID, name, age, department, city, salary, and all the data which we have feeded is present here. Now let's go to the update command. So the update command in SQL is used to modify existing records in a table. Now consider that my name is Riti. I ordered something from Swiggy. I gave my name there. But my mistake, I wrote it as REETI rather than RITI. Now my name is displaying as REETI, but my name is RITI. So I raise a complaint to their customer care and I tell to correct my name. So they will ask me that what is the corrected name. So I'll provide my corrected name and I'll provide the name which is right now present. So basically I am somehow updating the value here of name from Riti, REETI to RITI. So basically update means whenever we are modifying any existing data which is present inside the database. Consider you have provided your age. By mistakenly someone feed it incorrect age. So you can ask that particular person to go ahead and update your correct age in the database. So basically update help us to modify any records or any values which is present into our table. So the query for update is this update, then we give the table name, and then we provide here set. Basically means ki you have to update this particular table and you have to set the column name to this particular value. So basically if I am updating my name here, what I'll do, I'll update, I'll give the table name, I'll set, and then I'll provide the column name as name. I'll provide the value which is need to be set. So the value which needs to be set. If there are more values which are incorrect, we can provide it using comma separated way. And then I'll give the condition. Okay, I've given the name is equal to Riti, you have to set in this particular table, but where I have to set this particular name. So I'll provide the condition where name is equal to REETI. So I'm telling my database that go ahead and update the table with the table name this, set name equal to Riti, like the updated value, and if there are more values I can give, and I'll tell my database ki you have to update the name as Riti, where right now the name is equal to REETI. So in this manner the update query mostly works. Now let's see some examples of this update query, some practice question, and then we will go ahead in the MySQL workbench and execute these queries. So the very first practice question is write a query to update the salary for all employees in the HR department to 50,000. So basically for HR department now there has been an increment which is applied to all the people who are working into the HR department. So So rather than going ahead and manually correcting all the salary, it's better to go ahead and execute a query which will update all the salaries of the people who are present in HR department to 50,000. So what the query would be, I'll give update, then the table name which we created, employee, and then we will give the set salary equal to 50,000. So this is the updated value which I want to set. So I'll set the salary equal to 50,000, and then I'll provide the condition or the clause where department equals to HR. So go ahead, update the employee table where department is equal to HR and set the salary as 50,000. So let's just go ahead and execute this particular query into our MySQL workbench. So let's just execute that particular query. So what we will do, we'll give update, and then we will give the table name, that is employee, and then we will provide set and the value which we need to update, salary, equal to 50,000, and then I'll provide the condition that where I need to update this. So where department equals to HR, and I'll just execute this particular query. So here you can see that while executing this query, I've got an error, unknown column salary in the field list. So basically it's a typo, and I'll just correct it, and I'll just execute it again. Again, I've got an error. So what this error says, you are using a safe update mode. So what is this safe update mode? So let's learn about this safe update mode. So what happens ki right now we are creating some databases, we are creating some tables, we are doing update into the table, we are deleting some tables, we are deleting some databases. But in a normal scenario, this doesn't happen. Or in a real world scenario, this doesn't happen. Because there are companies who are having huge databases, which are having databases of employees, workers, their salary details, their personal details, and much more things. So whenever we are performing any update or the delete command, that could be harmful because there might be some APIs which would be depending on the data which is present into the database. So whenever we are updating any values or whenever we are deleting any values, we have to make sure that we are turning off the safe mode, which means we are telling ki, okay, I know that I am updating the value, okay, I know I am deleting the value, please turn off the safe mode. So for that, we will just execute this query, that is set SQL safe updates equal to 0. So I'll go here. So I'll set SQL safe updates equal to 0. And whenever I want to revert this, I'll execute this query and I'll just provide here as 1. And I'll just execute this query. So this query is successful. Now let's just execute this query of update. And now it's successful. So now we want to see that if the update has happened successfully or not. So we will just see all the employee details. I'll just run this command. And here you can see the department is HR and the salary has been updated to 50,000. So earlier the salary for the HR department was 2,000. Now the salary has been updated to 50,000. So let's go to the second practice question. Write a query to update the name of an employee from RAAJ to RAJ. So basically our employee name, as I told that I have given my name as REETI, but my actual name is RITI. So I want to update that value. In the same manner, we have to update the name of an employee whose right now name is RAAJ to RAJ. So for that, what we will do, we will give that update followed by the table name, that is employee. Then I'll give the set, which basically sets the value or set the updated value. So I'll give name equal to Raj, which is the updated value. And now my database wants to know that where you want to set this updated value. So I'll provide the condition where name is RAAG. So in this manner, we can update the name from RAAG to RAG. So this is all about the update command in this particular video. We would be learning about the delete and the select command in the next set of videos. So the delete command in SQL is basically used to remove records from the table. So it's not like that it removes a value or it removes a data from the table. It entirely deletes the record which is present in the table. So records here basically means the rows of a table. So whenever we want to delete an entire row, we use this delete command. So the query for this is delete, then we give from, and then we provide the table name from which table we want to delete, and then we give the condition that what we need to delete. So consider that I want to delete all the records of a person whose name is Riti. So what I'll do, I'll just put this delete from table name, and then in the where I'll provide the condition where name is equal to Riti. So it will delete all the records of mine from the database. So let's just see from the practice question, and then we will go to MySQL workbench and execute the queries. So the very first practice question is write a query to delete all the records from the employee table where department is HR. So I want to delete all the records which is present into our table for the people who are from the HR department, because I am making a separate database for IT department, separate database for HR department, separate database for consulting department, and much more things. So what I'll do, I'll just give this query delete from, and then I'll give the table name which is employee. Then in the condition, I'll provide that from where I want to delete. So I want to delete the department equal to HR. Now what it will do, consider that this is my table. And this is the department, and these are all the details. Consider the department here is IT, it is HR, it is again IT, and it is again HR. So it will find all the HR department which is present in my table, and it will delete just all the departments which is having the name as HR. So it will delete all the department which is having the name as HR. It's not like that it will only delete one row, it will delete all the rows with the name HR. So let's just go to MySQL Workbench and see how the delete works. So we'll give delete from, and then we will give the table name, that is employee, and then we will provide the condition where department equals to. So now here we have only one HR department. So let's use the IT department, because here we are having two IT departments. So we will be seeing that how it is deleting all the records which is present into our table with the department as IT. So I'll just give IT and I'll just execute this particular query. So this query is a success. Now let's just use this select star from employee to see all the records. And here you can see that we can't see any of the record with the name department name as IT. So now you can see that whenever we are deleting anything, and if we are providing the department as IT, it will search in the entire table with the departments and as IT, and it will delete all the records who are having the department name as IT. It's not that it's only deleting one record, it will delete all the records with the department name as IT. Now let's see the second practice question. So we have to write a query to delete the record of an employee having the name as Raj. So here we are deleting the record of an employee who is having the name as Raj. So what query we will write? We'll give delete from, and then we will give the table name, that is employee, and then here in the condition we will provide where name, and then we will provide the name as Raj. So let's just execute this query as well. So I'll just close this and I'll use delete from, and then I'll give the table name as employee, and I'll give where name equals to, and I'll give Raj, and I'll just, so the Raj name is RAJ, and I'll just execute this. So you can see that I've got a success. Again, I'll just hit this particular query, and here you can see that I can't find any person with the name Raj. So whenever it will find any person with the name Raj, it will delete all the records which is present into that particular table with the name Raj. So in this way, delete command works. So whenever we want to retrieve data from our table, we use the select command. So select command is a DQL command, that is data query language command. It is basically used to retrieve data from the database. So whenever we want to get or we want to retrieve some data from the database, we use the select command. Now we can provide specific columns from which we want to retrieve data. Either we can retrieve all the data which is present into our table. So there are two queries which we can use. First one is select. Then we provide all the columns which we want to see or which data we want to see. So we'll provide the column name, column 1 name, column 2 name, and then we will provide from, and then we will provide the table name, like the table name from which we want to retrieve the data. So it will retrieve the data present in a specific column in a table. Then there is another query which is select star from table name. So this star basically means all the columns which is present into our table. So this star basically means all. So whenever we want to see all the data which is present in our table, we use the select star and then we provide the table name. So it helps us to retrieve all the data which is present in our table. So let's just see the example of select. So consider the first example where I want to only see the name and age of an employee from the employee table. So I'll use select, and then I'll provide the column names from which I want to see the data. So first one is name, second one is age, and then I will provide the table name. So the table name is employee. And then I'll just execute this query. So this is a success query, and here you can see that I can only see the name and age. So this employee table is having more columns, but as of now I've told that I want to only retrieve the data from the name and age which is present in the employee table. So basically it helps us to retrieve data from some specific column. If you want to retrieve the data, like the entire data which is present in this particular table, so we give select star, which is basically pronounced as all, and then we give from, and then we provide the table name which is employee. And whenever we execute this, we can see the entire data which is present in all the columns. So basically you have seen that in the earlier videos also we were using this particular command select star from, which was helping us to see all the details or all the data which is present into the table. So select command help us to retrieve all the data or some of the data which is present into the table. So let's understand about where clause, its importance, how it helps us to filter data, and much more things. So without any further ado, let's get started. So whenever we want to filter the data, we use this where clause. Now where clause helps us to filter the rows based on a specified condition. Now what does this mean? So consider that I want a detail of a person whose age is 25, or I want all the details of a student who are having marks greater than 90. So basically I'm giving a condition that the age should always be greater than or equal to 25, or the marks should always be greater than or equal to 90. So whenever I'm providing any kind of condition to filter some of the data, because consider that I'm saying that I want the details of a person, so it will send me all the details, or it will show me all the details of all the person who are present in that particular table. But when I put up some condition like age should be 25, now what it will do, it will go one by one and check all the records, and wherever it will find age equal to 25, it will return that particular result and show me that particular result. So I am somehow giving some condition to get some filtered set of data. So in that way, where clause helps us. You have seen in the earlier videos as well that I was using the where condition along with update, along with delete, sometimes along with select also we use the where condition. So where condition or where clause is oftenly used whenever we want to apply any condition to our data. So here is a query on how we can use the where clause. So consider that I am trying to fetch some of the columns from a given table with a particular condition. So what I'll do, I'll provide the select command, then I'll provide all the columns from which I'm fetching the data, then I'll provide from, I'll provide the table name from which I'm fetching the data, and then I'll provide the where, and then I'll provide the condition, that what is the condition on basis of which I want all these columns to be filtered. So here is an example. So here I am kind of fetching or filtering out all the data of an employee whose age is greater than 20. So what I'll do, I'll just do a select star, which will make sure that all the data is selected. So basically till here, I am having all the data which is present in my table from table employee. So this is the table employee. Now here, there is a condition where age is greater than 20. Consider there is a age column in this particular table employee. And in this age column, we have ages such as 18, 20, 25. So now what will happen here, whenever I'll give where age is greater than 20, it will go record by record and see, here is the age greater than 18? No. So discard this value, it won't be shown in the final result. Now here, is the age greater than 20? It is 20 but not greater than 20. So this will also be discarded. Here, is the age greater than 20? Yes. So it will be shown in the final result. So in this way, we use the where clause. Let's see from an example as well. So this is my MySQL workbench. I have already created a table employee and I have already feeded some data in that particular employee table. Now here I'll be using this where condition to filter out all the employees whose age is greater than 25. So what I'll do, I'll just give select star from, and then I'll give the table name, that is employee, and then I'll provide the condition where age is greater than 25. So firstly, I'll see that what all data is present in my current table. So I'll just hit the select star from employee. And after hitting, I can see that all the data which is present in my table. I have actually, after the next set of videos, I have feeded all the data again because we are seeing about the SQL queries and we need much more data to perform the queries. So now I'll just execute this query. And here you can see that there are only two people who are having age greater than 25, and I can see all the details of that particular person whose age is greater than 25. So basically where clause is helping me to get the filtered data, like on the basis of condition, I can get a filtered data which would be really helpful for me to execute some of the complex queries. So if you remember, in the very start of the lectures, we discussed about types of SQL commands. So there we learned about 5 types of SQL command. The very first one was DQL. The second one was DML. The third one was DDL. The fourth one was DCL, and the fifth one was TCL. Now what is DQL? So DQL basically stands for Data Query Language Command. So whenever we want to make any query into our data, or whenever we want to fetch the details from our database, we use this DQL command. Now the second one was DML command, that is Data Manipulation Language Command. Now Data Manipulation Language Command is basically used whenever we want to manipulate some data, like whenever we want to insert some data, whenever we want to update some data, whenever we want to delete some data, basically doing manipulations on the data. The third command was the DDL command, that is Data Definition Language Command. Now Data Definition Language Command mostly deals with the definition or the schema of the data, basically like creating the table, creating the database, doing some modification in the database, doing some modification in the table. So whenever we are dealing with the schema or the definition of the table, we use this DDL command. Now the fourth one is DCL command, that is basically Data Control Language Command. Now in this Data Control Language Command, we set some controls on our database. So in that case, DCL command is used. The fifth one is TCL command, that is basically Transaction Control Command. So whenever we are doing some transaction and we need some control on that transaction, we use this TCL command. Now in the DQL command, we have already learnt about the select command. In the DML command, we have already learnt about the insert, update and delete command. In the DDL command, we have already learnt about the create and drop command. So in this particular video, we would be learning about the alter command, and then we would be learning about the truncate and the rename command. Now what is alter command? So alter is a DDL command that is used to modify or change existing database objects such as table, indexes or constraints, basically doing some modification in the schema. So whenever we want to do any kind of modification into our database object, into our definition or into our schema, we use the alter command. So consider that right now I am having an employee table in my employee database. Now in this particular employee table, I am having 3 columns, but there comes a requirement where I need to add one more column to this employee database. So this particular addition of column is done using the alter command. Consider that there is one more requirement which comes that you have to change the column name from employee ID to ID. So this particular change is also done using the alter command. So whenever we want to do any kind of modification or changes in our database, tables, schemas, we use this alter command. So let's see all the things that alter command can help us do. So mostly it is used to modify the schema. So whenever we want to do some modification in the columns like addition of new column, deletion of column, modification of column and much more, we use the alter command. So let's see how the alter command is used, the queries, and then we will go to the MySQL workbench and execute all the queries. So the very first use case is adding a column. As I told that alter command basically help us in doing any modification in the schema. So what is the schema? So whenever we provide all the column names or the characteristics of our table, we call this as schema. So whenever we want to add a column, basically doing some modification in the schema, we use the alter command. So the query for adding a column is alter table, then we provide the table name, and then we provide this add, and then we provide the column name, which column we are adding, then the data type of that particular column, and if we have any constraint or not, we provide this. So whenever we used to create the table, we used to provide all these values like the column name, data type and constraint. In the same way, whenever we are adding a column, we provide all the properties like column name, data type and constraint, and we provide this alter command followed by the table, and then we provide the table name in which we want to alter the data. So let's see from the MySQL workbench how we can add a column in our particular table. So here you can see that we already have a database with the name XYZ, and in that particular XYZ we have a table called as employee. Now in this particular employee table, we would be adding one more field, that is employee date of birth, which is not existing as of now. So what we will do is, we will give this alter, and then we will give the table provided by the table name, that is employee. Now we'll add a column DOB, so we'll give add, and then we will give the column name, that is DOB, then we will give the data type, that is varchar, and let's give the character limit as 20. And then we will provide the constraint. So if we execute the query just now, what it will do, that it will create a DOB column name, but all the values in that DOB column name will be null. So if you want any default value to be there, you can give a default constraint. So we can give default, and here we can give the value as NP, that is not present. So if we run this particular query, what it will do, it will first go, it will alter the table employee, it will add a DOB column, and then it will give the default value as NP wherever null is present. So let's just execute this query. So once you execute this query, you can see a success, and when we will try to see all the details of this particular table, you can see that a DOB is created with NP because all the values for now is null. So it has taken the default value, that is NP. Now let's see the second use case of alter command, that is drop a column. So whenever we want to drop or delete a column, we use this alter command. So here you can see we have given the query as alter, and then we provide the table followed by the table name, and then we provide the drop command, then we give the column which we want to drop, and then we provide the column name. So let's go to MySQL workbench and let's just execute this query. So for now we have created this DOB column. Let's just delete only this particular column. So first I'll give alter, and then I'll provide table, and then I'll give the table name, that is employee, and then I will provide the drop command, and then I will provide column saying that I want to drop the column, and then I will provide the column name, that is DOB. Now let's just execute this query. So you can see the query is successful. Let's see that if it has been deleted from our particular table or not. So we'll just execute this query, and here you can see that we can't see any DOB field. So this particular column DOB is deleted whenever we use this alter command followed by the drop command. Now the third use case is modify the data type of an existing column. So whenever we want to do some modification in the data type of an existing column which is present, we use this alter command. So for that we use this modify clause. So the modify clause is oftenly used with an alter table statement in SQL. It allows us to change the definition or the properties of an existing column in a table. So whenever we want to change the definition or the properties of a column in table, we use this alter command along with the modify clause. So here you can see the query. So the query is alter table, then we give the table name like which table we want to do modification, and then we provide this modify command, and then we provide the column name like in which column we want to modify, and then we provide the new data type like which new data type we want to set for that particular column. So the above command modifies the column name to a new data type. So let's go to my MySQL workbench and let's see how it works. So for now let's just modify the data type for age. Let's make age as varchar. So what we will do, we will give alter, and then we will provide table, and then we will provide the table name, that is employee, and then we will provide this modify, and then we will provide the column name, that is age, and then the new data type. So the new data type for age is varchar 3. So let's just execute this query. So you can see that we have got a success. So for now the data type for this particular age column has been changed to varchar. Now the fourth use case is change the name of an existing column. So whenever we want to change the name of an existing column, like in earlier use case we saw that how we can change the data type of a column. In this use case we can know that how we can change the name of that particular column. So the change command is oftenly used with an alter table statement in SQL. It helps us to change the name or data type of a column within a table. So whenever we want to change the name or change the data type of a column in a table, we use this change along with the alter command. So the query is alter table followed by the table name, and then we provide this change. Then we provide the old column name, and then we provide the new column name, like from old column name to the new column name, like what is the new column name you want to give. And then if there is any new data type for that particular column, we provide in this way. So the above command changes the old column name to a new column name and also its data type. So the old column name is changed to new column name, and the new column name has a new data type. If the new column name doesn't have a new data type, you can give the data type of that particular old column name only. So let's go to MySQL Workbench and see. So let's just modify this age column name to employee age. So let's see how we can do. So we'll give this command alter table followed by the table name, that is employee, and then we will provide this change, and then we will provide the old column name, that is age, and then we will provide the new column name, that is employee age. And if there is any new data type, else we need to provide the data type of this age column only. So that is varchar 3. And let's just execute this query. So once you execute this query, you can see a success. So let's see if we are able to see this in our table or not. So let's run this select star from employee. And here you can see that the age column name has now been modified to employee age, that is EMP age. So in this way, using the alter command, we can change the column name as well. So this was one of the way in which we can rename our column. There is one more way in which we can rename either our table, our column, our constraints and much more. That is using the rename command. So the rename command is used to change the name of an existing database object such as a table. So whenever we want to rename the table name, column, so whenever we want to rename the column name, index, or constraint whenever we want to rename the constraint name. So the query for the same is alter table, then the table name, and then we provide this rename. And then we provide like which thing we want to rename, like table, column, constraint, anything. And then we provide the old column name, like here we are renaming the column, so we will provide the old column name. And then we provide this too, like basically you want to rename the old column name to the new column name. So we provide 2 and then we provide the new column name. The above command renames the old column name to the new column name. So let's see from the MySQL Workbench. So what we will do now, we will revert this employee age to age. So what we will do is, we will give this alter table followed by the table name, that is employee, and then we provide the rename, and then we provide what we want to rename, that is our column. So we will provide column, and then we provide the old column name, so that is EMP age, and then we provide this 2, and then we provide the new column name, so we will give this age. So let's just execute this query. So you can see that we have got a success, and when we execute this command, select star from employee to see all the data present in our table. So you can see that now this EMP age has now been renamed to age. So in this way we can rename our column name, table name or constraints. So what is this rename command? Rename command is used to change the name of an existing database object such as a table, column, index or constraint. So whenever we want to do any kind of changes in any of the database object like table, column, index or constraint, we use this rename command. So as the name suggests, rename. So whenever we want to rename or whenever we want to give a new name to a table, a column or a constraint in SQL, we use this rename command. Rename command comes under the DDL command, that is data definition language command. So the data definition language command basically deals with the data definition, the data properties, or we can say the database schema. So whenever we are doing any changes in the database schema, database definition or database properties, so there are many use cases of the rename command like renaming a table, renaming a column or renaming a database. So let's see about all these one by one. So the very first query is table renaming. So whenever we want to rename a table, what is the query to do so? So first we will give this rename command and then we will provide what we want to rename. Basically we want to rename the table, so we will give table and then we will provide the old table name and then we will provide this to and then we will provide the new table name. Basically this query means ki rename the table from the old table name to the new table name. So the above command renames the old table name to the new table name. So let's see from the MySQL Workbench that how it is happening. So let's rename this employee table to the employees table. So what we will do is we will give this rename and then we will provide what we want to rename. So we will provide this table and then we will provide the old table name, that is employee, and then we will provide this to and then we will provide the new table name, that is employees. And we will just execute this query. So you can see that we are getting a success, but here we are still seeing this employee. So we just need to do a refresh all in the schema tab. So once you do a refresh all, you can see that in this particular XYZ database, we have a table with the name employees. So if you try to see all the details of the employee table, you won't be able to see, because right now we have renamed the employee table to the employees table. So whenever we want to see the detail of employee table, if you run this particular query, that is select star from employee, you will see a error, because right now the employee table is not existing in this XYZ database, because we have renamed the employee table to employees. And whenever you give the new name, that is employees, and if you run this query, here you can see that you can find all the details. So in this way we can rename any of the table. Now the second use case is when we want to rename a column. So to rename a column, since it comes under the schema, so what is schema? Schema is basically all the properties or the attributes or the characteristics of table which is displayed by the column. So whenever you want to do any kind of changes in the schema, we use this alter command. So we give this alter, and then we provide the table, and then we provide the table name in which we want to alter the data, and then we provide this rename command, then we provide what we want to rename, that is column, and then we provide this old column name, and then we provide this to, and then we provide this new column name. Like we want to go ahead, we want to alter some data in that particular employee table, and we want to rename a particular column to a new column name. So let's see from the MySQL workbench. So let's just rename this name column to employee name, that is EMP name. So we will give alter, and then we will provide table, and then we will provide the table name. So for now we have modified the table from employee to employees, so we will give employees, and then we will provide rename, and then we will provide what we are renaming, that is column, and then we will provide the old name, that is name, and then we will provide to, and then we will provide the new name of the column, that is EMP name. Just execute this query. And here you can see that now the name has been modified to EMP name, and here we are getting a success. So whenever you will try to fetch all the details or see all the details of the table, so here you can see now that name has been renamed to EMP name. So in this way we can rename any of the column in our particular table. Now the third use case is whenever we want to rename our database. So we give this rename, then we give database, and then we provide the old database name, then we provide this to, and then we provide this new database name. Now in this particular renaming of database, there are many security risks involved, because we can't go ahead and rename any of the database. So there are some security requests and protocols which needs to be accepted before renaming any of the database from the old database to the new database. So it mostly depends on the server to server that if the server allows renaming of database or not. So what is truncate command? This command is used to remove all the rows from the given table, leaving the table empty but preserving its structure. So it basically means that whenever we have a table and there are some data which is fed into our table A, B, C, D, E, F, G, H, I, and whenever we give this drop table name command, so drop table name command, what it does, it basically deletes the table from the database. Then we give this delete command. So delete command basically deletes the data on a given condition. Then this truncate command comes into picture. So what truncate command does, it truncate command clears all the data which is present in our table, but it preserves the structure of the table. Basically you can say that table is there, that is an empty table, all the data inside that particular table is cleared using this truncate command. So let's see from the MySQL workbench how this truncate table works. So here we already have an XYZ database. We will create one more table in this particular XYZ database. We will try to truncate or delete all the data which is present in our table, and then we will see that if our table is preserved or not, or if the structure of table is preserved or not. So we will just create a table with the name salary details. And in this particular table, we will provide some columns. So let's provide the first column as salary, int, and second we will provide increment, and let's just give this also int. So let's just execute this query. So once you execute this query, you can see a success, and when we will go here, we'll do a refresh all. Here you can see that two tables are created. First one is employee table, and the second one is the salary details, which is having salary and increment. Let's just feed some data into this particular table. So we will give insert into, and then we will provide the table name, that is salary details, and then we will provide the manner in which we want to feed the data. So first we will give salary, and second we will give the increment, and let's just provide the values, and here we will start giving the values. So let's just provide the first value as 1200, and the increment is 6%, and the next salary is 1500, and the increment is 4%. Let's just execute this query. So here you can see that we have got a success. So let's see if all those details are fed in our table or not. So we'll give select star, and then we will give from, and then we will provide the table name, that is salary details. And let's just execute this query. So here you can see that all the data which we gave is feeded here. So now let's see that how this truncate command is working. So what we will do, we will just truncate this particular table. So whenever we truncate this particular table, it says that all the data which is present inside the table would be deleted, but the structure will remain preserved. So we'll give truncate table, and then we will give the table name, that is salary details. And let's just execute this query. So here you can see that I've got a success. If I go here and I do a refresh all, I can still see the salary details table is here. It means the data is only deleted, the table is still there. So let's see if all the data is deleted or not. So here you can see that there is no data which is present in salary and increment. So in this way truncate table command works. It basically deletes all the data which is present in our table, but it preserves the structure, or it preserves the table. Only the data is deleted. So firstly, let's start with the truncate command. So truncate command is basically used to remove all the rows from a table. What does this mean? So consider that there is a table employee. And in this employee table, we have some rows, we have some columns. So what truncate command will do? Truncate command will clear all the rows or all the data which is present in our table, which will make the table empty but will preserve the structure of the table. So there would be a table, but that particular table would be empty. There would be no rows in that particular table. All the data would be deleted. So it basically removes all the rows from the table. The command for the truncate is truncate table, and then we provide the table name. Now the next is the delete command. So the delete command is basically used to remove some specific rows from a table based on a given condition. So whenever we want to delete a specific row on a given condition, like delete or remove all the rows where the age is greater than 20. So whenever we are providing some specific condition, it executes the delete operation and it deletes the entire row. So the command for the same is delete from table name, and then we provide where condition. So it basically deletes some rows on the basis of condition, but the truncate deletes the entire rows, like all the rows which are present in our table. The third one is drop command. So the drop command is used to completely remove the table. So it not only deletes the data, it also deletes the entire table. So it removes the existence of table. If in a database there is a table, and if we use the drop command for that particular table, that table would be deleted. There would be no existence of that particular table. So the command for the same is drop table, and then we give the table name. So if this is a table employee, in this particular table, if we are using the truncate command, it will go ahead and delete all the particular data which is present in this particular table, and it will delete all the rows which is there in the table, but it will preserve the structure of the table. Basically the schema of the table would be preserved. If we are using the delete command, it sees that if this particular rows specify the condition, if this particular row specify the condition, it deletes this particular row, but if this row doesn't specify the condition, it leaves this particular row, and if this specifies the condition, it deletes this row. So it deletes the rows based on a specified condition. The drop command entirely deletes the table. So it doesn't only deletes the data which is present in the table, it entirely deletes the table. So this was the basic difference between truncate, delete and drop command in SQL. So what does this distinct keyword means? Distinct basically means unique. So whenever we want any unique values, we use this distinct keyword. So distinct keyword is used with select statement to retrieve unique values from a column or a combination of columns. So whenever we want to retrieve some unique values from a given column or a combination of columns, we use this distinct keyword. Now let's see from an example. Consider that there is a table of employee which is having three columns. First one is ID, second one is name, and the third one is city. So let's just feed some data. So ID is 1, name is Ram, city is Pune, ID is 2, name is Ram, city is Mumbai, ID is 3, name is Radha, and the city is again Pune. So we have made a table, we have entered the detail of 3 employees, and now we want to see that how this distinct keyword is working. So consider that right now I want the distinct values from the city column. So what it will do, it will go to the city column, it will start fetching the values. So the very first value is Pune. Now it has nothing to compare with because it is the very first value. So it will print Pune in the output. Now Mumbai is not existing in row 1. So Mumbai is also a unique value because it is not existing in the upper values. So we will print Mumbai also in the output. Now coming to the third row, that is Pune. So Pune is already existing in row 1, not in row 2 but in row 1. So this value would be discarded. So we would be only seeing Pune and Mumbai in the output. So it gives us the distinct value for the city column. Now consider that we want a distinct value in a combination of columns. Consider that we want to see distinct values in name and city. So what we will do in the output, first for Ram and Pune there are no any values to compare. So it will give Ram and Pune in the output. Now coming to the second row, it will see that is there any combination of Ram and Mumbai together present in any of the above rows. So it can find the name as Ram but the city is Pune. So there is no combination with the name Ram and Mumbai. So it will print Ram and Mumbai now. And now coming to the third column, so it will search for the name as Radha and city as Pune. So it will see in row 2 and row 1, is there any name of Radha existing along with the city Pune. So there is no combination of Radha and Pune. So it will print Radha and Pune as well. So in this way we can either get the distinct values from the combination of column or from a single column. So to get the value from a single column we use this query, that is select, and then we provide this distinct keyword, then we provide from which column we want the distinct value, and then we give from, and then we provide from which table we want this distinct value. So select distinct, then the column, and from table name. When we want to have a combination of distinct values, so we give this select distinct, and then we provide all the columns from which we want the distinct value or the combination of columns, and then we provide from, and then from which table we want the distinct value. So let's see from the MySQL workbench that how this distinct keyword is working. So here let's just create a database with the name company, let's just create a table with the name employee, insert some details into that particular employee table, and let's just use this distinct keyword. So to save the time I have already written the query, so we will just execute this create database followed by database name, which will create a database of company in my schemas tab. So here you can see a database with the name company is created. Now I will execute this use company, which will tell the server that all the operation now needs to be performed in this particular database. Now I will create a table employee in this particular company database. So here you can see a success. Once I do a refresh all here, I can see in table our employee table is already created. Now let's just fill some details into this employee table. So we will execute this insert into command, and here all the details have been fed. Now let's see that if all the details are fed correctly or not. So here you can see that ID, name, age, department, city, salary, all the details have been fed for 5 of the employees. Now let's use the distinct command. So I want to see the distinct value of department in this particular employee table. So I'll give the query as select distinct, then I will give the column name, that is department, and then I will give from, and then I will provide the table name, that is employee. So it will give me the distinct value of this particular department. So let me just execute this query. So once I execute this query, you can see that I am getting all the unique department names, that is IT, HR, marketing, and finance. So in this way we can see the distinct value from this particular column, that is department. Let's see some distinct value from a combination of columns. So I want to see a distinct value, select distinct, and the column from which I want to see the distinct value together is age and department. So I'll give department, and then I'll give age, and then I will provide from, and then I'll give the table name, that is employee. So let's just execute this query. So once you execute this query, you can see that IT, HR, IT, marketing, and finance, and with the IT here is the age as 25, with the IT here the age is 27. So you can see that in the department we can see that IT is repeated twice, but when we see the combination of department and age, that is IT and 25, IT and 27, there are no any other combination existing with the same. So in this way we get the combination of distinct value for 2 columns. So what is operators in SQL? So whenever we want to perform any operations on the data, we use operators. So consider that there is a table. In that particular table, there are many sets of data. So whenever we want to perform any operation on that particular set of data, we use the operators. Now operators are of various types. Let's see about each and every types of operator. So the very first operator is arithmetic operator. Now in this arithmetic operator, we have addition, subtraction, multiplication, division, and modulus. Now let's see an example of arithmetic operator. Consider that my table is not updated from the last 1 year, and in this particular year there are some people who are about to retire. So I'm writing a query in which I am checking the people whose age plus 1 is equal to 60. So here I have written select star from employee where age plus 1 equals to 60. So it will give me all the details of a person whose age is equal to 60. So in this way we can use the arithmetic operator. We can also use the subtraction, we can also use the multiplication, we can also use the division. Now here comes the modulus. Now what is modulus? Modulus basically gives us the result of the remainder. So whenever we are dividing any two numbers, like whenever we are dividing 2 by 4, so we get remainder as 0. So this is the modulus. Now the second operator is the comparison operator. In the comparison operator we get this equal to, not equal to, greater than, less than, greater than or equal to, or less than and equal to. So let's see from an example. I want to see the details of all the employees whose age is greater than 20. So I'll use this select star from employee where age greater than 20. So here I have used the comparison operator, and here I am getting the details of all the person whose age is greater than 20. I can also use this age equal to 20 if I want the details of all the person whose age is equal to 20, or I can also use age greater than or equal to 20, which will also include the 20-year-old employee. Now the third operator is the logical operator. Now in the logical operator we have 3 operators. So the very first is AND, the second is OR, and the third is NOT. Now AND operator basically combines 2 conditions and return true if both of the conditions are true. So consider that we have given 2 conditions, that age is greater than 20 and city is equal to Pune. So it will give the output only when it finds a age which is greater than 20 and the city which is equal to Pune for a particular employee. So here you can see an example, select all from employee where city is equal to Pune and age is greater than 80. So consider that there is a table having age and city. Now in age we have some values as 18, 20, 25, 29, and in city we have Pune, Mumbai, Pune and Pune. So what it will do, it will match for both the conditions. So first it will see where the age is greater than 80 and city is Pune. So for the very first row, is the age greater than 18? No. So if one condition is discarded, it won't see for the other condition. Now for the second row, is age greater than 18? Yes. Is city equal to Pune? No. So this one is also discarded. Now for the third row, is age greater than 18? Yes. Is city equal to Pune? Yes. So it will show 25 Pune in output. Now for the fourth row, is age greater than 18? Yes. Is city equal to Pune? Yes. So it will show all the details of this particular employee as well. So it will show all the details of this employee and this employee. Now the second operator is OR operator. So it combined two conditions and return true if either is true. So if age is greater than 80 but city is not equal to Pune, it will return all the values. If city is equal to Pune and age is not greater than 80, it will also return that values. So consider in the same table. So for the very first row, is age greater than 18? No. Is city equal to Pune? Yes. So it will show the details of this particular employee. Now is age greater than 18? Yes. So it will not check for the second condition. So it will show the details of this particular employee. Now is age greater than 18? Yes. So it will show the details of this particular employee as well. Is age greater than 18? Yes. So it will not see for the third value because the first value is getting corrected. So age is greater than 18. The first condition is evaluating as true. So it doesn't need to see the second condition. Now for the NOT, it reverses the result of a condition. Return true if condition is false. So consider a condition where I want only the details of a person who are not in IT or HR department. The persons who are in other department, I want only the details of that particular person. So we can use the NOT operator there. So here you can see a query, select star, which means all, from, and then we provide the table name, that is employee, and then we provide it here where, and then we provide department, here we provide not, and here we provide a in operator about which we would be discussing in further slide, and here we have given all the department in which we don't want the particular employee to be. So if our employee is not in IT or HR department, give me all the details of that particular employee. So it will give me all the details of that particular employee whose department is not in IT or HR. Now what is this in operator? So in operator basically checks a value matches a list of value or not. So in this in operator we provide some list of values. This list of values can either be in this particular department column or cannot be in this particular department column. So basically it checks that if in this particular department column, if these values are existing or not. If these values are existing, return the record of that particular employee. If these values are not existing, then don't return the record of that particular employee. So it basically gives select star from employee where department in IT or HR. So it returns all the employees details whose department are in IT or HR. So let's see about all these operators from MySQL Workbench. So here we have a company database. In that company database we have an employee table. So let's see for the logical operators. So let's see for the AND operator. So for the AND operator we will give select star from, and then we provide the table name, that is employee, and we provide the condition where age is greater than 20 and department is equal to IT. So give me the details of all the employees whose age is also greater than 20 as well as the department is ID. So let's execute this query. So once we execute this query, we can see that we are getting the details of all the employees whose department is IT and the age is also greater than 20. So in this way, we can fetch all the details of a particular employee in which the age is greater than 20 and the department is also IT. Now let's just do some manipulation in the same query. So we will see for the OR operator. So here we will see the query for the OR operator. So we will be using the same query, and in the place of AND we will be using OR. So give me the details of all the employees whose age is greater than 20 or the department is IT. So it will search for all the employees whose age is greater than 20, either the department is IT. So let's just run this query. So once we run this query, we can see that we are seeing much more details this time. Like we are seeing the details of all the 5 employees, because for all the 5 employees the age is greater than 18. So it's not seeing for the second criteria, that is department equal to IT. On the basis of age is greater than 18, it is giving me all the results. Now let's see for the NOT operator. So for the NOT operator, we will give select star from employee, and then I want the details of all the employee where department not in either IT or HR. So give me the detail of all the employees where department is not either IT or HR. So let's just execute this query. So here you can see that I am getting the details of all the employees whose department is neither IT or HR. We are getting the department for marketing and finance. So it will basically give me the details of all the employees whose department doesn't lies in this particular list. So in operator basically checks that if in this particular list are there any department which is existing here or not. So if we are using in operator, let's see for the in operator how it works. So in operator, so for the in operator what we do is we give this command select star from employee, and then we want the details of all the employees whose department is IT or HR. So whose department is having values either IT or HR. Now you will say that why are we even using this in operator? We can use this or operator. We can provide department is equal to IT or department is equal to HR or department is equal to marketing. Yes, we can provide it here, but here it's very easy to provide because we can provide list of values. We can also provide those values which are not present even in this department column. So it makes us very easy to compare between the list of items and the item which is present in our column. So let's just execute this query. So here you can see that we are getting the employee details for all the employees whose department is either IT or HR, or basically the department which lies in this particular list. So whenever we give not in front of in, it basically makes sure that give me details of all the employee whose department is not in IT or HR. So it basically reverses the result which we get in using in operator. So now the next operator is null, is not null operator. So basically is null operator checks for the null values, is not null operator checks for the not null values. So whenever we want to check for any null or not null values, we can use this is null and is not null operator. So here you can see a query where we are checking that give me the details of all the employees where department is not null. So give me the details of all the employees where there is no null present in the department column. So it will give me the details of all the employees. So let's see for the not null operator or null operators. So here we will see about the not null, is null and not null operators. So give me the details of all the employees where department is not null. So let's just execute this query. And here you can see that we are getting the list of all the employees where department is not null. For now there are no null values which is present in department, but you can understand it in this way that if there are any null values for any particular record or any particular employee, it will not show that particular result. Now let's see the next operator, that is the bitwise operator. So there are two operators in bitwise. First one is and second one is OR. So in bitwise operator, what it does, it basically converts the integer value into bits and then perform any of the operation either and or on in this particular bits. So for now bitwise operators is not something which is very concerning to us. So for now we are skipping the query for this because it's not very used, but you can understand that in bitwise operator we convert the integer into bits and then we perform any of the operation like and or on the bits itself. Now the next operator is the like and the wildcard operator. Now what is this like and wildcard operator? Like operator is used to search for a specified pattern in a column. So whenever we want to search for a specified column, like give me the details of all the employees who are having double A in their name. Give me the detail of all the employees whose names start with A. So whenever we are trying to search for a pattern, we use this like or wildcard operator. It uses wildcard operators for matching patterns. So this like operator basically uses the wildcard operators for matching patterns. Now the very first wildcard operator is the % sign, which basically matches for any sequence of 0 or more character. The query is given as select star from employee where name like. So here you can see the like operator is given and here we are provided A and %. So what does this mean? So it basically means give me the detail of all the employees whose name starts with A and can have many more characters after their name. So consider that a person is having a name as Abhay, a person is having a name as Aman, a person is having a name as Ayush. So all these employee names we can see because these all employee names start with A and have 0 or more set of characters after that. So basically like search for a specified pattern and returns the value whenever it matches any of the pattern which is given here. So if I give R and percent, so it will give me the details of all the employees whose names start with R and can have more characters in their name. Either it can be 0, either it can be 1, either it can be 2, or either it can be many. So Riti will also qualify for this, Ram will also qualify for this, Rahul will also qualify for this, because the number of characters after R does not matters because it is given as percent. So percent basically replaces all the characters and it will find that all the names start with R. So these qualify for this particular query. Now for the second wildcard we have underscore. So it matches for any single character. So here percentage matches for any set of characters. But if we are giving underscore, it means that there should be only a single character. So here you can see a query where I am getting all the details of employee, where name, like, and we have given a single character any. So give me the details of all the employees whose second character in the name is having A. So first character can be R, can be A, can be B, can be C, anything. But the second character in the name should always be A. So it basically matches for a single character. Now let's see from a MySQL workbench and understand that how it's working. So let's use for the like operator. So we will use the like operator when we are using the wildcard as percent. Let's fetch all the details of employee whose name starts with A. So we will give select star from employee, and then we will give where, then we will provide name, and then we will provide this like operator, and inside the inverted comma we will provide the character for which we are searching, and then if there can be any number of characters or not. So we'll just execute this query, and once we execute this we can see that we are getting the details of all the employees whose name is starting with A. It doesn't matter that how long the name is, it doesn't matter that how many characters are there after A, but they are having the name as A in the very start. Now let's see for the like operator using the underscore wildcard. So we will give like operator when using a underscore wildcard. So let's get all the details of a person who is having the second letter or second character as A in their name. So select star from employee, and then we will give where, and then we'll provide name, and then we will give the like operator, and here we will leave the first character can be anything, and then we will give the second character as A, and then we will give this percent sign that after the second character there can be many characters. So we will just execute this query. So once you execute this query, you can see that we are getting the details of two employees, Rahul and Raj, who are having A as the second character in their name. It doesn't matter what is the first character. It doesn't matter that how many more characters are there after A. We are getting the details of all the employees who are having A as the second character in their name. Now the next operator is the between operator. So between operator basically checks if the value is within a range of values. So consider that we have given a range of values, if a values lie between this range or not. So here you can see that we are trying to fetch all the details of a person whose salary lies between 1200 or 1500. So select all details from employee where the salary lies between 1200 and 1500. So let's see from the MySQL workbench. So we will see for the between operator. So let's fetch the details of all the employees whose salary lies between 1200 to 1500. Employee where salary between 1200 and 1500. So we'll just execute this query. So here you can see that we are getting the details of two employees whose salary is 1500. So basically this between operator is an inclusive operator. Basically it means that it will search for an employee who is having 1200 salary as well, and it will search for an employee who is having 1500 salary as well, and then any salary which lies in the range. So it includes this also and this also. So what are clauses in SQL? Clause basically means condition. So clauses are like tools or condition that help us to make queries more specific or decide what data we want to fetch. So whenever we want to fetch some data which is specific to some of the condition or specific to some of the clause, we use the clauses in SQL. So here we have mentioned all the type of clause which are there in SQL. So the very first one is where clause, which we know that which is used to filter out data. Now the second clause is the group by clause. The third clause is the having clause. The fourth clause is the order by clause, and the fifth clause is the limit clause. For the group by and having clause, we will learn about this after aggregate function, because this works on a aggregated set of data. But for where, order by and limit, we would be learning in this particular video only. Now the query for using a clause is we give select, and then we provide if we want to give any kind of condition on a given row, then we provide from, then we provide the table name, and then we provide the clause, and then we provide the condition. So whatever is the clause and whatever is the condition, perform all these on these particular columns. Now the very first clause is the where clause. Now where clause is basically used to filter the row based on the specified condition. So the query for the same is select column from table and where condition. So let's assume an example where I want to see or fetch all the details of a person whose age is greater than 20. So we are filtering out all the employees whose age is greater than 20. So we will give select star, that is all, from employee where age greater than 20. So it will give me the details of all the employee whose age is greater than 20 from a table employee where there could be multiple employees with the age 25, 26, 18, 17 and much more. Now the second clause is the limit clause. So the limit clause in SQL is used to restrict the number of rows returned by a query. So consider that I am writing a query for giving me all the details of a person whose age is greater than 20. But I want only 3 of the employees whose age is greater than 20. Or let's just understand in this way. Consider that there is a school. Now in that particular school there are 5 students who have scored above 90. But I want the details of only top 3 people who have scored above 90. So what I'll do, I'll just use this limit clause which will put a limit to the result which we have got. So this query retrieves the first n rows from the table. So whenever we provide a limit n, it will just give me the n rows from the table. Consider we provide the limit for 2 rows, so it will only return me the 2 rows, or 3 rows, then it will only give me the 3 rows. So here n can be 1, 2, 3, anything according to your condition or according to your use case. Now the query for the same is select column 1, column 2, or any of the column, or if you want all the details you can use the star, then from, then table name, and then here we provide limit, and then we provide the number of rows, like how many number of rows we want. Consider that we want to only see the details of 2 employees. So what we can do is select star from employee, and we can provide limit, and we can provide 2. So it will give me the details of only 2 employees from all the employees. So let's see from the MySQL workbench. So consider a condition where we want to only see the details of 2 employees. So what we will do is we will give select star from employee, and then we will give the clause, that is limit, and then we will give the condition, that is 2. So give me the details of only 2 employees. So let me just run this query. So here you can see that we have got the details of only 2 employees. So in this way limit clause work. So here we can provide the value either 2, 3, 4, 5 according to your use case. Basically limit sets the limit to the returned results. So consider that if I want to see the details of all the employee, it will return me the details of 5 employees. But in that particular 5 employees, I want to put a condition that give me the details of only 2 employees. So limit sets a limit on all the values which is returned. Now the next clause is the order by clause. Now the order by clause is used to sort the results in either ascending or descending order. So whenever we want our results to be sorted in either ascending or descending order, consider I want to see the details of all the employee whose salary is highest from lowest. So we can use this order by clause. Now by default it returns the result in ascending order. So if we haven't provided the order, it will by default return the result in ascending order. So this query retrieves the first n rows from the table. Now the query is select, and then we provide if there are any columns from which we want to see the data, and then we provide from, and then we provide the table name, and then we provide this order by clause, and then we provide the column, and then we provide either ascending or descending. So basically we provide the order by, and we want the order by to be performed on this particular column, and we want the results to be filtered in either ascending or descending order. So here you can see an example, select star, which basically means all, from the table name employee, and then we provide the clause order by, and then we provide the column in which we want the order by clause to be executed, that is salary, and then we provide the manner or the fashion in which we want to see the result, that is descending. So it will basically give me all the employee details with the salary in the descending order. So let's see from the MySQL workbench. So here we will be seeing about the order by clause. So we will use the select star from employee. We want to see the details of all the employee who is earning the salary from the highest to lowest. So we will select star from employee, which will give me the details of all the employees, and then I will put a clause order by, and then I will provide from which column we want to order the details. So we will give salary, and then we will provide that in which manner we want to see the salary, that is in descending order. So let's just execute this query. So once I execute this query, here you can see that we are seeing the salary in the descending order, like the one who is earning the highest is at the very first, and the one who is earning the lowest is at the very last. If we don't give any manner like ascending or descending, it will by default take the ascending. So let's see without giving any order. So here you can see that by default it is giving me the results in ascending order. So this is all about the order by clause in SQL. Now let's do some practice question. So the very first question is write a SQL query to fetch the details of employees having ID as 1. So we have to write a SQL query where we have to fetch the details of employee who is having ID as 1. So we will write select, and then we will give all, and then we will provide from, and then we will provide the table name, and then we will provide the where clause, and then we will provide ID, and then we will provide a comparison operator, and then we will provide 1. So give me the details of all the employees where ID is equal to 1. So here we are seeing the use of where clause. Now let's go to the next question. So the next question is, write a SQL query to fetch the details of all the employees who are having ID as 1 and city as Mumbai. So give me the details of all the employees who is having ID as 1 and city as Mumbai. So here we'll be using this query, select star from employee where ID equal to 1, and because we are seeing that ID is also 1 and the city should also be Mumbai. So both the conditions should be true. So ID equal to 1 and city equal to Mumbai. Now the next question is, write a SQL query to fetch the details of employees who are having salary greater than 1200 and the city as Mumbai. So we want to fetch the details of all the employees who are having salary greater than 1200 and the city as Mumbai. So what we will do is we'll give this query select star, which basically means all, from employee. So it will fetch all the details of this employee table. Now on the all the details we have to perform some condition. So where salary should be greater than 1200 and city should be equal to Mumbai. So this is how we are writing this query for this particular practice question. Now the next practice question is, write a SQL query to fetch the details of employees who are not from Mumbai. So we want the details of all the employees who are not in Mumbai or not from Mumbai. So we will give this select star from employee, which will fetch me the details of all the employees. Then we will provide this where condition and we will provide city not in. So basically not in, make sure that in this particular list whatever thing is given is not present in the city column. So if this particular data is not present here, it will return me the details of that particular employee. So city not in, and here we provide Mumbai. Now the next practice question is, write a SQL query to fetch the details of employees having the maximum salary. So we have to write a query to fetch all the details of our employee who are having the maximum salary. So we'll give select star from employee. So here we'll get the details of all the employees, and then we will provide this order by clause, which basically makes sure to give the results in a certain order, and then we will provide which column we want to order, that is the salary. So we will give the salary column, and here we want the maximum salary, so we will provide the order as descending. So in the descending order we'll get the maximum salary as the very first record. Now the next query is, write a SQL query to fetch the detail of 2 employees who are having the maximum salary. So here we have to break the problem, is we have to fetch the detail of only 2 employees who are having maximum salary. So for the maximum salary we can use the order by clause followed by the descending order on the salary column, and for the 2 employees we can use the limit clause. So what we will do is we will write the query is select star from employee, and then we will try to fetch the maximum salary. So we will give order by, and then on which particular column you want to order, that is salary, and then in which manner you want to get the details of salary, that is descending, and then we will limit that particular result which we get from here to 2 employees. So in this way we can get the details of 2 employees who are having the maximum salary. So this was all about the practice question and clauses in SQL. We will learn about group by and having clause in next set of videos. So what does this aggregate means? Aggregate basically means collated. So all the functions or all the methods which is helping us to do some manipulations or do some calculations on a collated or collected set of data, that is called as aggregated function. So let's see the definition. So aggregate function performs some operation on a set of rows, you can say collection of rows, and then returns a single value summarizing the data. These are used with select statements to perform calculation. Now let's understand from an example. Consider that you have an employee table with you. And now in this employee table you have some columns such as ID, salary, employee name. Now there are many employee data which are feeded inside the system. For now consider that we have feeded 3 employee details, employee E1, employee E2 and employee E3. Now if we want any kind of manipulation or any kind of value from the given set of data or from the collated set of rows, we use the aggregated function. Now what kind of value we would be desiring? So consider that I want to find that what is the maximum salary a person is getting from all the employees. So we can use the max function which is present in aggregate function. If I want to know that what is the minimum salary our employee is getting in the company, so we can use the minimum function. What if I want to know the average salary company is giving to our employee? So we can know the average salary by collating all the data which is present in the row and doing manipulation on all the salary which is present there. In the same way we can know the total salary using the sum function. Also we can count how many employees are there using the count function. So as you can see that this particular minimum function will first go to employee E1. It will see that what is the data present. It will take the data. Consider the salary is 1200. Now in the employee E2 it will go and see if the salary is less than 1200. If it's 1300 it will ignore this. Then it will go to E3. It will see if the salary is less than 1200. It's 1100. So now it will erase this 1200 and have 1100 in the output. Now it will go to the 4th column, see if the salary is less than 1100. So it's 1500. So it will ignore this. So the final output we will get is 1100. So the minimum salary of an employee in this particular employee table or in a company is 1100. In the same way, it can calculate the maximum value. When it wants to calculate the sum of entire salary, it will just add the salaries of employee E1, E2, E3, E4, and it will get the total salary which the company is giving to the employees. Now, there are many types of aggregated function, as I told here: min, max, average, salary, sum. So let's see about them. So the first one is count, which basically help us to count all the rows which is present in our table. The second one is sum, which is basically used to sum all the numeric values which is present in our table or in our column. The third one is average, which gives us the average of a particular aggregate or collated set of rows. The fourth one is minimum, which gives us the minimum value in a collated set of rows. The fifth one is maximum, which gives us the maximum value in the collated set of rows. And the sixth one is group concat, which is basically used to concat two groups. Now let's see about each and every aggregated function one by one. So the very first aggregated function is count. Now what is count? It counts the number of rows in a table or the number of non-null values in a column. So consider that in my table there are some columns and I want to count that how many people are there who are getting salary. So the salary details for each and every employee is feeded. Consider it is A, B and C here. So it will count 1, 2 and 3. So it will result the value as 3. That 3 employees are there in the company who are getting a salary. If there is a null value which is present here, like employee has joined the company recently but it hasn't been paid yet. So for this it will ignore this value and it will only give the 3 values. So it counts the number of rows in a table or the number of non-null values in a column. So basically in a column, if there are any non-null values, it counts the value and returns the output. So the query for the same is select, then we give the count, and then we provide in which column we are providing this particular aggregate function, and then we give from, and then we provide the table name, that is employee. So this will tell us the number of employees in a company. So we are giving a count on the name. So basically it will count all the name of employees and it will tell me, okay, in your company there are X number of employees who are working. So let's see from the MySQL workbench that how this count aggregate function is working. So for now, we will learn about the count function. So now what count function will do is, let's see that what all details are there in our employee table. So we will just execute select start from employee to see all the details. Now here you can see that there is ID, name, age, department, city and salary. Now I want to count the number of employees in my company. So what I'll do is, I'll give this command as select and then I'll provide the aggregate function, that is count. And then I'll provide that which particular column I want to count. So I can get the count of employee using the ID, name, age, department, city, salary, any of the columns. But for now, let's take the name column because name is something like all the employee would be having a name. So let's calculate from the name column only. So we'll give name, select count name, and then we will provide from and the table name from which we are trying to find the count employee. And let's just execute this data. So here you are seeing that we are getting the count as 5. So we have feeded the details for 5 of the employees and we are getting that in your company there are 5 employees who are existing. Now let's see the second aggregate function, that is sum. So what is sum? Sum basically calculate the sum of all the values which is present in a numeric column. So whenever there is a column which is having numeric values, we can use this sum function. Consider salary. So this adds up all the number which is present in the list. So if in the list of all the rows which is present inside a column, it adds up all the salary and gives us the desired salary or the total salary. So here you can see we have provided a query where we are giving select and then we are providing the aggregate function and then we are providing the column on which we are taking the aggregate function, that is salary, and then we are providing from and then we are providing employee. So this particular query will give me the total amount company is paying to its employee. So it will tell me the total amount which the company is paying to its employee so that the company can make their budget. So let's go to the MySQL workbench and see how the sum aggregate function is working. So we will just do select and then we will give sum, the aggregate function, and on which particular column we want the sum. So we will give salary and then we will give from and then we will give the table name, that is employee. So let's just execute this query. So here you can see that we are getting the total sum of all the salaries which were present in the salary column. So this works the same way on how we are trying to fetch the details from the table. It's just that while fetching the details, like while fetching any of the column, we are providing an aggregate function to get a collated data or to get a collated result of all the rows which is present inside our column or all the records which is present in a single column. Now let's go ahead with the third aggregate function, that is average. Now it computes the average of all the values in a numeric column. Again, for average also we need a column to be numeric. It can't hold any varchar or string values. It needs to have a numeric value, and whenever we want the average of all the numeric values, we can use this average function. Now it finds the average or the middle number of the numbers in a list. So consider that company wants to know that what is the average salary they are giving to the employees. So they can use this average function which can tell you, okay, this is the average salary a company is giving to their employees, or this is the average fees we are getting from the students. You can take that example as well. So here you can see the query where we are getting select And then we are giving the aggregate function, that is average. Then we are providing the column on which we are doing this aggregate function, that is salary. And then we are giving from, and then we are providing the table name, that is employee. Now this query will tell the average amount company is paying to its employee. So let's see the average function as well. So we will see for the average function, the average salary company is giving to its employees. So we will give select average, and then we will provide the column name, that is salary. So always make sure that these functions like salary, sum, it works only on the numeric columns. So you can't use that in a column which is having varchar or string values. So average salary, and then we can give from, and then we provide the table name, that is employee. So let's just execute this query. So here you can see we are getting the average salary a company is paying to their employees. So let's look at the fourth aggregate function, that is minimum. So minimum help us to find the smallest number in a list. So whenever there is a list and we want to find the minimum value or the minimum salary a company is giving to its employee, we can use this minimum function. In the same way, we can also use a maximum function which tells us the maximum value in a particular column. So this minimum function tells us the minimum value, that is min, tell us the minimum value, and max, that is maximum, tell us the maximum value. So here you can see the query we have given. Select, and then we provide the aggregate function, that is minimum, and then the column on which we are providing this aggregate function, that is salary, and then we provide from and which table name, that is employee. So this will tell the minimum salary company is paying to its employee. And in the maximum, we do the same query, it's just that minimum is replaced by maximum. So we give select max, and then we provide the column name, that is salary, and then we provide from, and then we provide the table name, that is employee. So this will tell the maximum salary company is paying to its employees. So let's go to the MySQL workbench and see how it's working. So the next aggregate function is minimum. So we will give the query as select minimum, and then we will provide the column name, that is salary, and then we will provide from, and then we will provide the table name, that is employee. So let's execute this query. So once you execute, you can see that you are getting the minimum salary as 1500. Let's just verify if 1500 is the minimum or not. So let's see all the details of this employee table. So here you can see that the salary is 1500, 2000, 2500, 2400, and 1500. So 1500 is the minimum salary which is present in our employee table. And in the same way, we can find the maximum salary as well. So we have to just replace minimum with maximum, that is max. So we'll just replace minimum with maximum, and we will just execute this query. So once we execute, we can see the maximum salary is 2500. Let's just verify from our table details also that if the maximum salary is 2500 or not. So if we run this query, we can see that there is 1500, 2000, 2500, 2400, and 1500. So from here also we can verify that 2500 is the maximum salary which our employee is getting. So while we were learning about clauses in SQL, I left these two clauses, group by and having clause. So let's know that why I left both of that clauses, and let's see that how are they helping us. So what is this group by clause? So whenever we want to group data, we use the group by clause. So this clause is used to group rows that have same values into together. It helps to organize data into groups so that they can do calculations like finding totals, averages for each group. So in the last particular video of aggregated function, we learned that if we want to perform any operation or any function on some collated set of data, we use the aggregated function. Consider that there is a salary column in my employee table. If I want to know the minimum salary among all the particular rows which are present in my table, we can use the minimum function. If I want to know the maximum salary, we can use the maximum function, which will see in all the rows and give a single result on this collated set of rows. Now how this group by clause help us? So consider that for now we were finding the salary, the minimum and maximum salary for all the employees, but consider that there are some departments in the employee. So one is the IT department, one is the HR department, one is the marketing department. Now what if I want to know the minimum salary in the IT department or the maximum salary people are getting in the HR department? In IT we have 2 employees, E1 and E2. In HR we have 2 employees, E3 and E4. In marketing we have 3 employees, E5, E6 and E7. So earlier what it used to do in aggregate function, it used to see for all the employees E1, E2, E3, E4, E5, E6, E7 and used to provide us the minimum and the maximum salaries. But now what will happen that it will see only in a group of data, like only in the IT department there are 2 employees, among the 2 employees give me the minimum salary, or among the 3 employees in the marketing department give me the maximum salary. So you can see that how we are working on a group of data. So this can be achieved using the group by clause. Now the query retrieves the first n rows from the table. So let's see the query. So the first is select, and then we provide the column name on basis of which we are grouping all the rows. So basically here we are grouping the rows on the basis of department. So we will provide department on like basically the column name on basis of which we are grouping all the things. Now then we will provide the aggregate function, and then we will provide the column on which we are providing the aggregate function. Like I am grouping all the fields based on department. Now in the department they are grouped into IT, HR and marketing, and now in the department we are finding this minimum or maximum using the salary. So salary is basically the column on which we are using the aggregated function, in which we are trying to get the collated data, and then we are also grouping the all the values on basis of the department. So basically we provide the aggregated function, then we provide the column 2, that is salary, and then we give from, and then we provide table name, and then we provide this group by clause, and then we provide the column on basis of which we are grouping the elements, that is column 1. So here you can see that an example is given here where I am selecting department, and then I am giving the aggregate function average, and then I am providing on which column I am using the aggregate function, that is salary, and here you can see that I have given a as. So basically what as does is it will calculate the average salary, and it will create another column with the name average salary, and it will show all the details which is present here, and then we give from, and then we provide employee, and then we provide the group by clause, and then we provide the column on basis of which we are grouping the elements. This is how the group by clause work. If you are still not understanding that how the group by clause work, let's just understand it again. So let me just clear all the data which is present here, and we will then see that how this group by clause is working. So let's take an example. Consider that there is a table of employee. Now in this employee table we have department and salary. For now I am only taking 2 columns just to make it a bit simpler, and then here are the details of some of the employees. So one of the employee is in IT department, the next employee is also in IT department, one is in HR, one is in marketing. Let's take one more. So that is also in HR. And now the salaries are 1100, 1200, 1100, 1500, 1100. Now what this particular query will do? So what it will do, it will select department. Now it will select the department column. So it will select the salary column as well. Now what it will do, it will group by the department. So what it will do, it will make the group of departments. So the very first group which will be present will be of IT. Now IT is having 1100 as salary and 1200 as salary for 2 of the employees. Then it will make a group of the HR department. Basically the similar values will be together. So IT both are similar, so that will be in one group. Now HR, are we finding any HR? So HR is also present here. So we have 2 values for HR as well. First is 1100, second one is also 1100. Now the next one is marketing. Is there any group for marketing present? No. So there is only one employee in marketing, that is 1500. So we have formed 3 groups, IT, HR and marketing, and we have give the respective salary of all these 3 groups. Now what it will do, now it will perform this aggregate function which is average salary. So what it will do, it will find the average salary between these 2 employees, and it will give a single result of the average salary for IT department. Then it will perform the aggregated function on these 2 groups, and then it will provide the average salary for the HR department. Now it will do like there is a single element, so it won't do much of the thing. So it will just provide the average salary of the marketing department, which will be 1500 only. So in this way we can find the average salary per department. So in this way we are trying to group the data, and in this way we are trying to aggregate the data and perform some aggregated functions on the data. So let's see from the MySQL workbench, then it would be more clear from there. So let's go to the MySQL workbench. So let's see that how group by clause is working. So what I'll do is I'll give the command select, and then I'll select department because I want to group them on the basis of department, and then I will give that what I want to do the aggregated function on. So basically I want to do the aggregated function on salary. I'll give this average salary, and then I'll give from, and then I'll provide the table name, that is employee, and then I'll provide the group by clause, group by, and then I'll provide the column name on the basis of which we are grouping the elements. So we are providing as department. Now in the query, if you remember, I've provided this as, and then I've provided a new name, that is average salary. So let's see that what it will do. So I'll provide as, and then I'll provide a average salary column, like a new column name. So let's just execute this query. So here you can see that we are getting department as IT, HR, marketing, finance, and here you can see that a new column with the name average salary is having all the values of the average of IT, the average of HR department, the average of marketing, and the average of finance. So in this way this as function works. So the next one is the having clause. So the having clause is just like the where clause, but the main difference is it works on aggregated data. So where clause can work on non-aggregated data, but having clause is something which only works on an aggregated data or collated set of data. So it is used with the group by clause, and it helps to filter groups based on a given condition. So consider that if we want to give some condition during grouping of the elements, we can use the having clause. Earlier, whenever we want to provide any condition, we were using the where clause, but whenever we are providing any condition on a collated set of data or aggregated set of data, we use the having clause. So here you can see the query. So we give select, and then we provide the column on basis of which we are grouping the data. Then we provide another column on basis of which if we want to group the data on basis of 2 columns, so we provide both the columns, and then we provide the aggregated function, and then we provide the column 3. the column on which we are aggregating the data, and then we provide this from, and then we provide the table name, and then we provide this group by clause, and then we provide like on which columns we are grouping, so column 1 and column 2, and then we provide this having clause, and here we provide the condition. So whenever I want to provide any condition during group by clause or in aggregated function, we use this having clause. Now here you can see that we have given an example where what we are doing is we are selecting the department and we are taking the average salary as salary. So basically we are grouping all the departments and we are taking the average salary from all the departments. So from here we give the table name, that is employee. Here what we are doing is we are grouping all the rows which are present in our columns into a single collated groups, like IT is having one group, HR is having one group, finance is having one group, basically all the similar type of elements in one group. And then here we are giving a having and average salary is greater than 1500. So here we are providing a condition. So what it will do, it will first group the departments. So it will group the department into different departments like IT, HR and finance. Now for each and every department, it will find the average salary and average salary. And at the last, it will check that if the average salary is greater than 1500 or not. If the average salary is greater than 1500, it will show this particular result in output. If the average salary is not greater than 1500, it will not show the given result in output. Same goes with the HR department and same goes with the finance department. So let's see from the MySQL workbench that how this having clause is working and how it is helping us to provide conditions. So we will give having clause. So here what we are doing is we are collating all the given rows of the column department into some single groups, and in that particular groups we are trying to find the average salary. After finding the average salary of each group, we are checking that if the average salary is greater than 1500 or not. So let's see how it works. So we will give select and then we will give department, and then we provide the aggregated function, and then we provide the column name in which we want the aggregated function, that is salary, and then we provide this as average salary to show it in a different column. Then we provide from, and then we provide employee, and then we provide how we want to group the data, so group by, and then we provide the column name, that is department, and then here we provide the clause, having clause, so having, and then we provide the condition. So here we have renamed the average salary as AVJSALARY. So we will use this particular column name and we will just give average salary is greater than 1500, and let's just execute this query. So once you execute this query, you can see that we are getting only the department of IT, HR and marketing with the average salary as 2000, 2000 and 2400. So all the average salaries which are present in this particular column are greater than 1500. What if we don't give this having clause and we see that what is the average salary per department? So if you run this query, so you can see that there is a finance department also which is having an average salary as 1500. But we are not able to see the finance department in this particular query because we have given a check that average salary or a condition that average salary should always be greater than 1500. What if I give it as greater than or equal to 1500? So let's see if we are able to see the finance department now or not. So if I run this query, here you can see that we are seeing the details of the finance department also. Let's see all the departments who is having average salary greater than 2000. So we will be only seeing one result. So let's see. So here you can see that we are seeing only one department, that is marketing, that is having average salary greater than 2000. So this is how the group by and the having clause work. Having clause is mostly used with the aggregated function, and it's just like the where clause, we provide the condition in the having clause. Group by clause is mostly used with the aggregated function whenever we want to collate all the rows into a particular group who are having the same values. So consider in department, if there are 5 IT department, we can group all the IT department into one single group. Like if in a school database there are many classes, class 1, class 2, class 3, we can group class 1 into one group, class 2 into one group, class 3 into one group, and then we can see that what is the average fees class 1 is giving, what is the average fee class 2 students are giving, what is the average fee class 3 students are giving. Now in the next set of video, we would be seeing about some practice question which would be helping us to get ourselves familiar with the group by, order by, having and limit clauses. So when I was teaching about this having clause, many people had a doubt that why are we even knowing about this having clause? Like what this having clause is doing. Having clause is basically helping us to filter out data based on a given condition. So was the where clause. Then what was the need of having clause? So what is the where clause? Where clause is a clause which is basically used to filter rows from the result based on a condition applied to a row before aggregation. So whenever we want a filtered data based on a given condition from a table, we use the where clause. But where clause is always used before aggregation. Now what is this aggregation? So aggregation aggregation, or you can say aggregate functions, are the functions which work on some collated or collected set of data and returns a single value based on some manipulations. Like if we want to find the maximum salary, if we want to find the minimum salary among all the employees, we can use the aggregate function. So aggregate function mostly works on a collated or collected set of rows. So whenever we want to work on some collected or collated set of rows, we use the aggregate function. And here it is saying that where clause is a clause which should always be used before the aggregate functions. It means that we should always be using it on an individual rows, not some group of rows or collected rows. Now what is having clause? So having clause is a clause which is used to filter rows from the result based on a condition applied to a row after aggregation. So whenever we have formed a group, such as like there is a group of IT department people, there is a group of HR department people, there is a group of marketing department people. Now in this particular groups, if we want to provide any condition to filter out some data, we use the having clause. So where clause is mostly used before the aggregate functions, and having clause is mostly used with the aggregate function. Now where clause is mostly used with the select, update and delete SQL commands, whereas having clause is mostly used with the group by clause and the aggregate function. Now what we do is we form some groups. On that particular groups we perform some aggregate functions, and this aggregate functions returns us a single value, and on that particular value we perform any condition using the having clause. So having clause is mostly used with the group by clause along with aggregate functions. Now the query for the where clause is select, and then we provide star, which basically means all, and then we provide from, and then we provide the table name from which we are making the query, and then we provide this where followed by the condition. In having we mostly give select, and then we provide the columns on which we are grouping the data, then we provide the aggregate function, and then the column on which we are performing the aggregate function, then we give from, and then we provide the table name on which we are performing the having clause, and then we provide the group by, and then the columns on which we are grouping the data, that is column 1 and column 2, and then we provide this having, and then we provide the condition. So having clause mostly works with the group by clause and the aggregate functions, whereas where clause mostly works with the select, update, delete commands. Where clause is oftenly used whenever we want to filter out some data based on some condition before the aggregation happens, whereas having clause is mostly used to filter out data based on some given condition after the aggregation happens. So this was the basic differences between where and having clause. So the very first practice question is write a query to find the total number of employees in each city. So what we have to do is we have to find the total number of employees which are present in each city. So let's just break the question and then we will see how the query works. So first we have to find the total number of employees. So to find the total number of employees, here we can use the aggregate function. So in the aggregate function, we can use the count function, which basically counts the number of employees or counts the number of rows which are present. So this will help me to find the total number of employees. Now the second sub part is in each city. So what I have to do is I have to find the total number of employee in each city. So there could be multiple cities like Mumbai, Bangalore, Hyderabad and much more. Now I have to find the total number of employees who are present in each city. So there could be a possibility there are 2 or 3 employees who are living in the same city. So what we will do is we will here use the group by clause. So basically this clause will help me to group all the data which is present in Mumbai, which is present in Bangalore, which is present in Hyderabad. And then in these group of employees, we will count all the employees which are present in this particular cities. So what we will do is we will give this select, and then we will provide the column on basis of which we want to group the data, that is city, because here it is given in each city. So we will give city, and then we will provide the aggregate function count, and then we have to provide the column name on which we want to count. So we can either count on the basis of name, ID, salary and much more things. So for now we will use the name, and then there is as, and then there is a temporary column name or an alias name for this particular column. So what it will do is this count name will provide me a result or a value, and that particular value would be shown in this number of employees. So it is kind of acting as an alias for a particular column name. Now then we will provide from, and then we will provide the table name from which we want the specific results, and then we will provide the group by clause, and then we will provide the column name on basis of which we want to group the data. So this will help me to find the count of employees, and this will help me to group all the employees on a particular city. So these both together will help me to find the count of employees who are in each city. Now let's see from the MySQL workbench that how this query is working. So to understand all those queries, I have already created a company database. Inside that company database, I have already created an employee table, and in this particular employee table, we would be performing all the queries. So let's just see what are all the details which are present in this employee table. So we'll just execute this query, and here you can see that I've feeded the data of almost 5 employees with their name, age, department, city and salary. Now the very first practice question is we want to find the total number of employees in each city. So for that we will give the query as select, and then we'll provide the column name on basis of which we want to group the data, that is city, and then I'll provide the column name on which I want to perform the aggregate function, basically count the total number of employees. So I'll give name, and then I'll provide an alias for this particular column name as number of employees, and then I'll provide group by, and then I'll provide the table name, so from employee, and then I'll provide the group by clause which will help me to group the cities into some subgroups. So I'll give group by city. So let's just execute this query. So here you can see that we have got the city and we have got the number of employees who are there in each city. So for Mumbai there are 2, for Pune 1, for Surat 1 and for Indore 1. So this particular query will help me to find the total number of employees who are present in each city. Now let's see the next practice question. Write a query to find the maximum salary of employees in each city in descending order. So we have to find the maximum salary of employees in each city and then we have to order it in descending order. So let's just break this particular question into some sub questions and then we will write the query. So first what we have to do is we have to find the maximum salary of employee. So to find the maximum salary of employee, we can use the aggregate function max. And here we can provide the column on basis of which we want to aggregate the data, that is salary. Now the next set says that in each city we have to find the maximum salary of employee in each city. So to get the group of cities we can use the group by clause. So here we'll use the group by clause on city, which will help me to get all the subgroups of city or all the cities into some similar subgroups. So let's see the query. So here in the query we have provided select and then we have provided the column on basis of which we want to group the data, that is city, and then we have provided an aggregate function max on the column on which we want to get the aggregated data, that is salary, and then we have provided an alias for this column name as max salary. Then we provide the from and then we provide the table name from which we want this particular data, and then we provide this group by clause and then we provide the column name on which we are grouping the data, that is city, and then we provide the order by clause followed by the column name on which we want to order the data. So I've missed it here. So the column name would be max salary, because I have already created a max salary column name which is having all the maximum salary from the particular group. So we'll provide the column name as max salary and then we will provide the manner in which we want our data, that is descending. So let's see from the MySQL workbench. So here we want to find the maximum salary of employees in each city in descending order. So what we will do is we'll give the query as select and then we'll provide the column name on basis of which we are grouping the data, that is city, and then I'll provide the aggregate function and then I'll provide the column on which we are aggregating the data, that is salary, and then I can provide an alias for this, that is as, let's give it as max salary, and then I'll provide the table name, that is from employee, and then I'll provide the group by clause, so group by, and then I'll provide the column on which we are grouping the data, that is city, and now we want to see all our result in descending order. So we will be using this order by clause, so we will use order by, and then we can use this particular column name because it has all the aggregated set of data for each city. So we would be using max salary, and then we'll provide the manner in which I want to see my results. So select, then the column name on basis of which we are grouping the data, then the aggregate function on the column name on which we want the aggregated data such as maximum salary, and then we can provide an alias for that particular column, then we'll provide the table name, then we'll provide the group by clause followed by the column name on basis of which we are grouping the data, then we can use this order by clause to get our particular result in descending order. So here you can see that we are getting an error. That the reason behind getting this error is in the earlier query we haven't ended the query, so here we'll provide a semicolon and you can see the error is gone now. Now let's just execute this query. So here you can see we are getting all the groups of city and here we are getting the maximum salary in all the groups and the maximum salary is sorted in descending orders. So this is how we can group the data and get the result in some specific order. So let's see the next query. So the next query is write a query to display the department names alongside the total count of employees in each department, sorting the results by the total number of employees in descending order. So what we have to do is we have to display the department names. So we have to display the department names which are present in our employee table. So we'll use the group by clause. Now alongside that we have to display the total number of employees in each department. So we have to tell that if there are 3 departments, IT, HR and marketing, now in this particular department how many employees are there. So for that we can use the count aggregate function to get the count of all the employees who are present in each department, and then we have to sort the result of total number of employees in descending order. So we have to sort the result of this total number of employees in descending order. So we can use the order by clause. So whatever result we get from this count aggregate function on some specific group of departments, we have to order the result on basis of that. So whatever is the result from this count, we have to order our results on basis of that. So we have to use the group by clause for the department name, then we have to use this count aggregate function to find the total number of employees, and then we have to order our results based on the result we get from count for each particular department. So very first we will provide the select command to make some query, and then we will provide the column name on basis of which we want to group our data. So basically it's department names, and then we'll provide the aggregate function, and then we'll provide the column on basis of which we want to perform this aggregate function. So here we want to find the total number of employees or total count of employees. So we'll use the count aggregate function, and then we'll provide a column name on which it will count all the total number of employees in each department, and then we'll give an alias for this as total employees. Then we'll provide the table name, that is employee, and then we'll provide the group by clause followed by the column name on basis of which we are grouping the data, that is department, and then we'll provide the order by clause, and then we'll provide the particular column on which we want to order our data, that is total number of employees, and then we'll provide the manner in which we want to order our data, that is descending order. So let's see from the MySQL workbench. We'll give the command as select, and then we want to group department into subgroups, and then we will provide the aggregate function, that is we want to count the total number of employees, and then we'll provide the column name on basis of which we want to perform our aggregated function, and then we'll provide an alias for this, that is total employees, and then we'll provide the table name on which we want to perform these operation, that is employee, and then we will provide the group by clause followed by the column name on which we are grouping the data, that is department, and then we will provide the order by clause followed by the column name on which we are ordering the data, that is total number of employees, so that is total EMP, and then we will provide the manner in which we want our data, that is descending. So let's just execute this query. So here you can see that we are getting all the department, that is IT, HR, marketing and finance, and here we are getting the total employees in each department. Now here you can see that all the result has been sorted in descending order, like IT is having 2 employees, so it is at the very first, and then all other departments are having 1 employee, so they are sorted on basis of that. Let's see the next practice question. Write a query to list the departments where average salary is greater than 1200. Also display the department name and the average salary. So we have to write a query to list all the departments where average salary is greater than 1200. So firstly we have to list all the departments, so we'll be using the group by clause for the same, and we'll be grouping the data on the basis of department. So we have grouped the data, we have listed all the departments, then we have to find the average salary greater than 1200. So then we have to find the average salary for all the departments, so we can use this AVJ function from the aggregate function, which will help me to find the average salary for each department. So it will give me the value of average salary for consider IT, HR, marketing department. Now there is a condition that we have to find the details of employees who are having average salary greater than 1200. So from here we'll be getting a result, and here we'll be using the having clause as we are providing a condition to filter our data. So we'll be using the having clause, and with the having clause we'll provide the average salary greater than 1200. That is result of average salary for each particular department should be greater than 1500. So we have to display the department name as well as average salary. So let's see the query. So first we'll give the select command to make a query, and then we'll provide the column on which we are grouping the data, that is department, and then we'll provide the aggregate function, and then we'll provide the column on which we want to aggregate our data, that is salary. So here you can see that we are doing some condition or performing some condition on the average salary. So we have to find the average salary first, and then we'll provide an alias followed by the column name for which we are providing an alias, and then we'll provide from and then the table name, and then we'll provide the group by clause followed by the column name on which we are grouping the data, and then here we'll be using having clause because having clause is mostly used with the aggregated set of data. So here we have already aggregated some set of data, and here we want a condition that is average salary is greater than 1200. So we'll provide the having clause, and then here we'll provide the average salary, and here sorry, it's by mistake written as 5000, so the average salary should be greater than 1200. Either here we can provide this AVJ salary, or we can use the alias name, that is average salary as well. So in this way what it will do is it will group the department into some sub-departments or subgroups, that is IT, HR and marketing. Then it will find the average salary of all the employees which are present in IT, average salary, and for HR and for marketing. And when we have got the average salary for all the groups, then we will perform the having clause, that is having, and then we'll provide the condition that is average salary should be greater than 1200. Sorry, here also I have by mistakenly told that average salary should be greater than 1500, so it would be 1200. So we have to find the list of departments where average salary is greater than 1200. So let's see from the MySQL workbench. So we'll just write a query. So we'll give select, and then we will give the column name on basis of which we want to group the data, that is department, and then we'll provide the aggregate function. So basically we want the average salary, so we'll use average, and then we'll provide salary, and then we'll give an alias, that is average salary, and then we will provide the table name, so from employee, and then we'll provide the group by clause to group our departments. So we'll provide group by and then department. So our department have been grouped. Now we want to provide some condition to the group data, so we'll provide having, and then we'll provide the column, that is average salary, and then we'll provide the condition that is greater than 1200. So show me the department of all the employees who are having average salary as greater than 1200. So let's just execute this query. So here you can see that you can see 4 departments, IT, HR, marketing and finance, and here you can see the average salary that is greater than 1200, greater than 1200, greater than 1200 and greater than 1200. So this was all about the practice question in this particular video. These practice questions are very important, so try to practice this, try to break the questions into sub question and try to make query from the sub question. So here you can see that I have provided a table in which I have provided the rank in which we should be using all the particular commands, and then we have provided the commands, and then we have provided the use case for that particular command. So it's not possible that you are providing a condition to any of the column or any of the set of rows before even telling the MySQL server that these are the columns on which I want to provide the condition. So where can never happen before the select command. So first command is the select command. So select command is basically used to retrieve data from the database. So the very first thing what we do is we first retrieve the data from the database. Then now the next is from command, which help us to identify the table. Now in a particular database there could be multiple tables, so I need to tell my database that from this particular database I want this particular table. The third one is where clause, which help us to provide any condition or filter the rows based on some specific condition. So we have retrieved the data from the database, we have provided the table from which we are retrieving the data, then we can provide the conditions on that particular data which we are retrieving. Then the fourth one is group by clause, which basically works on the aggregate function. So if we want to perform any aggregate function, we can use this group by clause after where. Why we are using this group by clause after where? Because where is mostly used before the aggregated function and having is mostly used after the aggregated function. So using the group by clause, we can group the rows that have the same values based on some aggregate function, and then we can use this having clause, which help us to filter groups based on some condition. So where clause help us to filter rows based on some condition, whereas having clause help us to filter groups based on some condition. And then at the sixth number we have the order by clause. So we have retrieved the data, we have identified the table, we have filtered some rows on the table, we have grouped the rows, we have filtered some group on some basic condition, and then we want to sort the result either in ascending or descending order. So we can use the order by clause. And at the very last is the limit. We have retrieved the data, we have filtered the rows, then we have grouped the data, then we have filtered the groups, then we have sorted the result. Now I want to limit the number of rows which are result in our final result. So this is the general order of SQL commands which we follow while making any of the queries in SQL. So what is joins in SQL? As the name suggests, join. So basically we are joining something to get a desired result. So joins are used to combine rows from two or more tables based on a related or shared or common column between them. So whenever we have two or three tables who have a related or a common column between them, like consider an example of ID. So the ID column is present in the student table, the course table, and the course details table as well. So that particular ID column is a shared or a common column between all those three tables. So we can just join them and get all the related details we want from all these three tables. There are commonly four types of joins. So the very first one is inner join. Then there is an outer join, which consists of left join, right join, and full join. And then there is a self join, and then there is a cross join. Now in these particular tables you can see there is a student table and then there is a course table. In the student table also we have an ID column. In the course table also we have an ID column. So since they both have a common or a shared or a related column, we can perform join operations on them to get the details of name, age, course ID, course name for a particular student. Now as I told that there is a shared or common column between these two tables. So there would be a doubt which would be coming to your mind is that whenever there is a common column between two tables, we establish a relationship using foreign keys. So is foreign key important for performing joins? So the answer is join can be performed based on any column that establishes a relationship between two tables, not just foreign key constraints. So it's not necessary. So it's not necessary to have foreign key present in one of the table. Even if there is no foreign key, but there is a column which is kind of present in another table as well, we can perform the join operation. So foreign key is not a must-have. If two tables are having a foreign key relationship, we can perform join on them. If there is no foreign key present in any of the table, still we can perform join operation on them because we only need a shared or a common column between two tables. Now let's see on the types of join. So the very first join is the inner join. Now as the name suggests, inner join. So basically we are trying to fetch all the inner details from two tables. So there is table 1 and table 2, that is A and B. Now in this particular table A, we are calling it as left table. The table B, we are calling it as right table. So whenever we perform inner join among any two tables A or B, we get the common values between them in the inner join. So basically the values which are present in left table as well as the values which is present in right table, we get the value as result whenever we perform the inner join. So here you can see that there are two tables, student and course. So if we want to perform any inner join among them, what it will do is it will search for the common column. So the common column is roll number. Now in that particular common column, it will find the values which is common among both of the tables. So 1, is there any value of 1 here? So it would be discarded. Then 2, is there any value of 2 here? Yes, so we will be printing 2 Hindi along with 2 Rahul whenever we perform an inner join. And then 3, there is a row with the value as 3, so we will be printing 3 Riti along with the subject as English. So in this way we get the common values which is present between left table as well as the right table. Now the second join is the left join, or we can also call it as left outer join. Now in the left outer join, what happens is we get all the values which is present in left table along with the values which is present in left and right both of the table. So basically we get all the values which is present in left table. So consider for now student is the left table and course is the right table. So we will be getting all the values which is present in left table, that is 1, 2 and 3, and we will print the name for all the 3, and And then we will come to this particular table. So here we can't find the roll number 1. So for now, null would be assigned to that particular person, Ram. And then for 2 we can get Hindi, and then for 3 we can get English. So mostly we will be first taking all the values of the left table, and then we will be seeing that in this particular left table, what are the values which are common in the right table, and we will be taking that. Now the third one is right join or right outer join. So it is kind of similar with the left outer join. There is just one difference, that in this particular join we take all the values from the right table along with the common values between the left and the right table. So if this is the left table and this is the right table, we will be taking all the values which is present in that right table, and then we will find the common values which is present in the left table, and then we will display all the particular details. But in the right table you can see a roll number 4 who has opted maths, but here you can't find the roll number 4. So for that particular column we will fill null in the name. So mostly in the left and right outer join, whenever it doesn't find any values in the next column, it just fill the null value. Now the fourth join is the full join or full outer join. In this particular join, we take all the values of left table, right table along with the common values between them. So all the values which is present in left table would be taken, all the values which is present in right table would be taken, and all the values which is common between them would be taken. So if there is two tables left and right, so we will take all the values which is present in student table. We will also take all the values which is present in course table. Now for the course table, the values which is not present in student table, we will fill as null. And for the student table, the values which is not present in the course table, we will fill as null. So here C name would be null for roll number 1, and here name would be null for roll number 4. Now the fifth join is the self join, or we can say that whenever we perform join on the same table, that is called a self join. So consider that there is a table student, and if we want to perform a join on the same student table, we can use the self join. For the self join, we would be learning more in the further videos. For now, you can understand that whenever we are performing any join operation on the same table, we use the self join. Now the sixth one is the cross join. So in the cross join, what happens is कि consider that there are two tables A and B. So what happens here is कि if there is any row in the A table, it will go ahead and do a Cartesian product with all the particular rows present in the B table. Then the second row of the A table would do the Cartesian product with all the rows which is present in the second table, and then the third row will go ahead and do the Cartesian product with all the rows which are present in table B. So what happens in cross join is now roll number 1 and Ram would form a pair with roll number 2 Hindi, then with roll number 3 English, and then with roll number 4 maths. Then roll number 2 will go ahead and form a pair with roll number 2 Hindi, roll number 3 English, and roll number 4 maths. In the same way, roll number 3 will go ahead and form the pair with roll number 2, roll number 3, and roll number 4. So there is a Cartesian product, or there is a cross join which is happening, that one particular element of a given table is going ahead and doing a cross product with all the elements or all the rows which is present in table B. So that is why it is called as a cross join. And in the cross join, the number of rows in the final table is m into n. So consider that in the student table there are m rows, and in the course table there are n rows. So the final table would be having m into n, that is 3 into 3, 9 rows. So what is inner join? Inner join help us in getting the rows that have matching values in both the tables according to the given join condition. So whenever we want the values which is matching on both the tables, we use the inner join. So consider that there are two tables A and B. Whenever we want the values which is present between both the tables, that is this particular value, we use the inner join. Now here you can see that there are two tables, customer and order. And here there is one column which is common between both the tables, that is ID. So what we need to find is कि in both of these tables, customer and order, give me the values which is present in customer as well as order table. So let's see, is 101 present in the order table? No. So for now this is discarded. Then 102, is 102 present in the order table? Yes. So this is the value which would be returned in our final result. Then it will check for 103. Is there any value with the 103 existing in the order table? Yes. So we will be returning 103 as well. So it will give me all the values which is matching between both of these tables. So the query for the same is we give select, and then we provide all the columns which we want to see the data among both the tables. Then we provide this from, and then here we provide the table 1, that is this particular table, customer table, and then we perform this inner join, and then we provide the table 2 name, that is order, and then we provide on, and then we provide the condition on basis of which we are performing the join. So the condition is table 1 dot column name. So this dot column name basically refers to a column which is present in table 1. So table 1 dot column name should be equal to table 2 dot column name. So basically the column which is similar between both the tables perform the inner join on that particular table. Now here you can see that at the first I have given the table 1, and in the second I have given the table 2. So can we reverse this order? So for inner join we can reverse the order because ultimately we are focusing more on getting the values which is common between both the tables. So even if table 2 is on the upper side and table 1 is on the lower side, it doesn't affect our result. But when we go to other type of joins, we have to maintain the order in which we want to fetch the data. So let's see from an example. So this is the query which returns the rows where there is a matching ID in both the tables. So what it will do, it will give select, and then it will provide star. So it will get all the columns which is present in both of these tables, and then we will provide from, and then we will provide the table 1 name, that is customer, and then we will perform this inner join, and then we'll provide the table 2 name, that is order, and then we'll provide on which particular columns these values needs to be inner joined. So for customer we are using the column as ID, and for order we are using the column as ID. So in both of these tables, ID is the similar or a common or a shared column. So on ID we are performing the inner join, and we want to see all the details of a particular customer as well as their orders. So whenever we perform this particular query, we will get the result as this. So here you can see that among all the IDs which is present in customer and order table, the ID 102 and 103 are common among both the tables. So we'll get the details for 102 and 103. Then we'll get the name which is present in table 1, and then we'll get the ID which is again present in table 2, and then we'll get the order name, that is fruit. In the similar way we will get for 103 Riti. 103 is the ID which is for the second table, and then the order name as ball. So if we want to eliminate this ID which is being repeated twice, we can provide the column name specifically from which we want to fetch the data. So here we can provide ID name and order name, but if we provide star, it will fetch all the columns which is present in table 1 as well as table 2. So let's see from the MySQL workbench. So here to perform the queries, let's just create an e-commerce database. In that particular database, we would be creating two tables. One is the customer table and the second one is the order table. So I've already written all the queries just to save time. But I'll be executing all the queries just now. So here you can see we are executing this create database e-commerce. So we'll just execute this query. We have got a success. Here if we do a refresh all, we can see a database with the name e-commerce is created, which is right now having no tables. So we'll then tell the MySQL server that we want to create all the tables inside this particular database. So we'll just execute this query, use ecom, and then we will create a table with the name customer, which is having attributes such as ID and name. Then we will fill some data into this particular customer table. So let's just fill the data, and then we will see that if all the data are filled or not. So let's see. So we have provided the details of 5 employees. We have provided their name as well. Now let's create a order. For that, again we will tell the MySQL server that in this particular database we want to create the table. So we will execute this use followed by the database name. Then we will create the table for the orders. So here we have got a success. Here if I do a refresh all, so in the tables you can see that we have created two tables. First is the customer and second one is the order. So let's just fill some details in the order table as well. So we'll just execute this query. So this is a success, and then we will check that if all the details are filled in our order table or not. So we'll just execute this query. So here you can see that we have filled the details for 3 of the orders along with their ID. Now we want to perform an inner join on both of the tables. Now both of the tables have a common column between them, that is ID, which is present in the customer table as well as the order table. So let's perform the inner join basis on ID, and then we will try to fetch all the particular details which are there in customer like ID name, and then in order like ID order name, for all the values which are common between both of the tables. So let's just write the query select, and then we will give star, and then we will give from, and then we'll give the table 1 name. For now we can give any of the table, but let's just take the customer table as table 1. And then we will give the inner join, and then we will give the table name on which we want to perform the inner join, that is order, and then we will provide the condition on which we are joining, that is on customer dot ID, which basically tells that in this particular customer table we are fetching the ID column is equal to orders dot ID, because this is the shared column between customers as well as order. So let's just execute this query. So on executing, you can see that we are getting the details of only 3 of the IDs, that is 2, 3 and 4, which was common among both orders as well as customer. Now we are getting the name, then again we are getting the ID from table 2, and then we are getting the order name. If it doesn't want to see this replicated column, so let's just give the query here as customer dot ID. So this will give me the customer ID. This particular dot is basically used to refer to a column which is present in this particular table. Then we will give orders dot order name, and then we will give this customer dot name. So what this will do is this will give me the ID from customer table, name from customer table, and order name from the orders table. So let's just execute this query. So here you can see that we have removed that replicated column that was ID. So here you can see that you are getting the ID, you are getting the order name, and you are getting the name. So in this way we perform the join. We basically get all the details from both the tables using the common or the shared column between those tables. In inner join we basically focus more on the common values which is present in both of the tables. So left outer join is a part of outer join. Now it is used to fetch all the records from the left table along with the matched records from the right table. So consider that we are having two tables, A and B, and A is the left table and B is the right table. So in the left outer join we get all the details of the left table along with the values which is common between A and B table. So we get all the records from the left table along with the matched records from the right table. So we get this entire detail using the left outer join. Now if there are no matching records in the right table, null values are returned for the columns of of the right table. So if there is no matching record which is found in the right table, consider that in the left table there are records as 1, 2 and 3, and in the right table there is only 2 and 3. So for the left table it will take all the records 1, 2 and 3, but there is no one which is present in the right table. So for that, the values for the right table will be filled as null, or the columns which is present in the right table will be filled as null. So here you can see the query. So we basically give select, and then we provide all the columns which we want to show in the final result, and then we provide from, and then we provide table 1. So here table 1 is the left table. We need to maintain this order because eventually we want all the details of the left table. If we reverse the order, we will get all the details of the right table. So we need to maintain this order. So we'll give from, and then we will give the table 1, and then we will give the left join, and then we will give the table 2. So basically we are performing a left join on table 1, which is taking all the details of table 1, and then the matched details between table 1 and table 2. And then we will provide the condition on which table 1 dot column name is equal to table 2 dot column name. So perform the left outer join on table 1 and table 2 on the basis of the common column which is present between table 1 as well as table 2. So what is the left table? The table specified before the left join keyword is called as the left table, that is table 1, and the table which is specified after the left join keyword, this is the right table. So table 1 is the left table and table 2 is the right table. Now let's see how it is happening. So there are two tables, customer and order. So here customer is the left table and order is the right table. Now in the left outer join, what will happen? It will take all the values of the left table and then the common values between the left as well as right table. So firstly it will take all the values of the left table, that is 101, 102 and 103. So it will take 101, 102 and 103. Then it will find the common values between these two tables. So here is ID 101 present here? No, ID 101 is not present here. So for now, for order table, we will fill the null values for ID 101. Now, is ID 102 present here? So yes, the ID 102 is present here. So we will take the value as 102 and fruit. So we'll take the value as 102 and fruit. Now, is the ID 103 present here? So yes, the ID 103 is present here. So it will take the ID as 103 and the order name as ball. So it will take ID 103 and order name as ball. So for the ID 101, it didn't had any of the entry in the table 2. So it filled null value for all the columns of the table 2. So let's see from the MySQL workbench that how it is happening. So here we performed the inner join. Now let's perform the left outer join. So we will just give select. We'll use the same tables, customer and the order table. So we'll provide select, and then for now let's see all the details. So we will provide star, and then we will provide the table name from customer, and then we will provide the join, like type of join. So we'll give left join, and then we'll provide the right table name. So the right table name here is orders, and then we will provide the condition. So we'll give on customer dot id is equal to orders dot id. So this is the condition on basis of which we are performing the left join. Basically this particular column and this particular column is a shared column and they have the equal values. So let's just execute this query. So here you can see that we are getting the ID as 1, name as Rahul, and here in the ID section for the right column we are getting null and null. So basically the values which were not present in the right column we are getting as null and null. Then for the ID 2 there is a value which is present in right table, so we are getting all the values. For ID 3 there was a value, for ID 4 there was also a value, for ID 5 there was value only in the left table but there was no value in the right table, so it is null and null. In this way left outer join performs. So the right join or right outer join is basically used to fetch all the records from the right table along with the matched records or the common records which is present between the left and the right table. So consider that there are two tables A and B. A is the left table and B is the right table. So in the right outer join we get all the details which is present in the right table along with all the common values or common records which is present between both the tables. So we get all the details of the right table along with the common values which is present between the left as well as the right table. Now if there are no matching records in the left table, null values would be returned for the columns of the left table. So consider in the right table we have IDs as 1, 2 and 3. In the left table we have IDs as 2 and 3. So for the right outer join it will take all the details of the right table, but here you can see that 1 is not present in the left table. So for the left table columns it will fill null values. Now let's see the query. So the query is select, and then we provide the columns which we want to see in our result, and then we provide from, and then we provide the table 1, and then we provide which type of join we are performing, that is right join, and then we give the table 2 name, and then we provide the condition on basis of which we are doing the join, that is table 1 column name should be equal to table 2 column name. So left table is the table which is given before the right join, and the right table is the table which is given after the right join. So table 2 is the right table and table 1 is the left table. So let's understand that how this particular right join is working. So consider that there are two tables, customer and the order table. Order is the right table and customer is the left table. Now in the right outer join we get all the details of the right table along with the matched values between left and right table. So it will take all the values of the right table, that is 102, 103 and 104. So it will take 102, 103 and 104 along with all the values such as fruit, ball and utensils. So here you can see fruit, ball and utensils. Now it will find the common values between these two tables. So is 102 present here? Yes, it's present, 102 and Rahul. So it will go ahead and fill the details of 102 and Rahul. Is 103 present here? Yes, it's present, so we'll fill the details of 103 and Riti. Is 104 present here? So 104 is not present here, so we'll fill the values as null and null. Now let's see from the MySQL workbench that how it is working. So it works in a similar fashion of left outer join. It's just that we get the details of right table rather than the left table. So I'll give select and then we will provide star and then we will provide the first table name, that is the left table name, that is customer, and then we will give the join type, that is right join, and then we will provide the right table name, that is orders, and then we will provide the condition on which we are performing the join. So that is customer dot id is equal to orders dot id. So let's just execute this query. So here you can see that we are getting the ID 234, we are getting the name Afsara, Abhimanyu, Aditya. Now for the left table we are getting the ID as 234 and we are getting the order name as fruit, ball and utensils. So all the details which were present in the right table were there in the left table. So we are not seeing any of the null values. So it is kind of giving me the common as well as all the values which are present in the right table. So in the earlier videos we learnt about left join as well as right join. Now what happens in left and right join? So consider that there are two tables. So this is basically a Venn diagram. So there are two tables A and B. A is called as a left table, B is called as a right table. In the right join also, let me just draw a Venn diagram, A and B. A is the left table and B is the right table. Now in the left join, we usually get all the details which is present in the left table as well as the common details which is present between the left as well as the right table. So if I want the details of the left table as well as the common details between left and right table, we use the left join. Now in the right join, basically as the name suggests right, so we get all the details of the right table along with the common details of the left and the right table. So basically when I want the details of the left table along with the common details between left and right table, I use the right join, and when I want the details of the left table along with the common details between left and right table, I use the left join. Now what is full join? So full join basically returns the matching rows of both left as well as the right table and also include all the rows from both the tables even if they don't have a matching rows. So full join basically is a combination of the left join as well as the right join. So in the left join we get this particular area, in the right join we get this particular area. So let's name the area as C. So in the left join we get A plus C and in the right join we get B plus C. So basically in the full join it is a combination of left join as well as right join. So we will get A plus C plus B plus C. Now here I'll get all the details of A, I'll get all the details of B and the common area between them, that is C. But here you can see that C is repeated twice. So C is also occurring in the left join, C is also occurring in the right join. So is it like we will see the details of C twice? So basically that doesn't happen. I'll tell you the reason in couple of minutes, but we usually get the details of A as well as B as well as C in the full outer join. Now, if there is no match, null values are returned for the column of missing table. So consider in the left table we have a column called as ID. Now in this ID we have 1 and 2. In the right table also we have a column ID, but in this column we have only 2 and 3. So here you can see that for 1 there is no entry in the right table. So if there is no match which is found, we usually fill the null value. Now how we would achieve the full join in SQL? So basically in the right join we were using the right join keyword. In left join we were using the left join keyword. So is it like in the full join we would be using the full join keyword? Let's understand. So in MySQL the syntax for a full join is different compared to other SQL databases like PostgreSQL or SQL Server. So in MySQL to make a full join, the query is slightly different from other SQL databases. So what is the difference? MySQL basically doesn't support the full join keyword directly. So we use a combination of left join, right join and the union keyword to achieve the result. So basically in MySQL we can't use the full join keyword. So what we do, basically the full join is a combination of left join as well as right join. So we use the union keyword between them. Now the question which would be coming to your mind is, what is union and how it is helping us to achieve full outer join? So union is basically a concept which comes in math, wherein if there are two sets A and B, and whenever we do a union between A and B, it gives me all the values which is present in A along with all the values which is present in B, and then the values which is present in A as well as B without any duplicates. So it eliminates the duplicates. So this is the answer for the last thing, where we discussed that full join is basically a combination of left join as well as right join. In left join we had A plus C, in right join we had B plus C. So in the final result we were not getting C twice. So the reason behind not getting C or this particular area twice is because we are using union, and union basically give us all the details of A and B, eliminating the duplicates. The full join is basically a combination of left join as well as right join. Now here is the query for the same. So firstly we'll write the query for the left join, and then we'll write the query for the right join, followed by a union between them. That is this. So first we give select, and then we provide the columns which we want to see in the final result. Then we provide from, and then we provide the left table name, followed by this left join keyword, and then we provide the right table name, and then we provide a condition between which we are joining two tables. So table1.column name is equal to table2.column name, and then we provide this union keyword, and then we provide the right join, that is select, followed by the columns, then from, then the left table name, followed by right join, then the right table name, and then the condition on which we are performing the right join. So basically this is left join, union, right join, which will give me full join. So let's see from the MySQL workbench that how this query is working. So here we have created a database ecom. In that particular database we have two tables, customer and orders. So we will be seeing about the full join on these two tables only. So here we have written some query for the left join which we learnt in the last video, as well as the right join. Now for the full join we need to provide a union between the left join query and the right join query. So firstly let's see what all details are present in both the tables. So first, to see the customer table, I'll be running this query select star from customer, which will give me all the details, all the columns which is present in the customer table. So that is ID and name. Now let's see for the orders table. So we'll run the query select star from orders. So here we can see that we have ID and order name. So in the full outer join, what will happen is first there will be a left join between the customers and the orders table. Then there would be a right join between the customers and the orders table. And then we'll provide a union in between them to perform the full outer join. So let's write the query. So firstly, we will write the query for the left join, that is select, and then the columns. So right now we'll see all the columns. And then we will provide from, and then we'll provide the table name, that is the left table name, and then we'll provide the left join, followed by the right table name, that is orders, and then we will provide the join condition. So on customer dot id is equal to orders dot id. Now we will provide the union symbol. So here we'll provide the union, and then we will write the query for the right join. So we'll give select, and then here we'll provide star to see all the columns which is present in the right table. Then we will provide from, and then the left table name, that is customer, followed by the right join, and then the right table name, that is orders, and then we'll provide the join condition. So we will give on customer dot id is equal to orders dot id. So this should be orders. So this is the final query which we have made. First we have provided the left outer join query, then we have given this union keyword, and then we have provided the right outer join query. So let's just execute this query. So here you can see that we are seeing all the details of the left table as well as the right table and the common thing between them. So you can see that 2, 3 and 4, these were common between left as well as right table. So we are getting all the details, ID, name and order name. For the ones which were not common between the left and right table, that is 1 and 5, for them we are getting ID as null and null, order name as null and null, because they were not present in the orders table. So if there are no matching rows between two tables, it provides the value as null there. So this is the final result we get for the full outer join. Now as the name suggests, cross join. So what we do in join, we basically combine two tables. So we combine two tables. Now what we do in cross, so cross is basically something we can say as a cross product. So whenever we are performing any cross product between two tables, that gives me a cross join, or that is the result of the cross join. Now let's understand what is cross join. So basically in cross join, it combines each row of the first table with the every row of the second table. So consider that the customer table is the first table, the order table is the second table. Now according to definition, each row of the first table is combined with each row of the second table. So firstly we will get the result as 101 ram with 1 fruit and 2 ball. And then for the second row again it will combine with each row of the second table. So it will be 102 Rahul with 1 fruit and 102 Rahul with 2 ball. So basically there is a cross product which happens between these two tables, and what we get in the cross join is we get the result of the cross product. So consider that in the customer table, if there are m rows, consider it is 1 and 2, and here also the number of rows are 1 and 2. So for now we are considering variable. So consider that there are m rows in the customer table and n rows in the order table. So the product or the result of the cross join is m cross n. That is, for this particular table it will be 2 cross 2, that is 4. So let's verify. So firstly, first row of the customer table would be cross joined with the first and second row of the order table. So first result would be 101 Ram with 1 fruit, and again 101 Ram with 2 ball. Then for the second row it would be 102 Rahul with the first row of this table, that is 1 fruit, and then again 102 Rahul with the second row of this particular table, that is 2 ball. So this would be the final result of the cross join. Now here you can see that we are getting 1, 2, 3, 4. So here we are getting 4 rows, and if we do m cross n, then m is the number of rows for the first table and n is the number of rows for the second table. So here 2 cross 2 gives us 4. So basically it results in a new table where the number of rows is equal to the product of number of rows in each table, that is m cross n. Now let's see the query for the same. So here you can see the query. So first what we give is select statement, and then we provide the columns which we want to see in the final result. So here we have provided star, which basically means all. So we want to see all the columns which is present in the first table as well as the second table, because join happens between two tables only. Now then we will give from, and then we will provide the table 1 name, and then we will give this cross join, and then we'll provide the table 2 name. So it will give me a product which would be the cross join between two tables, table 1 and table 2, which would be having number of rows as table 1 rows into table 2 rows, that is m into n. So 2 into 2, that is 4. So this would be the final result of the cross join. Let's see from the MySQL workbench that how cross join happens and if we are able to get this result or not. So let's see how cross join happens in the customer as well as the order table. So firstly, let's see what all details are there in the customer table. So we'll just hit select star from customer, which will give me all the details in the customer table. So there are 5 IDs with the name. So it is having 5 rows. And then let's just execute the order table as well. So here there are 3 IDs. So basically there are 3 rows. So we will get 5 into 3, that is 15 number of rows in the final result. So let's just do a cross join. So for the cross join, let's just use the existing tables which are present here, the customer and the orders table, and then we will see that how the cross join is even happening. So firstly, we'll see all the details of the customer table. So we'll hit the select star from customer, which will basically give me all the details of the customer. So here you can see that there are almost 5 IDs and there are name of that particular IDs. And here you can see that there are 5 rows. So the first table is having 5 rows. Now coming to the second table, that is the orders table, we'll run the query. So here we can see that there are 3 IDs present. So there are 3 rows. So 5 into 3 is 15. That means the final product or the final result we get after the join would be having 15 rows. So let's do the join. So first we will give select, and then we'll provide the columns which we want to show in our final result. So for now we want to see all the columns so that we understand that how the join operation is even happening. And then we will provide from, and then we'll provide the table 1 name, that is customer. And then we will provide this cross join keyword, and then we'll provide the table 2 name, that is orders. So select star, which will give me all the columns. Then I'm providing the table 1 name, that is customer, and then I'm providing cross join, and then I'm providing the table 2 name. So mostly it will have m cross n, that is 5 into 3, 15 number of rows. So let's see from the final result if we are getting 15 rows or not. So I'll just execute this query. So here you can see that we have got a cross join of both of the tables, and let's see that how many rows are there. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the final result is having 15 rows, and here you can see that ID 111 is repeated, 222 is repeated, because it is going and cross joining from the each and every row of the second table. So basically whenever each row of the first table is cross joined with each row of the second table, we get the result. So that is m cross n number of rows, that is 5 into 3, 15. So as the name suggests, join. What is join? Basically whenever we want to join two tables, we use join. Now what does this self join means? So whenever we are performing join operation on itself, it is called a self join. Now that may sound confusing, but let's understand that how self join works. So a self join in SQL is a type of join where a table is joined with itself. It is a type of inner join. Now whenever a table, consider that there is a table A which is having some data, and the column is ID, name, age. So whenever this particular table A is joined with itself, so again there is a table that is the same table A only with the same columns and same values. So whenever we are joining the first table with itself, it is called as self join. So in this particular join, what will happen? Table A will join with table A only. So there is a self join which will happen. Now the very next question which would come to your mind is why do we even need to join a table from itself only? Why do we even need that? Like join is mostly performed on two tables. So why do we even need to join one table from itself only? So let's see this example. This will make a bit clarity and this will give you the reason why we are joining one table with itself. So here you can see that this is a student table which is having details of the student ID, the name, and this one is the mentor ID. So basically there is a group of students. Now in that particular group of students, there is a mentor for each particular student, and that particular mentor is also a student. So that is also provided the student ID. So here you can see that for the very first row, we have given the student ID as 1 for Ram, and Ram is having no mentor. Now for the second row, the student ID is 2 for Rahul, and Rahul is having a mentor who is having student ID as 1. So where the student ID is 1, it is for Ram. So for Rahul, Ram is the mentor. Now again coming to this third row, here the student ID is 3, the name is Riti, and she is also having a mentor as 1. 1 is Ram. So Ram is the mentor for Riti. Now coming to ID 4, that is Riya, and Riya is having the one who is having student ID as 3 as mentor. So Riti is having student ID as 3, so Riti is the mentor for Riya. So in this cases, for now I have decoded it, but if the table is too large, if there is like very much of data or there is a huge data set, in that case we can't go ahead and decode from the table itself that who is the mentor for which particular student. So in that case, what we do is we self-join two tables, and from the first table we fetch the student name, and from the second table we can fetch the mentor name, and can do it vice versa also. So in this way we can know the student name as well as the mentor name who is assigned to the student, where the student ID is always equal to the mentor ID, because student ID is having all the details which mentor is having. So here you can see that I have drawn a hierarchy chart. So in the hierarchy chart, the very first student is Ram. Now Ram is the mentor for Rahul as well as Riti. So if you see here, Rahul is having Ram as mentor, Riti is also having Ram as mentor. And now for Riya, Riti is the mentor. So here you can see that there is a hierarchy which is formed between the mentors as well as the student. So here the self join plays a picture. Now if we go here, the query for the self join is we give select, and then we provide all the columns which we want to display in the final result. Then we provide from, and then we provide the table name, and then we provide an alias for the table name. So why do we even need to provide an alias? So join is basically performed on two tables. So if we give the same table name before or after join, it can result in error. Here you can see that I am joining A with A only. But if I provide an alternate name for both the table, it won't result in an error and it can give me the result. So that is why we provide an alias which provides an alternate name for the table. So this is an alternate name. It's not like it is creating a new table. It's just an alternate name for the table. So it will provide an alternate name as T1 for the first table, and then we will give join. So whenever we perform self join, it's not like we give a keyword as self join. We only provide the join keyword whenever we are doing the self join, and then we will again provide the table name, and then we will provide an alias for the table name, that is T2. So there will be T1 and T2, which is having almost the similar details only because it is the same table. It's just that we are joining it, so we are making two tables and we are joining the same table with itself only. Then we'll provide the condition. So we have provided the condition on T1.column name equal to T2.column name. So whenever you find T1.column name equal to T2.column name, do a self join. Now here T1 and T2 are aliases for the table used to distinguish between the order of the rows. So basically whenever we want to distinguish between two tables, between their rows or something, we can provide an alias. Now here you can see the query which I have written to find the mentor name as well as the student name. Now here we are providing select, and then here we are providing S1. So what is S1? So S1 is basically an alias which is provided for the student table only. So whenever we provide an alias for any of the table, we can use the columns or access the columns using the dot. So here we are accessing the column of S1, that is the student table only. So S1.name as mentor name. So we are providing an alias for this S1.name, that is the mentor name. So first table would be having the mentor name. And then we are providing S2.name as name. So S2 is again an alias which is provided for the second table. So for the second table, S2.name is referred as name. So we will get a final result where we will get the mentor name and the name. Then we will provide from, and then we will provide the table name, then we'll provide an alias, and then we'll provide an alternate name. And then we'll provide the join keyword for the self join, and then again we'll provide the table name on which we are joining, and then we'll provide an alternate name for the same table name. And then we'll provide the condition. So here the condition is where S1.SID, so basically this one. So whenever S1.SID is equal to S2.mentorID, so whenever S1.SID like 1 is equal to the mentor ID, give me all the rows. So what it will do is it will check if 1 is equal to this, no. If 1 is equal to this, yes, so give me Ram. If 1 is equal to this, yes, give me Ram. If 1 is equal to 3, no, don't give me Riti. So in the same way it will perform for 2, 3 and 4. Now let's see the final result. So here in the final result we get the mentor name as Ram for Riti. the mentor name as Ram for Rahul and the mentor name as Riti for Riya. Let's verify here. So for Riya, the mentor was Riti. For Riti, the mentor was Ram. For Rahul, the mentor was Ram. And for Ram, there is no mentor. So this is the final result which we get. Now, if you're still getting confusion that how this cell join is even happening, so let me just explain again. So what is join? Join basically combines two tables and gives us the details. Now, in the join, what happens is that there is a cross product, which always happens, and then we provide the condition on that cross product, which gives us the final result. So in join, what happens? We are combining two tables. So whenever we are combining two tables, there is a cross product which happens, and then it eliminates all the pairs based on some condition. So here we have a condition s1.sid is equal to s2.mentor id. So let me just refer it as mid. So let's draw the table which we have. So what we will do whenever we are performing cell join is, first we will find the cross product. So to find the cross product, we need to understand that what kind of join this is. So this is a cell join, so it will get joined with itself only. So there is one more table which is having exactly the same details as this table. So this is the mentor ID, and then they are having the same details: 3, 4, Ram, Rahul, Riti, Riya, and then it's null, 1, 1 and 3. So let's just perform the cross product. So in cross product, what happens is each row of the first table is cross joined or co-joined with each row of the second table. So basically there will be a pair which will be made, which will be having the first row of the S1 and all the rows of S2. So the very first set which we will get is 1 Ram null, which is joined with 1 Ram null, 2 Rahul 1, 3 Riti 1 and 4 Riya 3. Now again for the second row we will do the cross product, so it will get joined with 1, 2, 3 and 4. So the second row is 2 Rahul and 1, which will be joined with 1 Ram null, 2 Rahul 1, 3 Riti 1, 4 Riya 3. Now again for the third row, it will be 3 Riti 1, which will be again joined with 1 Ram null, 2 Rahul 1, 3 Riti 1, 4 Riya 3. Now the final one would be 4 Riya 3. So it will be 4 Riya 3 with 1 Ram null, 2 Rahul 1, 3 Riti 1 and 4 Riya 3. So these are the four sets which we have got: set A, set B, set C and set D. So here in the cross product we have got 4 sets, which is kind of each row of the first table is cross product with each row of the second table. Now cross product is done. Now we need to apply the condition. So here the condition is s1.sid is equal to s2.mid, that is mentor id. So s1.sid is this and s2.mid is this. So is 1 equal to null? No, rejected. Is 1 equal to 1? Yes. So this will appear in final result. So this will be the one which will appear in the final result. Now is 1 equal to 1? Yes. So this will also be appeared in the final result. So is 3 equal to 1? No. So we'll just discard this. So from here we have got 1 Ram null, 2 Rahul 1, 1 Ram null, 3 Riti 1. Now let's come to the second set. So this is the SID and this is the MID. So is 2 equal to null? No. Is 2 equal to 1? No. Is 2 equal to 1? No. Is 2 equal to 3? No. So from set B we have got none of the pair. Now let's go to the set C. So is 3 equal to null? No. Is 3 equal to 1? No. Is 3 equal to 1? No. Is 3 equal to 3? Yes. So basically here 3 is the student ID and here all these fields are the mentor ID. So it is basically the S1 details and it is basically the S2 details. So from here also we have got a set that is 3 Riti 1 along with 4 Riya 3. Now coming to the 4 set. So here is 4 equal to null? No. Is 4 equal to 1? No. Is 4 equal to 1? No. Is 4 equal to 3? No. So from here also we have got no sets. So here you can see that we have got 1, 2 and 3. So we have got 3 rows in the final result, and here also you can see that we have got the 3 rows in the final result. So in the final result we are showing s1.name as the mentor name and s2.name as the name or the student name. Now let's figure it out. So here s1.name is Ram. So the very first mentor name is Ram, who is the mentor of Rahul, and Ram is again the mentor of Riti. Now the third set is 3 Riti 1 with 4 Riya 3. So Riti is the mentor of Riya. So basically we are getting Ram, the mentor of Rahul, Ram, the mentor of Riti, and Riti, the mentor of Riya. Let's go to the final result. So Ram, the mentor of Riti, Ram, the mentor of Rahul, and Riti, the mentor of Riya. So in this way we get to the final result. I know the video is extending too long, but this is a very important concept, and if you understand this, you can solve any of the join problem. and you can understand that why this particular result is coming and how it is coming. So basically whenever you do a cross product with along any condition, you can get the result of the specific join. Now let's go to the MySQL workbench and see how the cell join is happening. So for the cell join, we will be making a school database. Inside that school database, we will be making a student table, and inside the student table, we will be filling all the details of the student ID, the mentor ID, and the name. So let's just create it. So just to save time, I have written all the commands. So firstly, we'll create the database. So we have created the database. Let's just do a refresh all. So here you can see a school database is created. Now I'll tell the SQL server that all the commands needs to be executed in the school database. So we'll use this use school command. So here it is a success. Now we'll create a table student. In the school database, we'll be having student ID, name, and mentor ID. So here it is a success. Let's just do a refresh all. So here you can see in the tables, we are getting the student, which is having columns such as student ID, name, and mentor ID. Now let's just insert the data into the student table. So this is success. Now let's just see that if all the data have been inserted correctly or not. So here we have got 1 Ram null, 2 Rahul 1, 3 Riti 1, and 4 Riya 3. Now let's just apply the join. First we will give the select command, and then we will give the column which we want to show. So for now we want to only show the name. So we will give it as name. Now we will give from, and then we'll provide the first table name, that is student. And since we can't perform join on the same table name, we will just use an alias for the first table name, that is S1. And then we will give this join keyword for self join, and then we'll provide the second table name, that is student, and then we will give as S2. And then we will provide the condition. So the condition is where S1 dot SID is equal to S2 dot mentor ID. So wherever you find the student ID is equal to the mentor ID, just do a self join so that we can get the details of the student as well as their mentor. So let's just run only these much query and see that what we are getting. So here you can see that we are getting an error. Why we are getting an error? So here, since we have provided an alternate name for the tables, so we can't just give it as name because it won't know that from which table you are using the name, because name is present in S1 as well as S2. So for now, let's just use S1.name and S2.name. Now let's just execute this query and see. So here we are getting name and name, which is having Ram, Riti, and Rahul, Riti, and Riya. So here we are getting all the mentors name, and here we are getting all the student name. So we just need to modify the query a bit, because here also we are getting the name and here also we are getting the name. So let's just provide an alias for this particular column and for this particular column so that we get the result in a desired format. So let's just name it as S mentor name, and let's just provide the alternate name for this as student name, or you can say name. So let's just execute this query. And now here you can see that we are getting mentor name and the student name. So the student name is Rahul and the mentor for Rahul is Ram. The student name is Riti, the mentor for Riti is Ram. The student name is Riya and the mentor for Riya is Riti. So in this way we can get the final result of the self join, where we can get the details of the mentor as well as the student. The most common example which is used for the self join is for the employee table, where we find that the employee ID remains the same for the manager as well as their employees. So in that case also we can use the self join. Now, as the word suggests, exclusive. So exclusive basically means whenever we are excluding something, and join basically means whenever we are combining two tables. So whenever we are combining two tables, if we are excluding something, that is used in exclusive joins. Now what are these exclusive joins? So exclusive joins are used whenever we want to retrieve data from two tables, excluding the matched rows between these two tables. Now let's go to the outer joins. So in the outer join, I explained about three types of join. First one was left join, second one was right join, and third one was full join. Now what happens in the left join? Consider that if there are two tables A and B, A is the left table, B is the right table. So in the left join, we used to get all the details which is present in A along with the common details which is present between A and B. Similarly with the right join, if there are two tables A and B, where A is the left table, B is the right table, we used to get all the details which is present in the right table along with the common rows which is present between right table and the left table. In the full join, we used to get all the details which is present in the left table along with all the details which is present in the right table and the common rows between them. But in the exclusive joins, we basically exclude this area. So we don't get this area, we only want this particular area which is having the details of A, or only this particular area which is having the details of B, or only this area which is having the details of A as well as the details of B. So here also you can see that there are three types of join. The very first one is the left exclusive join, the second is the right exclusive join, and the third is the full exclusive join. So here the left exclusive join is same as the left join. It's just that in the left join we used to get the common or the matched values between A and B, but here we are excluding these values. Again in the right exclusive join, it is same as the right join, but in the right join we used to get all the details which is present in the right table along with the common details which is present in right as well as left table. But in the right exclusive join we only get the details which is present in the right table. We exclude the ones which is the matched rows between A as well as B or left table as well as right table. Now in the full exclusive join, again it is similar with the full outer join, but in full outer join we used to get all the details of left table, all the details of right table along with the details which is matching between left table and right table, but here we are excluding this particular area. So now let's learn about each and every type of join and let's see the query which we are using for these exclusive joins. So the very first one is the left exclusive join. So whenever we retrieve records from the left table, excluding the ones matching in both left as well as right table. So we are retrieving the records from both the table A and B, where A is the left table, B is the right table. So we are getting all the details which is present in the left, but we are excluding the ones which is present in both the tables or ones which is having the matched rows. So consider for now we are performing the left join only. So how we'll perform it? Consider that this customer is the left table and the order is the right table. So in the left join, what happens is first it will return all the details which is present in the left table and then it will find any matching values. So consider that join condition customer.id is equal to order.id. So the condition is whenever customer.id is equal to order.id, perform the join operation. So the join table would be having all the values. So the first one would be ID, name, and then it would be ID and order name from the order table. So let's go to the very first row. So since it is a left join, we need to print all the details or all the information or all the rows which is present in the left table. So 101 RAM would be printed. Now it will find that is ID 101 present here? No, ID 101 is not present here. So we will fill null and null for it. Now we will go to ID 102. So is ID 102 present here? Yes, ID 102 is present here. So we will fill 102 Rahul and here we'll fill 102 with fruit. Now it will go to ID 103. So is ID 103 present here? Yes, ID 103 is present here. So it will print 103 Riti with 103 ball. So this was the result we used to get in the left join. But in left exclusive join, what happens is we are excluding the ones which are matching between both of these tables. So what are the fields which are matching between both of these tables? That is this 102 and 103. So 102 and 103 are matching between both of these tables. So we have to exclude this and we have to just print this in the final result. So how we can get this particular row? So here you can see that whenever there is no matching row which is present in the right table, we get the value as null as there is no matching field which is present there. So here what we will do is first we'll write the query for the left join. So we will write select and then we'll provide the columns which we want to show in the final result, then we'll provide from, and then we'll provide the left table name, then we will provide left join, and then we'll provide the right table name, then we'll provide the join condition. So table 1 dot column name is equal to table 2 dot column name, and then again we will provide the condition to exclude the matching rows. So the condition to exclude the matching rows can be where table 2.id is equal to null or where table 2.name is equal to null. So we can provide the condition where table 2.column name is null. So whenever we provide is null, it will only return me this row and it will eliminate all the matching rows, because whenever there is a matching row there wouldn't be any null value. When it would be a null value whenever we don't find any matching row. So that is why with the left join query we write a where condition which help us to remove the matched rows between left table and the right table. Now the second one is the right exclusive join. So whenever we retrieve records from the right table, excluding the ones which is matching both in the left as well as the right table. Now the query for the right exclusive join remains the same as the right join. It's just that we will again put a where condition, and now this time it will be table 1 dot column name is, because in right join we print all the details which is present in the right table and the matching which is present in the left table. So consider for 102 it find the matching data, for 103 it will find the matching data, but for 104 it won't find any matching data. So it will print 104 utensils null and null. So here table 1.id would be null, table 1.name would be null. So that is why here we have provided a condition table 1.column name is null. So the query is select, and then we provide columns, then we provide from, and then we provide the left table name, then we provide the right join keyword, then we provide the right table name, then we provide the join condition on table 1.column name equal to table 2.column name, and then we provide this where clause which will help me to eliminate the matching rows between these two tables. Now in the full exclusive join, whenever we retrieve records from the right table and the left table, excluding the ones matching in both left and right table, we get the full exclusive join. Now in full outer join, what we used to do is we combine the left join as well as the right join query using a union. So why we use union? Because in SQL there is no full outer join or full join. So we use union to combine the details of the left join as well as right join, which will give me a full outer join. And this union also makes sure that the matched rows between the left table and the right table doesn't occur twice. Because there could be a possibility that in the left join we are getting all the details of the left table along with the common row. In the right join we were getting all the details of the right table along with the commons one. So if we are doing a union of left join with right join, this particular area can occur twice. But union makes sure that this particular area doesn't occur twice. So first we'll provide the query for the left exclusive join, then we'll provide a union, and then we'll provide the query for the right exclusive join. So in this way we can get the full exclusive join. So let's see from the MySQL workbench that how this is happening. So we'll just work on the exclusive joins. So let me just write it. Exclusive joins. Now there are 3 exclusive joins. So the first one is left exclusive join. The second one is right exclusive join. And the third one is full exclusive join. So let's see first for the left exclusive join. So the query for the same would be select, and then we'll provide the columns name which we want to see. So for now we want to see all the columns, so we'll provide star, and then we'll provide from, and then we'll provide the left table name, that is customer, and then we'll provide left join, and then we'll provide the right table name, that is orders, and then we'll provide the condition on which we are joining. So on customer dot id is equal to orders dot id. So this is the query for the left join. So let's see that what this query returns, and then we'll see that how exclusive join is making a difference. So here we are getting all the details of the left table, and for the right table the details which were not existing is marked as null, and then we are getting the details of the values which are matching between the left table as well as the right table. So wherever id is matching between left table and right table, we are getting that details as well, and since it was a left join, we are getting all the details which were present in the left table. Now let's just add a condition. So we have to add a condition where table 2, that is orders dot id is null. So it will make sure that give me all the details where orders.id is null. So whenever there is no matching rows, we can see that the id is coming as null for the orders table. So it will return me the details of that particular person who doesn't have a matching rows in the right table. So let's just execute this query. So here you can see that we are getting only 2 entries where id is null for the orders or the right table. So basically it excludes all the matching rows which is present in the left as well as the right table. Now for the right join, the query would be select, and then we want to see all the columns, so select star, and then we'll provide from, and then we'll provide the left table name, that is customer, then we'll provide the right join, and then we'll provide the right table name, that is orders, and then we will provide the join condition where customer dot id is equal to orders dot id. Now this is the query for the right join. So let's see that what all things are returned here, and then we can see the difference between them. So let me just execute this query. So here you can see that we are getting 2, 3, 4, and here all the rows are matching in between both of the tables. So here we are getting 2, 3, 4, and the entry for 2, 3, 4 is also existing in the order table. So whenever we would be running the exclusive join, we won't be getting any data. Here all the IDs are matching in the right table. So let's see for the right exclusive join. So we'll provide a condition where table 1 dot column name is null. And we'll just remove this. So let me just execute this query. So as I told that we are not seeing any data because all of the data were matching in the left table. So since left table and right table both had all the common sets which were present in the right table, we are not seeing any data. Now let's just execute full exclusive join. So for full exclusive join, first we will use the left join, and then we'll perform a union between them, and then we'll provide the right join. Just remove this, and let's just execute this query. So here you can see that ultimately we are getting all the details of the left exclusive join only. We didn't got any data. So here we are getting 1, 5 Rahul Raj, and here the ID is null and the order name is null. So before moving to the union operator, let's just re-revise some older concepts where we were using the union operator. So what happens in the left join? Basically, if there are two tables, A and B, if A is the left table, B is the right table, in left join we used to get all the details which is present in A along with the details which is common between A and B, that is the common details between the left table and the right table. So let's name this area as C. So we used to get A plus C. Now in the right join, if there are two tables A and B where A is the left table and B is the right table, in the right join we used to get all the details which is present in the right table along with the common details which is present between the left and right table. So here it will be B plus C. Now in the full outer join, what used to happen, we used to get all the details which is present in the left table, all the details which is present in the right table, along with the common details which is present between the left as well as the right table. So here we used to get A plus B plus C. Now in SQL there is no full outer join keyword. There is a left join keyword, there is a right join keyword, but there is no full outer join keyword. So in that case we use the union operator. So for full outer join, what we did was we combined the left join and right join together using a union between them. So it combines all the result which is present in the left join along with all the results which is present in the right join. So this and this both were combined to get this. But if we perform a union between the left join as well as the right join, so the left join used to give us A plus C and the right join used to give us B plus C. So here we are getting A, here we are getting B, but here you can see that we are getting C twice. So that is what union is helpful for. Union basically gives us all the values, removing the duplicates, or you can say without the duplicates. So whenever we are performing union between any of two queries, it helps us to remove the duplicates or it helps us to eliminate the duplicates. So it will only print C once. So we get the result which we wanted for the full outer join. So union helps us to achieve results or achieve the combination of results between any two or three queries, and it helps us to remove the duplicates. So here if you can see, union operator in SQL is used to combine the result of two or more select queries into a single result set and give unique rows by removing the duplicate rows. So as I said, consider that if there are two queries Q1 and Q2, which are the select queries. So if we perform a union between these two queries, it will help me to give a single data set, and in that single data set there would be no duplicates. So duplicates won't be there. So there are some things which one should keep in mind while using the union operator. So the very first one is each select command within the union must retrieve the same number of columns. So consider that there are two queries Q1 and Q2 and we are performing a union between them. So if we are selecting some columns here to show in the final result, the number of columns which we are putting here should be the same in query 2 as well. So if we are giving one column here, consider select ID, here we should also give one column. The number of columns should always be same between the two select queries on which we are performing the union. Now the second is the data types of the column in corresponding positions across the select statement should match. So consider in this select statement we are selecting ID, and in this select statement also we are selecting ID. So both of the ID should have the same data type. There shouldn't be any mismatch of the data type, like this ID is a varchar or this ID is a int. We can't perform union in that case. So these columns which we are putting here to select or to see the result should always have the same data type. The third one is column should always be listed in the same order across the select statements. So since we have to maintain the data type, we have to always maintain the order, because if the order is not in sync, we may get the inappropriate or a wrong result, or we may get an error. So we have to always make sure that we maintain the order. We have to always make sure that the number of columns we are mentioning in the select queries on which we are performing union should be same, and we have to also make sure the data type of the column should also match with each other on the specific order. Now let's see that how this union operator works. So firstly we will give select, and then we will provide all the columns which we want to see the details, and then we will give from, and then we will provide the table 1 name, and then we will provide the union, and then we will give select, and then again we will give columns, and then we'll provide from, and then we will give the table 2 name. So basically there are two select queries. This is the first select query S1, this is the second select query S2, and we are performing a union between them, making sure that all the columns in S1 is equivalent to all the columns in S2, all the data types of the column matches from S1 to S2. So we are performing a union which will help me to give a single result set for these two select queries. So consider that this is the table 1 and this is the table 2, and between them we are performing a union. So table 1 is having a column such as ID, table 2 is also having a column ID, it is also holding integer values, and this is also holding integer values for now. So for the first query, if we execute select ID from table 1, so what it will do, it will give me all the IDs which is present in table 1. So it will print 1, so this is the final result. So it will print 1, then it will print 2, and then it will print 3. Now there is a union symbol, so basically all the things which we have got from here, or all the result which we have got from here, needs to be combined with the second select query. So the second select query says that we have to provide the column ID of the table 2. Now let's go to table 2. So here in the table 2 you can see the first row is 2, like the ID is 2, but 2 is already present in the final list, and what union does is union removes the duplicates. So this 2 won't be printed in the final result, it would be discarded because we have applied a union between these two queries. Now coming to the second row 3, so 3 is also printed in the final result and we don't need any duplicated values, so we will be discarding this as well. Now coming to 4, is 4 present in the final result? No, 4 is not present in the final result, so we can print 4. So this is the result we get after applying union on these two tables. So let's see from the MySQL workbench that how it is happening. So here we already have an econ database, and in that econ database we have a customer table, we have an orders table. So let's just first select and see that what all IDs are present in the customer and the orders table, and then we'll perform the union to see if duplicated values are being removed and if we are getting a combined data set. So let's just first see the ID which is present in the customer table. So we'll give select ID from customer, and let's just execute this query. So here you can see that we are getting the ID details. So it is 1, 2, 3, 4 and 5. So from the customer table, we are getting the IDs as 1, 2, 3, 4 and 5. Let's see the IDs which we are getting from the orders table. So we will write ID and then we will give from, and then we'll provide the table name, that is orders. So let's just execute this query as well. So here you can see that the IDs are 2, 3 and 4. So 2, 3 and 4 is something which is present in customers as well as orders table. So let's see that if we are getting the duplicated value in the final result or a unique value in the final result. So we'll just provide a union between them and we will execute the query. So I just need to remove this. So let's just execute this query. And here you can see that we are getting only the IDs 1, 2, 3, 4 and 5. So we are not getting any duplicates and we are getting the IDs which is present in the customer as well as the orders table. So like the union operator, we have a union all operator in SQL. So let's just understand that how this union all operator helps us. So union all operator in SQL is used to combine the results of 2 or more select queries into a single result set and give all the rows by not removing the duplicate rows. So in union, we used to combine the select queries and remove the duplicates. But in union all, we only combine the query. We don't remove any duplicates. So we don't take into consideration of any duplicates or something. So we just combine the query. But in union, we combine the query as well as we remove the duplicates. Now let's see the query on how we can use the union all operator. So firstly, we'll give select columns from table 1. So this particular query will help me to fetch some columns from the table 1. Then we'll give this union all operator. Then we will give select, then the columns from table 2. Now this particular query will help me to give all the columns which are mentioned here from table 2. And we are performing a union all operator between them. So this query 1 and query 2 will give me a combined result, but there would be duplicates since union all doesn't take care of the duplicates. So let's see from an example. So consider that this is table 1 and this is table 2. And we are performing a union all operator between them. So what will happen? For now, table 1 is having an ID column. Table 2 is also having an ID column. So we can perform a union all operator. So firstly, it will execute the query 1, which is for table 1, and then it will execute the query 2 followed by the union all operator. So firstly, the query for table 1 would be executed. So we want to see all the IDs which is in table 1. So firstly, 1 would be printed, then 2 would be printed, and then 3 would be printed. Then it will go to table 2. So the first ID in table 2 is 2, which is already present in the final result. But as I told that union all operator doesn't take cares about if there is something which is present here because it doesn't remove any duplicate. So 2 will again be printed. Then there is 3. 3 is also present in the final result, but it doesn't take care of the duplicates. It's just combined the results which is present in table 1 and table 2. So 3 will also be printed, and then there is 4 in table 2. So 4 will also be printed. So we print the data which is present in table 1 column as well as the data which is present in table 2 column without even considering of removing the duplicates. So duplicates can be there. So let's see from the MySQL workbench that how this union all operator is working. So here we already have the query for the union. So let's just copy the same and we will replace union with union all. And let's see that what we are getting in the final result. So here you can see that we are getting 1, 2, 3, 4, 5 and 2, 3, 4 is again coming even if it's like duplicated, but since we are using union all, in union all we can see the duplicate values. So what is this SQL subquery, inner query or nested query? So SQL subquery is a query which is nested within another SQL statement. So consider that there is a SQL statement Q1 and inside this Q1 there is one more query Q2 that is acting as an inner query. We call this particular query as subquery, which is helping me to perform operations on Q1 based on the data which we are receiving from Q2. So whenever we want to retrieve data based on the result of another query, we use the nested queries. So consider that Q2 give me a result R2 and based on R2 we are doing some filtration on Q1. So it is helping me as a subquery and it is helping me to give the details. Now why do we even need the subqueries? So consider that you are working in a company XYZ. Now companies told you that the average salary which we give to our employee is 1200. Now consider the next year company hire more 50 employees, right? So the average salary can either increase or decrease as well. Now do we need to calculate the average salary each and every year whenever a new employee is onboarded or whenever a set of employees is onboarded? We don't need to do that, right? So what we will do is we will write a query to find the average salary and then we can tell ki you can use this particular query anywhere where you want to find all the employees who is earning more than average salary, where you need to find all the employees name, employee details. You can use that particular subquery everywhere because that will give me the dynamic dynamic value or the value which is at present. It will give me the dynamic value. It won't take the value as 1200 as static value. It will give me the dynamic value. Whenever a new employee is onboarded, the value would be updated. So in the same way, we use the subquery because it helps me to get the dynamic value and it helps to update the data at the real time. So we don't need to update our query each and every time. We write a self-sufficient query like select average salary from XYZ. So what it will make sure is that whenever there is new employee which is added in our database, it will update the salary accordingly. The average salary, consider if earlier it was 1200, now it can be 1250. So it will be updated accordingly. Now here you can see a block diagram where I have given an outer query and inside this there is an inner query. So this inner query is Q2, this outer query is Q1. The result which we are getting from Q2 is R2 and based on R2 we are performing some logic in Q1. So in this way the nested query works. Now how we can use the subqueries? So subquery can be used in multiple ways. The very first way is subqueries can be used with clauses such as select, insert, update or delete to perform complex data retrieval. Now here you can see that we can use it with the clauses such as select, insert, update or delete. So let's see that how we can use. So here we have written the query. So we give select and then we provide columns and here we can provide a subquery which will help me to find another column in which there would be some manipulation which would be already done in the subquery and which I can show in the final result. And then I can give from and then I have to provide the table name from which we are fetching the data. Now let's see the another way in which we can use the subqueries. So subqueries can be used with where clause to filter data based on the condition. So we can use the where clause and we can filter the data based on some condition. So let's see the query. So here you can see it, we are giving select and here star basically means all. So it will give me all the columns which is present in the table. Then we will give from and then we'll provide the table name. Then we'll give the where clause. And here we provide the column name on which we are doing the manipulations or the filtration. Then we provide the operator like greater than, less than, equal to, in operator or other operators. And then we give the subquery. So this is the query 2 which gives me some result. And based on this result, we are performing some operation. So we'll see the example one by one for each of these ways. But for now, I'm just explaining that how we are using this in each way. Now the third way is subqueries can be also used in the from clause. So we can also use subquery inside the from clause. So let's see. So let's see the query. So here we are giving select and here we are giving star which basically selects all the column. Then we are providing from and inside this from we are using the subquery and then we are providing an alternate name for the result we are getting from the subquery as alternate name. So let's see from examples that how we can use the subqueries inside the select, from and where clauses. Now let's understand from example how we can use the subqueries using the where clause. So the very first problem statement is find all the employees who have salary greater than the minimum salary. So we have to find all the employees who is having salary which is greater than the minimum salary which is present in our table. So we have to break the problem into two steps. First is we have to find the minimum salary and then we have to find all the employees who is having salary greater than the minimum salary. So let's see first at how we can find the minimum salary. So first we'll give select and then we'll give an aggregate function minimum which will take all the values which is present inside the column and will return the minimum value. So we'll give the column name as salary and then we'll give from and then we'll provide the table name that is employee. So this will give me one result that would be the minimum salary among all the employees. Now the second query is to find all the employees having salary greater than the minimum salary. So this we have already calculated. Now we have to find all the employees who is having salary greater than the minimum salary. So we'll give the query select and then we want to show the employee name as well. So we'll give name and then we'll give salary and then we'll provide from and then we'll give employee and then we'll give the where condition where the salary which is given here is greater than the subquery which is this minimum salary. So here we can replace the subquery with the query which we have written here and we can get the salary which is greater than the minimum salary or you can say R2. So in this way we can find all the employees who is having salary greater than the minimum salary. So let's see from the MySQL workbench. So we have to find all the employees who is having salary greater than minimum salary. So we already have a company database and in that we have an employee table. So let's first see that what all details are there in the employee table. So here you can see we have ID, name, age, department, city and employee salary. So let's just find the employee salary which is greater than minimum salary. So firstly we'll find the minimum salary. So for that we'll give select and then we'll give the aggregate function min and then we'll provide the column name that is salary and then we'll give the table name that is from employee. So let's just execute this query and see that what it is giving. So it is giving me 1600 which is the minimum salary among all the salaries which is present in the table. Now let's find all the employees who is having salary greater than the minimum salary. So what we'll do is we'll give select and then we want to show the employee name and then the salary column and then we'll give the table name that is from employee and then we'll give the where clause and we'll give the condition where salary is greater than and here we will replace it with this subquery. So here we are getting the minimum salary as 1600 and here we'll replace it with this and we'll just execute this. So here you can see that we are getting the name and the salary. So is 2000 greater than 1600? Yes. Is 2500 greater than 1600? Yes. Is 2400 greater than 1600? Yes. So we are getting all the employees' name along with their salary who is having salary greater than the minimum salary. So let's see another example. Find all the employees who is having the minimum age. So we have to find the employees who is having the minimum age. So first what we will do is we will find the minimum age which is present in our table, and then we will compare that. Consider that if the minimum age is 18, is the employee having the age as 18? Is the employee having the age as 18? Is the employee having the age as 18? In the same we will see for all the rows, and we will show the details of employee who is having age as the minimum age. So firstly we will break the problem. So first we'll find the minimum age, and secondly we'll find the employee who is having the minimum age. So how we can find that? So first we need to find the minimum age. So to find the minimum age, we can give the query select min age from employee. So this will give me a minimum age, consider R2. Now I have to find all the employees who is having the minimum age. So I'll give the query select name, and I want to see the age as well. So age from employee, and here in the subquery I'll give where age is equal to the subquery. So it will be replaced by this query because this is giving me the minimum age. So it is giving me the result as R2. So it will be basically R2, and this subquery would be replaced by this. In this way, we can find all the employees who is having age as minimum age. So let's see from the MySQL workbench. So we have to find all the employees who is having their age as minimum age. So firstly, we will find the minimum age. So to find the minimum age, we'll give the query as select min, and we'll give age, and then we'll give the table name from employee. So let's just execute this query. So here you can see that we are getting the minimum age as 24. Now let's find all the employees who is having age as 24. So we will then calculate all the employees who is having age as minimum age. So we'll give the query as select name of the employee, age from table name is employee, and then we'll give the condition where age is equal to minimum age, and basically this query is helping me to find the minimum age. So I can replace the minimum age with this. So we'll give this, and we'll just execute this query. So there is only one employee who is having age as the minimum age. If there were 2 or 3 employees who were having the age as 24, that data would also be shown here. So let's understand from example of using subqueries in the from clause. So the first question is find the employees who is having age greater than minimum age. So earlier we were using the where clause, but here we will be using the subquery inside the from clause. So firstly we'll find the minimum age, and then we'll find all the employees who is having age greater than minimum age. So let's see how we can do that. So to find the minimum age, the query is select minimum age, and here we are providing an alias or an alternate name for the same, that is min age, and then we'll give from, and then we'll give the table name as employees. So in the second step, we have to find the employee which is having age greater as minimum age. So we'll give select, and then here we have used emp.name. So emp is basically a short name we have provided to this employee table, and we can use dot to select all the columns which is present here. So we can use emp.name, and then we can give from employee emp, and here we can replace it with the subquery, that is the minimum age. So we'll replace this subquery with this, and we can give it as subquery, and here we'll give where emp.age. So basically emp is the short name, so employee.age is greater than what we are getting from subquery, so subquery.minage. So here we are having minimum age, so we'll use subquery.minage, and here we are having age as the column, so we'll be using age. So from here we'll get the result as minimum age, and with a result consider R2, and here we'll use the result which we got from this query to do a filtration. So let's see from the MySQL workbench. So first we'll calculate the minimum age. So we can use the query as select minimum, and we can give it as age, and then we can provide an alias to use that particular result somewhere else also. So we'll give as, and then let's provide it a name as min age, and then we have to give the table name, so from employee. So let's just execute this query and see what it is giving us. So here you can see that we are getting a minimum age as 24. So here you can see that it is replaced by the alternate name which we have given, else it would show min age. So we have replaced it with an alternate name, that is minimum age. So let's find all the employees who is having age greater than the minimum age. So firstly we will use select, and then we'll give what we want to select. So firstly we want to show the name and the age, and then we'll use from, and then we'll give the table name, that is employee. So for now we are giving a short name for the employee table so that we don't have any confusion. So here we'll give a short name for employee, that is emp. Since we have provided a short name, we have to access the columns such as emp.name and emp.age. And then here I'll replace the minimum age from this subquery. So since I am also using this particular result in my from, so I have to use the subquery also. So I'll just use the subquery which will help me to find the minimum age. So I can also provide an alias for this as min age query. So I've selected emp.name, that is employee name, emp.age, that is employee age, from employee table, and here I've provided a short name for it. And we are also selecting minimum age. So we are giving from employee table as well as this particular table. And then I'll give the where condition. So where emp.age is greater than this min query dot minimum age query dot min age. So let me just explain this. So this particular would give me a result where there would be a minimum age and it would be the value which is the minimum among all the employees. Now this particular query, select emp.name will select the name, emp.age will select the name from the employee table only, because emp is the short name we have given to the employee table. And then we also want to make query in this particular table. So we'll give a comma and we'll give the query which will give me the minimum age of the employee, and I'll give an alias for this so that we don't have any confusion. So we'll provide an alias as minimum age query. Now we have given the condition where emp.age. So basically this table, in this table find all the age and see the other table, like this particular query give me a table with the name min age which is having one value. So check if employee.age is greater than minimum age query dot min age. So from this select the min age and check that if the employee age is greater than min age or not. So let's just execute this query. So here you can see that we are getting the name and age of all the employees who is having age greater than the minimum age. So the minimum age was 24. So everyone you can see is 25, 26, 27, 25. So all are having age greater than the minimum age. So let's understand from an example of using subqueries in the select statement. So we have to print the employees with average age and the age of all the employees. So we have to print the average age and age of all the employees. So basically in the final result we'll be getting something like this, where this would be replaced by the average age of this particular age column, consider it's 23, and here we have to give all the age of employees like 24, 25, and here it will be only 23. To compare that, if the age is 25, what is the average age in the entire employee table? So for this we'll again break it into two steps. The first is find the average age, the second is print the employee's age and the average age. So let's see how we can do that. So firstly we'll find the average age, that is select average age, and then we'll provide from, and then we'll provide the table name. So this will give me the average age of employee. Now we have to print the employee age along with the average age. So we'll give select, and then we will replace the subquery here because this is giving me the average age. So we'll give an alias as average age, and then we'll select age, and then we'll give from, and then we'll provide employee. So in this way we can print the average age as well as age for the employee. So firstly we'll find the average age. So for that we'll use select average, and then we can give age, and then we can give the table name from, and then we can give employee. So let's just execute this query. So here you can see that we are getting the average age as 25.4000. So now let's see all the employees who are having age and average age in the result. So we'll give select, then we are selecting age, then for average age we can replace it with this particular query. I know this might sound weird that why are we even using this, we can just give average age and we can provide an alias. So I'm just explaining that how we can use the select query inside the clauses, and there might be more complex problem where you'll get the gist that why we are even using subqueries and how it is helping us to make the problem simpler. So we'll select age, and then for the average age we'll replace it with this query, and we'll provide an alias for it as average age, and then we'll give from, and then we'll give the table name as employee. So let me just execute this query. So here we are getting age, and here we are getting average age of all the employees. So with the age we are getting the average age which is for the entire table. So in this way the SQL subquery works. You will see more complex problem where we are using the subquery concept, and it will help to break down that particular complex problem into simpler problems. Now, finding the nth highest salary of a person in a given data set, this question is like mostly asked in the interviews. It can be asked in the interviews of Amazon, Google, etc. Like this is the most asked question, and this is like one of the most important question as well. So let's find the steps that how we can find the nth highest salary, and then we'll see the query for the same. So here we have to find the nth highest salary in a given data set. Now n can be either 1, 2, 3 till any natural number n. Now if we are asked to calculate the first highest salary, so that we can do very easily. We can use the command as select, and then we can give max aggregate function, and then we can give salary, and then we can provide the table name from, consider employee table name. So this will give me the maximum salary or the first highest salary which is present in the employee table. But consider that someone asks you to find the second highest salary. In that case what you will do, you will just write the same query, select, then max, and then salary, and then you can give from, then the table name employee. Now this query will give you the first maximum salary or the first highest salary, but I want to find the second highest salary. So what I need to do is I need to eliminate the first highest salary, then the most maximum salary will be the second highest salary. So I'll just give a where condition where salary is not equal to. So this particular operator basically means not equal to, and then I can replace it with the first query. So this first query gives me the maximum salary, or you can say the first highest salary. So give me the maximum salary which is not equal to the first highest salary. So this will give me the second highest salary. Now consider you are being asked the third highest salary. So the query will get complex and complex. So we have found a query which can be very helpful to calculate the nth highest salary of a person, and that is a very simple query. You don't need to do this complex operation or make many subqueries. You can use that particular query and that will make your work easy. So let's see the steps to find the nth highest salary. So the step 1 is select the column which you want to show in the final result, that is salary. So you have to first select the column which you want to show in the final result. Now step 2 is order the salary in descending order. So you have to order the entire salary in the descending order. So the first highest appears at the first position, the second highest appears at the second position, the third highest appears at the third position, so that you can get the max at the first. Now step 3 is, now the value of n could be anything 1, 2, 3 till any natural number n. So we have to make the query in such a way so that whatever be the value of n, it can provide the accurate or the correct result. So the step 4 is, so at the end of the query we will provide a limit so that on the data set which we have got after ordering this particular salary in descending order, we can fetch the nth highest one. So first what we have done is we have selected the salary column to show in the final result. Then we have ordered the salary in the descending order. So the first highest comes at the first, the second highest comes at the second, the third highest comes at the third, and then we will use this limit clause which will help me to give the first highest, second highest or third highest. So let's see how we can use this. So firstly, let's discuss about the limit clause. So the limit clause is used to restrict the number of rows returned by a query. So whenever we want to restrict the number of rows which is returned by a query, we use the limit clause. Consider that we only want to see the details of top 3 students in a college or in a school. So we'll use the limit clause there, which will restrict it to only top 3 people. So here we have 2 types of limit. One is the variation of the limit clause. So first is limit and then we give n. So it helps to retrieve a maximum n number of rows from the beginning of the result set. So whenever we provide limit 3, so it will return the 3 rows from the beginning of the final result. Now there is one more, limit mn. So here m basically means the number of rows which we want to skip from the beginning, and n is the number of rows we want to fetch after the skipping. So consider if there are 5 rows, 1, 2, 3, 4, 5. So if I give the value of m as 2 and n as 1, so what it will do, it will skip the 2 rows, so it will not show 1, it will not show 2, and then n is the number of rows which we want to show in the final result, so it will only show 1 row. If the value of n would be 2, it would show 3 and 4 in the final result. If the value of n would be 3, it will show 3, 4 and 5 in the final result. So basically m is the number of rows we are skipping and n is the number of rows we are showing after the skipped ones. So limit mn helps us to retrieve a specific range of rows where m is the number of rows to skip and n is the number of rows to fetch. So basically it helps to give us a rows in a particular range. So let's see the query for the same. So firstly we'll give select, and then here we'll provide the distinct keyword, because there could be a possibility that there are 2 persons who are having the same salary, 1200 and 1200. So in that case that can give us incorrect result. So we'll provide the distinct keyword which will make sure that we are getting only distinct salary, and among that distinct salary or among that salaries which are unique, we are getting the nth highest salary. So we'll give distinct, and then we'll provide salary, and then we'll give from, and then we'll provide the table name. Then we'll provide the order by clause which will make sure to order all the salaries in the descending order. So we'll give the first highest salary in the first, second highest salary in the second, third highest salary in the third, and like this. Then we'll provide the limit clause, and then here we'll provide m and n. Basically m is the number of rows which needs to be skipped from the beginning, and n is the number of rows which we want to show after being skipped. So here the value of m is n minus 1 and the value of n is 1. So the value of n is 1 because we always want to get only one result or only the nth highest salary. So the value of n would always be 1. The value of m is n minus 1 because consider that we want to find the first highest salary. So in the first highest salary we don't need to skip any of the rows. So here if we give 1, 1 minus 1 is 0. So in that case we are not skipping any row and we are giving the first highest salary. Consider the value of n is 2. So here if we see m, that is n minus 1, so it will be 2 minus 1, that is 1. So it will skip the first row, and then the value of n is 1. So it will give me the second row, that is the second highest salary. So let's see from the MySQL workbench that how we can find the nth highest salary. So let's find the fourth highest salary. So we'll find the fourth highest salary. So for that we'll write the query as select, and then we'll give distinct, and then we'll give salary, and then we will provide the table name, that is from, and then we'll provide employee, and then we'll provide this order by clause to order them, then the column which we want to order, that is salary, and then the manner in which we want to order, that is descending. So firstly let's see that what is the result of this, and then we will calculate the nth highest or the fourth highest salary. So let me just execute this. So here you can see that we are getting the salary as 2500, 2400, 2000 and 1500. So we are getting all the distinct salary. There is no duplicates, and we are getting the salary in the descending order. Now let's just calculate the fourth highest salary. So we will give limit. So first is n minus 1. So 4 minus 1 is 3, and then n is 1. So we'll give 1, and we will just execute this query. So here you can see that we are getting the fourth highest salary as 1500. So in this way, we can calculate the nth highest salary. You can replace the number n with any of the natural number you are being asked to. And this is the most simple query which you can use and get the result. Now, as the word suggests, stored procedure. So whenever we are storing some kind of a query in a procedure, we call it a stored procedure. So let's see. These are the programs that can perform specific tasks based on the stored query. So you might have heard about functions in programming. So how these functions were useful? Consider that if we want to find minimum age of a person, we used to create a function, give the function name and write all the logic inside that function. And wherever in our code we require to find the minimum age, we can reuse this particular function. In the same way, we create a stored procedure. We give that stored procedure a name, and then inside that we write a query, and wherever we want to use that query, we can use this procedure name. So it is basically a collection of pre-written SQL statements grouped together under a specific name. So procedures can be created in two types. One is when we are passing some params in the procedure, and one when we are not passing any params in the procedure, that is parameters are empty. So let's see the query and how we can create a procedure. So we give create, and then we give the procedure keyword, then we provide the procedure name, and if there are any params we can provide, else we can leave it empty. Then we give this begin, which tells that now the query is beginning, and then we provide the query, and then we provide this end, which basically tells now the query has ended. Now the procedure with the name procedure name is created. Now whenever we need to call this, we can use this particular query, that is call, and then we give the procedure name, and then we terminate it. So basically call can be used to call the procedure, and create procedure can be used to create a procedure. So let's see an example where we are using a stored procedure without params. So here we are trying to create a procedure where we get all the order details. So we'll give create, and then we'll give procedure, and then we'll give the procedure name. If there are any params, we'll provide, but since it is without params, so we'll leave it as empty. Then we'll give begin, and then we'll provide the query, that is select star from orders, which will give me the entire order details. And then we'll provide end. And then to call the procedure, we will use this call, and then we'll provide the procedure name followed by the termination. So in this way, we can call the procedure, and in this way, we can create a procedure. So let's see from the MySQL workbench. So first we will create a procedure to get all order details. So let's create. So we'll give create procedure, and then we'll give the procedure name get order details. And since there are no params, we'll leave it as it is. Then we'll give begin to tell the query is beginning. Then we'll provide the query, that is select star from orders, and then we will give this end to tell the query has ended. Now here you can see that we are getting some errors. So what could be the reason behind it? So if you remember that whenever we write any SQL query, if we want to terminate the query, we give this particular symbol. Now here what it is happening is we have provided the query and we have terminated it here only. So it is treating this particular thing as a query. So this begin is not able to find end because it has been terminated here only. So what we do in this case is we provide a delimiter. So what delimiter does is whenever we provide delimiter with any symbol, it considers that symbols as a form of termination, and it will not consider this particular symbol as a termination. So that will remove my error. So let's use this delimiter, delimiter, and then we'll provide a symbol as a delimiter. For now, I've provided this symbol as a delimiter. So here you can see that the error has gone. But since I've provided this symbol as delimiter, it will not consider here also termination. It will not consider here also termination. So what I'll do is I'll just remove this termination here, and I'll just provide this delimiter. So for now, it is treating this entire query as a single query. Now, since we have changed the delimiter, there could be a possibility that in the further queries, we have to provide this only. So we'll just change the delimiter back to normal once the query is done. So we'll just give this as the delimiter. So now the delimiter is changed as back to normal. So let's just execute this query. So here you can see that we have got a success. Now we want to see that if that particular procedure is created and what all details we are getting. So we'll just use call, and then we'll give the procedure name. And if there are any params, we'll provide, else we'll leave this as empty. So let's just call this. So here you can see that I am getting the ID and the order name. Basically all the details which were present in the order table I am getting here. So in this way we can create a procedure, and in this way we can call the procedure. So let's see another example where we want to return the details of order by ID. Now this is an example of stored procedure with params. So the query for the same is we give create, then we give procedure, then we provide the procedure name, and then we give the column name, and then we provide the data type. Now we give begin, then we provide the query select star from orders where ID is equal to the ID which is provided here, and then we provide this end keyword. And to call this, we basically use this call, and then we provide the procedure name, and then we provide the ID for which we are searching. So what is views in SQL? A view is a virtual table in SQL. So consider that there is an employee table. Now this employee table is having details such as employee ID, employee password, employee name, employee address. Now there are some people of the company who is making ID card for each and every employee. So should we give the access to that particular people to access this employee table? Because this is also having employee password. So this is a data breach, right? So we can't provide the access for this employee table to the people who are creating the ID card. So in this case, what we do is we give a view of this particular table. So in this view, we provide ID and name along with address, which is needed to create the ID card. But password is something which is not needed to create the ID card, and also it is a secure data. So we can't provide access or authorization for this particular table. What we do is we create a view, and the people who are creating ID card can now use this particular table. It is a virtual table, so can use this particular table to fetch the information and create the ID card. So it helps in providing a filtered view of data for security purpose. So let's see how we can create a view. So we give this create, and then we give view, then we provide the view name, and then we provide an alias, and here we provide all the columns from the base table which we want to show in the view. So it basically specifies the columns which should be included in the view. So it helps in data abstraction, security, and simplifying the complex queries. So if we are having a view table, if we don't need some of the columns, so we can just have a view table and we can do any kind of manipulation on that particular view table. It is also helping in data abstraction because it is hiding the password from the ID people, and it is also helping in the security purpose. So since view is just like a virtual table, so all the things which we perform on table can be performed on views. So to see all the data in the view, we give select star from view name, and to delete the view, we give drop view, and then we check that if this exists or not, and then we provide the view name. So all the things which we are performing on a table, we can perform on the views also. So let's see from the MySQL workbench that how we can create a view and how it can be used. So let's just create a view. So we'll create view, and we'll give the name as employee view, and then we'll provide an alias. So we'll provide as, and then we'll give the details which we want to show in the view table. So first is ID, second is name, and third is city, and then we'll give from, and then we'll give the table name, that is employee. So here you can see we are getting a success. Now the view is created. Now on this employee view, we can perform any operation. So consider that I want to see the details of employee ID. So I'll use this employee view table. So I'll give select ID, and then I'll use from, and then I'll use this table name, that is employee view. So let me just execute this query. So here you can see that I'm getting the ID details. So view has basically reduced the size of my table, and also it has only the valid details which is needed for the ID card department to create that ID card. So this was all about views in this particular video. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.